Hi everyone, welcome to PrepFusion. So this is going to be our marathon 2 on the random variables. Okay, so first marathon we have already watched. So in this marathon we will see some standard PDFs and we will see how to transform a random variable from one random variable to another random variable. We will study about central limit theorem and a lot of miscellaneous concepts we are going to see. A lot of miscellaneous concepts, at least 3 to 4 miscellaneous concepts will be there that we will see, and a lot of problems also we are going to solve. So this will be our second marathon, and here our random variable will end. Next marathon will be on random process. Okay, so yeah, you can start watching this video. So first you will watch this video, random variable 1, this marathon only. First you will watch this marathon and then only you will come here. Okay, so first watch this particular marathon and then only you start with the random variable 2. Okay, and here we targeted 10k views, but 2.4k views are there. So okay, it is a bit disappointing, but yeah, it is fine. So what I would expect from you is that you can share with your friends, you can share with the people around you. You will, like, you see the content, you see the quality, and then you try to share it. So I'm pretty sure that you will love the quality. That's 100% promise from my side. So here we are targeting 5k views and 250 likes. This is not as like this is not a obligation. This is just a expectation from my side. Random process will surely come on YouTube. This is my promise. No matter whether this video gets 1 views, 2 views, whatever views it gets, random process will surely be on YouTube. Okay, so next marathon will be based on random process. So here random variable will end. So now you can get started with the video. Thank you very much. Yeah, welcome back. So now we are going to study about some standard type of distribution. And first we will study uniform distribution. So what will be given in the question, that your continuous random variable x is uniformly distributed between a and b. This is what is given in the question. Your random variable x is uniformly distributed between a and b. That means between, like, x will take values from a to b. X will take the value from a to b, and in between a to b it will give you a constant value of PDF. Your PDF will have a constant value. Your PDF will have a constant value. So at all the point the PDF will have a constant value. Does that mean that probability is same at all the point? What if, let's just say, this point is alpha? What if I ask you probability such that x is taking, probability such that your random variable x is taking value alpha? What will be the answer? K. No, that would be 0. No, in case of continuous random variable, probability at a point is 0. But if you are asking me fx of x equals to k, sorry, fx of x equals to alpha, that what is the value of your PDF at x equals to alpha? That value is k only. So uniform distribution means the value of your PDF, the value of your probability density function, that is constant between a to b. Is that okay for you? So that's why the name is uniform distribution. Now can you let me know what will be the value of this constant k? Yes, I can surely let you know what will be the value of this constant k, because I know that this particular thing should throw 1. So what is the area of this particular thing? This is like a rectangle, right? So k into b minus a, total area is k into b minus a, that is equals to 1. So k is equals to 1 upon b minus a, right? So basically your fx of x is 1 upon b minus a, where your x is going from a to b and it is 0 otherwise. So if only this particular thing is given, if only this thing is given, then you should be able to understand all these things on your own. You should be able to make all these things on your own. That your random variable x is uniformly distributed between a to b, uniformly distributed between a to b. So amplitude also you should be able to write down. Whatever the length you see here, what is this length? This length is b minus a. Whatever the length you see here, 1 by this length would be your 1 by this length would be your value of k. So 1 upon b minus a. So it would be equals to 1 upon b minus a between minus a to b, otherwise it will be 0. All good, all fine, very simple thing. Can you make its CDF? What you are making? This is your PDF, right? From PDF to CDF you need to go. So what is the path do you follow? Your capital fx of x would be equals to what? Minus infinity to x fq of q dq, right? So basically you need to integrate this particular graph. You need to integrate this particular graph. So do you know how to integrate? You should know how to integrate. So till a everything is 0. Integration of 0 is 0 only. After that what is happening? there is a sudden jump of 1 upon b minus a. So there will be a slope of 1 upon b minus a. So there will be a slope of 1 upon b minus a. And after that there is a decay of 1 upon b minus a. So whatever the slope was there, slope was 1 upon b minus a. 1 upon b minus a. So now whatever the slope was there, that will lose its slope. That means now the slope would become 0. So basically simple integration is there. If you have studied your signals and system, then you would be able to do this integration very simply. Very simple integration it is. This point is b. So initially 1 upon b minus a slope, and then slope becomes 0. 1 upon b minus a, then slope becomes 0. So what is the slope here? Slope here is 1 upon b minus a. So if this slope is 1 upon b minus a, what will be this amplitude? This will be 1, right? Because this length is b minus a. Basically, let's just say this length is y. So y upon b minus a is equals to slope. So y is coming out to be 1, and it is pretty obvious as well, because fx of infinity should be equals to 1 only, and we are getting it 1. So you should be able to know how to integrate. So if your PDF is given, you know how to find out the CDF. Well and good. Let's try finding the statistical parameter. So first we will find mean of random variable x. What we are finding? Mean of this random variable. So mean of this random variable x, that will be equivalent to minus infinity to infinity x into fx of x dot dx. So it is non-zero between a to b. It is non-zero between a to b. X into, what is the value of fx of x? The value of fx of x is 1 upon b minus a dot dx. So 1 upon b minus a goes outside, x square by 2 a to b. So 1 upon 2 into b minus a into b square minus a square. So how will you open it up? B minus a into b plus a, right? How will you open it up? B minus a into b plus a. So this will be opened as b minus a into b plus a. And here you can see that this b minus a and b minus a is getting cancelled. So expectation of x is coming out to be a plus b by 2. So this is your expectation of x. Okay, a plus b by 2. So right in the middle of this, let's just say this was minus 1, and let's just say this was 4. So first let me know what will be the value of this k. This width is 5, so upper width should be 1 by 5. So value of k would have been 1 by 5. And what if I ask you what is the mean? So mean will be 4 minus 1 divided by 2. This addition with this divided by 2. So mean will be 3 by 2, which is 1.5. So mean will be 1.5. Okay. So expectation of x is a plus b by 2. Well and good. This you should be remembering. What about mean square value? So mean square value we will find out, but you don't need to remember it. Whatever the answer we get, you don't need to remember it. So mean square value we will find it out. So what we need to do? X square fx of x dot dx. What is fx of x? 1 upon b minus a. And it is non-zero between a to b. Right? So 1 upon b minus a. X cube by 3. A to b. So that is coming out to be 1 by 3 into 1 upon b minus a, b cube minus a cube. So do you know the formula of b cube minus a cube? B minus a into b square plus ab, right? So this formula I am going to apply now. B minus a into b square plus a square plus ab. So what you are getting? Basically your expectation of x square is coming out to be, just 1 second guys, yeah, so it is coming out to be a square plus b square plus ab divided by 3. So this is your expectation of x square, which you don't need to remember. So I am not putting it in a box. Okay. But variance answer, whatever the answer of variance you will be getting, that you need to remember. So what is your variance? That is your expectation of x square minus expectation of x whole square. Right. So expectation of x square is a square plus b square plus ab divided by 3. Minus, what was your expectation of x? That was a plus b divided by 2. So what you will do, a plus b divided by 2, and you need to do the square as well. So a square plus b square plus 2ab divided by 2. So this will become 4. So what is the LCM? LCM is 12. So 4a square plus 4b square plus 4ab minus 3a square minus 3b square minus 6ab. So what you are getting? A square plus b square minus 2ab divided by 12. So that can be written as b minus a whole square divided by 12. So what you are getting? Sigma x square is coming out to be b minus a whole square divided by 12. Should be remembered. Okay, should be there in your mind. So your variance is b minus a whole square divided by 12. And if someone asks you what is the expectation, so expectation is a plus b divided by 2. This is the expectation. So these two things are there, variance and expectation. Expectation is a plus b divided by 2 and variance is b minus a whole square divided by 12. So let's just say if I say my my random variable x is a uniform random variable which is uniformly distributed between minus 2 to 3. Now if I ask you what will be my expectation, so what you will do, you will add both of them divided by 2. So expectation of random variable x will be 1 by 2. And if I ask you what will be my variance, so what you will do, you will see the width. What is the width? 3 minus minus 2. So total width is 5. Do the square divided by 12. So 25 by 12, that will be the variance. And if I ask you the mean square value, then you will calculate the mean, you will calculate the variance, and from there you can find out the mean square value as well. Is that okay for you? Well and good. So we will surely solve a question. So as of now, in this particular lecture, what you have studied, so there is something called uniform random variable. That means it will be uniformly distributed between two values. Those two values will be given. From that you should know what will be the magnitude of your fx of x. That magnitude will be uniform between a to b. Otherwise the magnitude will be 0. Amplitude will be 0. Otherwise the amplitude will be 0. And how to find out this particular amplitude? That would be simply the 1 upon of your width. So whatever the width you get from here, 1 upon that width will be the amplitude of this your PDF. From PDF to CDF you know how to get, just by simply integrating you will get the CDF. Mean of random variable x is coming out to be a plus b by 2, and variance of random variable x is coming out to be b minus a whole square. That means width whole square divided by 12. Width whole square divided by 12. Right? Now what if your PDF is symmetric about the origin? What is the meaning of that? Symmetric about origin means your random variable x should be uniformly distributed between minus alpha to plus alpha. That means it is symmetric about the origin. Okay? Minus alpha to plus alpha. Uniformly distributed between minus alpha to plus alpha. Right? And what is the amplitude? 1 by 2 alpha. Very simple. Because what is the width here? This width is 2 alpha. If you want to make the whole area equals to 1, if you want to make the whole area equals to 1, that means this has to be 1 by 2 alpha. Because 1 by 2 alpha into 2 alpha will be 1 only. Right? So the amplitude is 1 by 2 alpha. What do you think? What will be the mean? Do you remember the formula of mean? Yes. A plus b divided by 2. So minus alpha plus alpha divided by 2. 0. So always mean is the middle point. In case of uniform random variable, mean is the middle point. Here also it is the middle point only, no? A plus b divided by 2. Middle point. A plus b divided by 2. And here also it is the middle point. Minus alpha, alpha. What is the middle point? 0. So mean of random variable x is 0. And what about the variance? What is the variance? Variance formula was b minus a whole square divided by 12. So total width. What is the total width? 2 alpha. 2 alpha whole square divided by 12. So 4 alpha square. So basically you will be getting alpha square by 3. So this is the variance. So for a PDF, for a uniform random variable, for a uniform PDF which is symmetric about origin, the mean is 0 and the variance is alpha square by 3. Okay, you don't need to remember it, you will be able to derive it very easily. Very easily you will be able to derive it. You don't need to mug it up, right? You don't need to mug it up. Well and good. Now x is a random variable which is uniformly distributed between -2 to 3. You need to find the mean square value and variance. So what we know, we remember the formula of mean. What is the formula of mean? Formula of mean is b plus a. Basically this is the value of your a, this is the value of your b. So for finding the mean, I just need to find the middle point. So what will be our middle point? Middle point will be b plus a divided by 2. So answer is 0.5. What I need to find? Variance. So what is the formula of variance? Whatever the width is there, what is the width is there? Width is 5, right? Width is 5, no? 3 minus 2, so width is 5. So width square b minus a whole square divided by 12. So what is the answer? 25 by 12. And what they are asking now? Mean square value. So mean square value is given as sigma x square plus mean square. Square of mean. Variance plus square of mean. AC power plus DC power. So what is the AC power? 25 by 12. What is the DC power? 1 by 4. 28 by 12. This is the answer you are getting. Okay, very simple thing, very straightforward. Uniform random variable is very straightforward, right? Now x is a random variable. X is a function of another random variable theta. Okay, x is also a random variable, theta is also a random variable. X is also a random variable and theta is also a random variable. Now about theta, what is given? That random variable theta is uniformly distributed between 0 to 2 pi. Random variable theta is uniformly distributed between 0 to 2 pi. So if this information is given, can you draw f theta of theta? If this particular information is given that it is uniformly distributed between 0 to 2 pi, so can you draw f theta of theta? Surely you can draw. Between 0 to 2 pi, it is uniformly distributed between 0 to 2 pi. Uniformly distributed between 0 to 2 pi. So what is the width? Width is 2 pi. So here what should be the height? 1 by 2 pi. So 1 by 2 pi into 2 pi, what will be the area you will be getting? That is 1. So you need to find the variance of x. What you need to find? You need to find variance of random variable x. So I need to find variance of a random variable x. So that would be equals to expectation of x square minus expectation of x whole square. But you are not given the PDF of theta. Sorry, you are not given the PDF of a random variable x. You are given the PDF of theta, not the random variable x. So what you will do? First, let's try finding expectation of x square. So expectation of x square would be equals to, there is a relation between x and theta. So what you will be getting? X would be equals to, sorry, x square would be equals to 9 cos square theta. 9 cos square theta, right? So 9 should be outside, e into cos square theta. Say yes or no. Is that okay for you? Expectation of x square I am finding. I am not having the PDF of x. So what I need to do? X is 3 cos theta. So 9 cos square theta. Why I am doing so? Because I am having the PDF of theta. If you are having the PDF of theta, then your job will be done now. 9. Expectation of cos square theta you need to find. Expectation of cos square theta. So what you will do? Whatever that is inside, that you write down dot d theta. Whatever that is inside. Now this is a function of theta, so you would require the PDF of theta as well. All good, all fine. So 9 going from 0 to 2 pi. F theta of theta going from 0 to 2 pi. Cos square theta. What is the magnitude of f theta of theta? That is 1 by 2 pi. 1 by 2 pi. 1 by 2 pi. Dot d theta. So 9 by 2 pi. 9 by 2 pi. Integrating 0 to 2 pi. 9 by 2 pi integrating 0 to 2 pi. 1 plus cos 2 theta divided by 2 d theta, right? So what is the answer you will be getting? 9 by 2. You can solve this integration. If you solve this integration, what you will be getting? If I solve this integration, 9 by 2 pi. So here this will throw 0, 1 by 2 and 2 pi. So basically I will be getting 2 pi by 2. You can solve this integration, okay? 1 by 2 into theta plus 0. This is what I will be getting. And limit of theta is going from 0 to 2 pi. So 2 pi by 2 you will be getting. So from here you can see that 9 by 2 will be the answer. Did you understand this point? Expectation of x square I needed to find. X is a function of cos theta. So 9 cos square theta, 9 goes outside. Cos square theta, f theta dot d theta I can write down because this is the function of theta now. Now f theta of theta I am already having, which is 1 by 2 pi between 0 to 2 pi. So I just need to integrate now. So that integration I will get as 1 by 2 into 2 pi. So 1 by 2 into 2 pi I was getting. So 9 by 2 is my answer. So expectation of x square is coming out to be 9 by 2. Okay. Now I need to find expectation of x. So what I need to find? Expectation of x. Again I am not having the PDF of random variable x, right? So but I know that x is equals to 3 cos theta. X is equals to 3 cos theta, right? X is equals to 3 cos theta. So now what I can do, whatever that is inside, write it down in a smaller manner. Now this is a function of theta, so you would require the PDF of theta as well. F theta of theta is non-zero between 0 to 2 pi into 3 cos theta divided by, what is the value? 2 pi. Now if you integrate it from 0 to 2 pi, what will be the answer? Cos theta 0 to 2 pi. 0, this point is pi, this point is 2 pi. So whatever the positive area is there, the same negative area is there. Basically for one cycle you are integrating your cos. What will be the answer? 0 only, no? So you can integrate this particular thing, very simple. Your answer will be 0. So expectation of x is coming out to be 0. So expectation of x is 0. Expectation of x square was 9 by 2. So what they are asking? Variance. So variance would be equals to expectation of x square minus expectation of x whole square. So variance would simply be expectation of x square, which is 9 by 2. Very simple, right? Very straightforward. Just follow the process, whatever that has been told to you, just follow that particular process and your answer will be done. Very simple thing, very straightforward. Next we need to study about Gaussian distribution, or you can call it normal distribution. So what will be given? That x is a Gaussian random variable. What will be given? X is a Gaussian random variable. Gaussian random variable with normal distribution. Because of normal distribution you use the sign n. Here what was the sign you were using? You are using the sign u, uniform distribution. So here because of the normal distribution you use the sign n. So x is a Gaussian random variable having mu x mean and sigma x square variance. So here in the bracket whatever that is written, first value will be mean, second will be variance. If somewhere it is written that x is 2, 3, what does that mean? That expectation of x is 2 and variance of x is 3. And type of random variable is Gaussian. Type of distribution is Gaussian. So it is a Gaussian random variable with 2 mean and 3 variance. So mean and variance would be written in the bracket of n. Okay. Now what is the distribution? So here what was your fx of x? Fx of x was 1 upon b minus a, right? 1 upon b minus a from a to b, not minus a to b. 1 upon b minus a from a to b. It was 1 upon b minus a. So here what it will be? It will be 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square. E to the power x minus mu x whole square and then divided in the e to the power only. Basically it is being divided in the e to the power only, divided by 2 sigma x square. Are you able to understand this point? 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square 2 sigma x square. So this is your fx of x. This is your fx of x. Sir, do we need to remember it? You need to remember it. This is the mean, mu x is the mean and sigma x square is the variance. Basically, mean is mu x and variance is sigma x square. Okay, we need to remember it anyhow. So what will be the amplitude at x equals to mu x? What I am asking, I am drawing the graph of fx of x. So at x equals to mu x, what you will be getting? X equals to mu x. So if you put mu x here, what it will be there? It will become 0. So e to the power 0 is 1. So at x equals to mu x, let's just say mu x is here. Let's just say this is your mu x. So at x equals to mu x, your amplitude will be 1 upon under root 2 pi 1 upon under root 2 pi sigma x square. So this completely is there in the under root, okay? So at x equals to mu x, the amplitude is 1 upon under root 2 pi sigma x square. And what will be the magnitude or what will be the amplitude at x equals to infinity? What I am asking, fx of x equals to infinity. If you put x equals to infinity here, what will happen? Whatever the amplitude is there, I don't care. E to the power minus x equals to infinity square. Whatever that is there downward, I also don't care about that. Basically, it is becoming e to the power minus infinity. What that would be? 0. And similarly, what will happen for fx equals to minus infinity? So e to the power minus infinity whole square divided by 2 sigma x square. So e to the power minus infinity square, that would be infinity square only, divided by 2 sigma x square. So that would be equals to 0. So at plus infinity and minus infinity, at both of the part, it is 0 only. So basically what is happening? At this particular point, it is the maximum. At x equals to mu x, it is maximum, and after that, so this is how the graph will go. This kind of a graph you will be getting. So this is your normal distribution. Okay, and you can calculate this particular thing, minus infinity to infinity, fx of x dot dx. It will surely come out to be 1 only. If I say one thing, that sir, minus infinity to infinity e to the power minus x square dot dx is equals to under root pi. Do you agree to this point? Right? You agree to this point. Now if I ask you minus infinity to infinity e to the power minus x minus 2 square dot dx, what will be the answer of this? Under root pi only, no? In place of x, I am putting x minus 2. So x minus 2, if you put equals to t, what you will be getting? Dx equals to dt. Limit will also be from minus infinity to infinity. So eventually you will be getting e to the power minus t square dot dt, which is equals to under root pi only. So you are just shifting the graph. You just shifted the graph. Here the here the maximum amplitude was at x equals to 0. But now here the maximum amplitude will be at x equals to 2. If you put x equals to 0 here, what you will be getting? 1. If I put x equals to 2 here, what I will be getting? 1. So basically, previously the graph was some e to the power minus x square. The graph was like this, e to the power minus x square. But e to the power minus x minus 2 whole square, the graph would be like this. Nothing else. The area under the curve does not change. The area under the curve is not changing. Area under the curve is still under root pi. So this is still under root pi, right? So just think about it, what it will throw. Just think about it. Will it throw 1 or not? Will this particular thing throw 1 or not? So let me know. What I need to do? Minus infinity to infinity. This is a constant amplitude, 1 upon under root 2 pi. Sigma x square is a constant value. Variance will be a constant value, right? Here variance is coming out to be a constant value. Always variance will come out to be a constant value. Here I am putting x just to show that it is the variance of random variable x. Variance of random variable x. That's why I am putting sigma x square. So all this thing is a constant part. So all this thing is a constant part, right? E to the power minus x minus mu x whole square divided by 2 sigma square dot dx. Now you know that e to the power minus x square dot dx will throw under root pi integration. Now x minus mu x whole square e to the power x minus mu x whole square dot dx, what it will throw? It will also throw under root pi only, right? Just it is shifted, just the graph is shifted to mu x, nothing else. So it will also throw under root pi only. But if I divide it by 2 sigma x square, so I told you one thing, e to the power minus x square by 2 will throw under root pi, whatever that you see downward, take it in the under root. So what it will throw? 1 upon under root 2 pi sigma x square is already there. So e to the power minus x minus mu x will be throwing pi, but whatever you see downward, take it in the under root. So 2 sigma x square pi, 2 sigma x square pi, this and this get cancelled out. What is the answer you are getting? 1 only. So yes, it is a PDF, it has to throw the total area equals to 1 only. So yes, the total area was 1. So I don't think it will be too tough to remember. Do you remember the Q function? Do you remember the Q function? What was your Q function? 1 upon under root 2 pi going from x to infinity e to the power minus x square by 2 dot dx. Here there is no integration. This is simply fx of x. So 1 upon under root 2 pi sigma x square e to the power minus x minus mu x. Basically center is moved to mu x. So x minus mu x whole square divided by 2 sigma x square. Here basically let's just say sigma x square was 1. Here if I say sigma x square was 1, sigma x square was 1 and mu x was 0. So kind of you are getting the same expression. No? If I say mu x was 0, if I put mu x equals to 0, what I will be getting? E to the power minus x square divided by 2 sigma x square is 1. So this expression I will be getting. And 1 upon under root 2 pi sigma x square is 1. So 1 upon under root 2 pi. But here there is an integration. This function is defined with respect to integration. But this is not defined with respect to integration. This is simply fx of x 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square. This is something should be there in your mind. Is that clear to you? Okay. So a lot of things I have written down here. So let me adjust it. Let me adjust in a good manner. Otherwise, this is not looking good. So this is the graph. This is the calculation that we have done. 1 upon under root 2 pi sigma x square, right? And area, total area I calculated, that is coming out to be 1 only. Now mean square value and variance. We already know everything, right? This will be the mean. Basically, how do I calculate the mean? Expectation of x would be equals to minus infinity to infinity. Here x goes from minus infinity to infinity, right? X is going from minus infinity to plus infinity. X into fx dot dx minus infinity to infinity x. What is your fx? 1 upon under root 2 pi sigma x square. So 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square dot dx. Now this integration will become very difficult. But when you solve this integration, answer would come out to be mu x. Basically this answer will come out. So that's why in the expression itself we write down in a manner that from expression only we can get to know what is my mean and what is my variance. So this is how we define our Gaussian random variable or our normal distribution. What will be given? X is a Gaussian random variable having mu x mean and sigma x square variance. If it is written like 2, 3, that means mean is 2 and variance is 3. So the way function is defined, from the function itself we can get to know that what is my mean. That is coming out to be mu x. It is not that easy to solve this particular integration, right? First you will have to put x minus mu x equals to t. Then you will convert it into t square divided by 2 sigma x square dot dt. In that manner you will convert, and then what you will do? You will put t square divided by 2 sigma x square equals to alpha. From there you will cancel out this particular thing and then you will get the answer. It will come out to be mu x only. You can do the integration when you study mathematics. At that time you can do the integration. Your answer will come out to be mu x. Okay. What do you think? What will be your mean square value? First, let's talk about the variance, or let's talk about the mean square value. So, what will be my mean square value? So, this integration I need to perform. Here it was x, now it is x square. So, it will become more tougher, right? It will be tougher to solve this integration. But again and again, you keep on writing the expression 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square dot dx. Okay, so you again and again keep on writing it so that it becomes habitual for you. So what will be your answer? What do you think? What should be the answer? You know that what will be my variance? What do you think? What will be your variance? So variance is already I know that will be sigma x square. This will be my variance. This will be my variance. So when you solve this particular integration, the answer came out to be sigma x square plus mu x square. This is what the answer came out to be. And it is pretty obvious, no? Because you know that sigma x square should be equals to expectation of x square minus expectation of x whole square. So expectation of x square, which is known as mean square value, should come out to be sigma x square plus what is this, mu x whole square. So from the expression itself, you will never have to solve the integration. From the expression itself, you will be able to see a lot of good things. Okay, so remembering the expression is very, very important. All good, all fine. So now we will solve some questions. This you already know. I am just asking, you need to find this particular thing. This I have already told you. X minus 2 you will put equals to t. What you will do? X minus 2 is equals to t. So dx would be equals to dt. So integration limit will go from minus infinity to infinity, e to the power minus t square dot dt. That will come out to be under root pi only. So basically just for shifting the graph, your area will not change. You just have shifted the graph. Area will not change. Right? Very simple question. What about this one? What do you think? What will be the answer of I? Think about it. Think about it. Take your time. Try thinking. Whatever you are able to think, it's fine. If you are not able to think, then also it is fine. Okay. What is the meaning of this exp? Exp means exponential to the power. Basically, exp means exponential to the power minus x minus 2 whole square divided by 4. So think about it, do something and try getting the answer of I. I will take a break and then I will come back and we will solve this question. Yeah, welcome back. So did you try this question? In the examination, if this question is coming in front of your screen, then you will say that, sir, integration is not that very easy, right? It is not that easy. It will take a lot of time. So integrating will not be the cup of my tea, but what I would do? I know something. This might be expectation of x square, right? This is something expectation of x square I will be getting because here there is x square. So what do you think what I will do? I remember this particular thing, that this is my standard PDF. This is my standard PDF. And can I relate? Yes. What I can do? If I put mu x equals to 2 and sigma x square also equals to 2, what I can get? 1 upon under root 4 pi e to the power minus x minus 2 whole square divided by 4. So this will be my fx of x. And one thing I know that if I do expectation of x square, so that will come out to be expectation of x square will be sigma x square plus mu x square. That means it will come out to be sigma x square. What is sigma x square? That is 2. And what is your mu x? Mu x is also 2 plus 4. That will come out to be 6. So this answer will be 6. So this 6 will be equals to what? 6 will be equals to minus infinity to infinity x square fx of x dot dx. Right? So basically minus infinity to infinity x square. What is your fx of x? That is upon under root 4 pi e to the power minus x minus 2 whole square divided by 4 dot dx. This is your fx of x. X square is already there. What is fx of x? Fx of x is 1 upon under root 4 pi e to the power minus x minus 2 whole square divided by 4 dot dx, and that will come out to be equals to 6. What do you need? You need x square e to the power minus x minus 2 whole square divided by 4. Basically this under root 4 pi is creating the problem. So let's throw it here. So minus infinity to infinity x square e to the power minus x minus 2 whole square divided by 4 dot dx is coming out to be 6 into under root 4 pi. And that is the answer of I. So this is your I. 6 into under root 4 pi. So this is the answer. So I is 12 under root pi. Your integration I is coming out to be 12 under root pi. This is the answer. Did you understand? Very simple. What I would do, I know that integrating this will be a tougher task. X square is there, expectation of x square divided by 4, something is there. So I will try to relate with whatever that I know. I know my standard Gaussian random variable. This is the PDF, 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square. Then I know that if I need to compare it with this, that means mu x should be equal to 2 and sigma x square should be equal to 2. Right? So from here I made my standard PDF. Now expectation of x square is given as sigma x square plus mu x whole square plus mu x whole square. So sigma x square I already know, mu x whole square I already know. So expectation of x square should come out to be equal to 6, and 6 is equal to minus infinity to infinity x square fx of x dot dx. So x square, what is my fx of x? This is my fx of x dot dx. So this particular integration I needed to calculate. So from here I got my answer. Well and good. Very simple. You just need to think that if I don't know the integration, then some trick I need to play, and that trick I have played here. This one. Will you play any trick here? No. No trick, nothing. This integration is not tough, right? If this question is coming, is it tough? No. What you will do? X square equals to t. So all these things you can do with respect to mathematics as well, no? So every time it's not that you need to use different brain. Simple mathematics can also work, right? And what about the limit? If x is 0, then t is also 0. If x is infinity, then t is infinity. So what is your I? From 0 to infinity, x dx would be put as dt by 2, and t is, so x square is t. So e to the power minus t square, x dx would be dt by 2. So 1 by 2, 0 to infinity, e to the power minus t dot dt. So answer will be 1 by 2. So answer of I is 1 by 2. So needlessly don't start comparing anything, okay? So needlessly we don't need to put any pressure on our brain that this thing should happen, that thing should happen. Simply you need to integrate here. Simple integration is very easy here, right? Job done, job done. What about this one? This is your standard PDF. You need to find the value of k. So again, do you think I need to compare or anything? No. What I need, if I need to find the value of k, what I will do? Minus infinity to infinity. This is the process that I always follow. Minus infinity to infinity, fx of x dot dx should be equal to 1. That means minus infinity to infinity, k e to the power minus x square by 2 dot dx should be equal to 1. So k is a constant. E to the power minus x square dot dx, that would throw under root pi. If there is downward, there is 2. So under root 2 pi, that is equal to 1. So what is the value of k? 1 by under root 2 pi. There you go. This is the answer. Or you could have compared as well. Like how would you compare? That fx of x is equal to 1 upon, this is what I remember, 1 upon under root 2 pi sigma x square exponential x minus mu x whole square divided by 2 sigma x square. So you know that sigma x square, if I compare from here, then what I can see, mu x I need to put equals to 0 and sigma x square I need to put equals to 1. So from here, what is the value of k is coming out to be? So k is coming out to be 1 by under root 2 pi sigma x square, with sigma x square is 1. So 1 by under root 2 pi. So value of k is 1 by under root 2 pi. There you go. Okay. So value of k is 1 by under root 2 pi. Very simple, but you don't need to compare all these, comparing and all these kind of things is not necessary. You directly can think that from minus infinity to infinity, basically for the whole area under the curve should be equals to 1. And I already know what will be the area under the curve for this one. Because I told you to remember e to the power minus x square dot dx would throw under root pi. So e to the power minus x square by 2 will throw what? Under root pi, whatever that you see downward, that should come in the under root. So k into under root 2 pi should be equals to 1. So value of k will be 1 upon under root 2 pi. So that's why in the last lecture I told you to remember one thing. This is very, very important. This will help you a lot. So always remember this. What is the answer? Under root pi. That's it. Always remember this. Just if you remember this particular thing, a lot of questions will be solved. Okay? Right? What about this one? Again, will you compare or anything? No. Always, very rarely, when you will compare, mostly when you see x square here, x square, and then in the exponential as well there is x square, then yes, comparison should come, because because like solving this particular integration is very difficult. Here already there is x square. Along with that, here also you are having x square. Basically, x minus 2 whole square is there, no? So already you are getting x to the power 2. Here also you are getting x to the power 2. But what if here you are getting x to the power 2, but here you are getting x to the power 1 only? So you know that if I put x square equals to t, then my job is done. But if same power here and same power here, then you need to think, right? And how will you think? That you already know. You need to compare it with the standard PDF. Do you think I need to compare here? No. What I can do? E to the power minus x square dot dx. I already remember the standard results. So what I will do? X minus 2 equals to t. So dx equals to dt. What about the limit? If x is equals to t, then t would be 0. If x goes to infinity, t would go to infinity. So limit of t is going from 0 to infinity. E to the power minus, in place of x minus 2 you are putting t square by 30 dot dt. In place of dx you will be putting dt. What will be the answer of this particular thing? You know that if only e to the power minus t square was there, then answer would be under root pi. But divided by 30 is there, so under root 30 would come inside. But if the limit was from minus infinity to infinity, but the limit is from 0 to infinity, that means area have been half. So this is the answer. Okay, under root 30 pi divided by 2, divided by complete 2, not in the under root. If it was from minus infinity to infinity, then the answer would have been under root 30 pi, but it is from 0 to infinity, that's why divided by 2. So very simple. If you compare, it will be a bit difficult. Okay, it will not be difficult, it will just take time. Like let's try solving it with respect to the comparison. So you can solve with respect to comparison as well, but forget about the comparison. This is how I will be solving it. All good, all fine. So yeah, this is the end of question. Now there is some important result. Now x is your Gaussian random variable having mean of mu x and variance of sigma x square. Probability of a random variable x taking value greater than mu x. That means what you will be doing? Basically, what is your fx of x? Fx of x is 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square, right? So if I need to find probability of random variable x taking value greater than mu x, that means I need to find this area. This area you need to find. Just let me know what should be the answer of this area. The graph is symmetric about mu x, right? The graph is symmetric about mu x. You know one thing, that from minus infinity to infinity, fx of x dot dx, from minus infinity to infinity, the whole area is 1. And it is symmetric about mu x. That means before mu x and after mu x, the area would be same. The graph is symmetric about mu x. That means before mu x and after mu x, the area should be same. So from mu x to infinity, what should be the area? From mu x to infinity, 1 by under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square dot dx. What should be the answer? 1 by 2. So in place of x minus mu, you can put equals to t. What I will do? In place of x minus mu x, I will put t. The limit will go from 0 to infinity. Similar this process we need to do. X minus mu x you put equals to t, e to the power minus t square divided by 2 sigma x square dot dt. Limit will go from 0 to infinity, right? So e to the power minus t square 2 sigma x square, what it will throw? 2 pi sigma x square. So this and this will get cancelled out, and since the limit is going from 0 to infinity, so answer will be half. So you just need to know one thing, that your graph will be symmetric about mu x. Are you able to understand this point? So in case of normal distribution, if you calculate the probability from mu x to infinity, that means if your random variable x is taking value greater than equals to mu x, if you calculate this, that would be equals to from minus infinity to mu x, fx of x dot dx, and that would be equals to half. Mu x to infinity minus infinity to mu x, half, and total area would be 1. Is that clear to you or not? So here, this is something that you need to remember. So can I write it down as probability of random variable x taking value lesser than equals to mu x? Probability of random variable x taking value greater than equals to mu x and taking value lesser than equals to mu x, both will be same and both will be equals to half, because the graph is symmetric about mu x. Is that okay for you? Okay, let's see more results. What you need to find? You need to find the probability of random variable x taking value greater than a. What is your x again? What is your random variable x? Again, Gaussian random variable having mean mu x and variance sigma x square. That means your fx of x is 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square. Right? You need to find probability of random variable x taking value greater than a. This is what you need to find. That means what you need to find? From a to infinity 1 upon under root 2 pi sigma x square e to the power x minus mu x whole square divided by 2 sigma x square dot dx. Try comparing it with something that you already know. What we studied in the last lecture, in the ending of last lecture, what we studied? Q function. So try comparing it with Q function, whatever that you already know. What is your Q function? My Q function is 1 upon under root 2 pi x goes from 0 to infinity e to the power minus x square by 2 dot dx. This integration I need to compare with Q function. Will you be able to relate? What you need to do? You need to, and here you need to put t, right? Again I do the same mistake. Here I need to put t square by 2 dot dt. So what do you think what I should do? X minus mu x divided by sigma x. X minus mu x divided by sigma x should be equals to t. Say yes or no? If I put x minus mu x divided by sigma x equals to t, what I will be getting? Dx sigma x goes here dot dt, right? This is sigma x. Basically, simple thing is there, no? X minus mu x sigma x dot t. So differentiation of x will be dx. This is a constant. Differentiation of mu x will be 0. Sigma x is also a constant, but this is in the multiplication. So sigma x dot dt. So dx is equals to sigma x is a constant in the multiplication dot dt, right? And what about the limit? What about the limit? If x is equals to a, then t would be equals to a minus mu x by sigma. And if x is equals to infinity, then t would be equals to infinity. So probability of random variable x taking value greater than a would be equals to 1 upon under root 2 pi sigma x square e to the power minus x minus mu x by sigma, So that would be x minus mu x by sigma is t, so t square by 2. So e to the power minus t square by 2. X minus mu x whole square divided by sigma x square, so t square by 2 dot dt. Are you able to relate? Right? And in place of from where to where the limit is going? Limit is going from a minus mu x by sigma x to infinity. A minus mu x to sigma x to infinity. A minus mu x divided by sigma x to infinity. So limit is going from a minus mu x divided by sigma x to infinity, but here I did a mistake. In place of dx you need to put sigma x into dt. Just very simple derivation. In place of dx what I am putting? Sigma x into dt, right? So here this was 1 upon under root 2 pi sigma x square. So if I take out the under root, so this sigma x and sigma x can get cancelled out. So what you are getting? Probability of x greater than a is coming out to be from a minus mu x divided by sigma x to infinity 1 by under root 2 pi 1 by under root 2 pi e to the power minus t square by 2 dot dt. This thing and this thing, are you able to relate? Yes, you are able to relate. How will you relate? Let's just take it upward. I think I need to add a page only. Okay, I am already having a page. So let's just copy this thing. I hope you are able to understand the derivation. Very simple, very straightforward, nothing else. Just started with this one. We needed to compare this thing with q of x. So that's why I am doing all this thing. That x minus mu x divided by sigma x I put equals to t, so that I can get e to the power minus t square by 2, so that I can compare. From here limit and everything got changed, so I wrote down the changes. So here sigma x was there, sigma x is getting cancelled out. So now somewhere I am able to compare. So this is my probability of x greater than a, right? And this is your q of x. So what do you think, what will be your q of a minus mu x divided by sigma x? What do you think, what will be the answer of this one? In place of x, what you need to put? A minus mu x divided by sigma x. So 1 upon under root 2 pi. In place of x, you need to put a minus mu x divided by sigma x. Going from a minus mu x divided by sigma x to infinity. A to the power minus t square by 2 dot dt. This thing and this thing both are same. So what did you understand? Probability of random variable x taking value greater than a is coming out to be q into this a, whatever a is written, a minus mu x divided by sigma x. So basically a random variable will be given, a random variable x will be given having normal distribution with the mean mu x and variance sigma x square. You would know how to draw its fx of x. You will draw its fx of x in this manner. That sir, I know how to draw its fx of x. That would be like this. Okay, so this point is 1 by under root 2 pi sigma x square. This point is mu x. This point is mu x. All good. This point is mu x and this is the amplitude. This is the random variable x taking value. Now what I am asking the probability of random variable x taking value greater than a. Let's just say this is a. Let's just say this is a. X equals to a. So what I am asking, this is your x equals to a. I am asking this probability. Probability of random variable x taking value greater than a. So that would be equals to a to infinity fx of x dot dx. And that would be equivalent to what? Q greater than a, greater than a. So q greater than a. Q of a minus, you would already be knowing the mu x value. You would already be knowing the sigma x value as well. So that would be the answer. Is this conclusion clear to you? Say yes or no. So a normal distribution is given having mean of mu x and variance of sigma x square. This is the graph I can make. They are asking probability of x greater than a. That would be equals to q of a minus mu x divided by sigma x. Should be there in your mind. You already know what is q function, right? So we are comparing and everything we got to know, but now this conclusion should be clear to you. Okay. So this is what we are writing down. Probability of, this is my mu x. This is my mu x. The center will be mu x. Where you are having the maximum amplitude, the center would be mu x. This would be your mu x. What they are asking, probability of a random variable x taking value greater than a. So that would be come out to be q into a minus mu x divided by sigma x. Gaussian random variable x such that it is normally distributed with mu x mean and sigma x square variance. So what do you think, what will be the probability of a random variable x taking value lesser than equals to, what will be the probability of random variable x taking value lesser than equals to a? That means this particular probability they are asking now. Which probability they are asking? Which probability they are asking now? This particular probability they are asking now. So that will be equivalent to 1 minus x greater than a, because you know that probability of x greater than a plus probability of x less than a is equals to 1. So x less than a would be equals to 1 minus probability of x greater than a. 1 minus probability of x greater than a. So that will be equivalent to 1 minus q a minus mu x divided by sigma x. There you go. Say yes or no. Right? So what do you think, what will be your CDF of a Gaussian random variable? CDF of Gaussian random variable normally distributed with the mean mu x and variance sigma x square. What do you think, what will be the CDF? So how the CDF is defined? CDF is defined as fx of x. It shows that probability of random variable x taking value lesser than equals to x. But for Gaussian random variable, what do we remember? We remember probability of random variable x taking value greater than equals to small x. This is what we remember. We don't remember lesser than small x. What we remember this one. We usually remember this particular thing. This answer we remember. So I can convert it 1 minus x greater than equals to 1 minus x greater than equals to x or x greater than x. This is how I can convert it, and I know that what will be the answer of this one. Q of x minus mu x divided by sigma x. Right? X greater than a was a minus mu x divided by sigma x. So x greater than small x would be x minus mu x divided by sigma x. So this is your fx of x. Do you remember one thing? Q of x plus q of minus x is equals to 1. So basically q of x would be equals to 1 minus q of minus x. So basically if I am writing down 1 minus q of something, so can this be written as q of mu x minus x divided by sigma x? Do you agree to this point? Because I know that, let's just say this was t. So q of t plus q of minus t would be equals to 1. If this was t, so this would have been minus t. So q of t plus q of minus t would have been equals to 1. So 1 minus q of x minus mu x divided by sigma x is written. So this is how I can write it down. So one of the thing could be mentioned in the options. Either this could be mentioned, either this expression can be mentioned, or this expression can also be mentioned. So you need to remember this particular property, that q of x plus q of minus x is equals to 1. So from here you can write it down in this manner. Is that okay for you or not? Well and good. Very simple. So only thing you need to remember is probability of random variable x taking value greater than equals to a. That would be q of a minus mu x divided by sigma x. So if you need to find out fx of x, then you can follow this process and you will get the answer. What does fx of x says? X should be having the value lesser than equals to small x. Then 1 minus probability of x taking value greater than equals to small x. If I know the answer of this one, then I can write it down, 1 minus q small x minus mu x divided by sigma x. So this is the answer you are getting. Well and good. Okay, so this is the graph of fx of x. Just let me know what will be the value of fx of mu x. Fx of mu x. So 1 minus, in place of mu x, in place of x you need to put mu x. In place of x you need to put mu x. So 1 minus q, let's do it on the next page. So your fx of x was 1 minus q x minus mu x divided by sigma x. You need to find the value of fx of mu x. That would be equals to 1 minus mu x divided by sigma x. So that would be equals to 1 minus q of 0. What is the value of q of 0? That is 1 by 2. From the last lecture we remember. So answer would be 0.5. So at mu x the value will be 0.5. And which is pretty obvious as well, because you know that what would this represent? This would represent the probability of random variable x taking value lesser than equals to mu x, right? And here only we told that probability of random variable x taking value lesser than equals to mu x, or probability of a random variable x taking value greater than equals to mu x is equals to 1 by 2. So this is your 1 by 2 only. So by any method you can tell this value will be 1 by 2. And what will be the value of fx of infinity? So here if you put x equals to infinity, here if you put x equals to infinity, so q of infinity is 0. Q of infinity is 0. So 1 minus 0 would be 1. And what will be q of minus infinity? Q of minus infinity will be 1. So 1 minus 1 will be 0. And you know the property of CDF. CDF will go from 0 to 1 only. So this is your fx of x. Is that okay for you? Okay. So now there is a question that random variable x is given having mean and variance of this. What you need to find? Probability of a random variable x taking value between a to b, then a to b, a to b and a to b like this. Okay. So do this question on your own. I will take a break and then I will come back. Do this one. Random variable x is given having mu x mean and variance sigma x square. You need to find the answer of all these four. So do it on your own. I will take a break and then I will come back. Yeah, welcome back. So did you try this question? So first thing is that x is a continuous random variable, no? Right? X is a continuous random variable. So for continuous random variable, all these probabilities will be same only, no? Right? So I don't need to find them separately. This is the first conclusion that I can make. Because if it is a continuous random variable, that means probability at a point will be 0. That means all these probability I don't need to find separately. All these will be equal. So here only I am putting the equal sign. All these will be equal. So simply what I am doing, I can find this probability, or I can find this probability, or I can find this probability, or I can find this probability. All of them will be the same only. Now let's find this probability with respect to the diagram. So mostly I will prefer making the diagram. When it comes to normal distribution, I will try making the diagram. So I am gonna find out this probability with respect to the diagram. So what they are saying, greater than A but less than B. Let's just say this is your A and this is your B. Greater than A but less than B. That means this probability they are talking about. Right? Greater than A, less than B. So can I write it down in this manner? It is your probability of x greater than A minus x greater than B. X greater than A means A to infinity. X greater than B means B to infinity. So from A to infinity you are subtracting B to infinity. That means you are talking about A to B. Now what is probability of x greater than Q of A minus mu x upon sigma x. And what is x greater than B? Q of B minus mu x upon sigma x. There you go. This is the answer. Very simple. So no need to mug up. You can derive it any day, right? Just make the diagram, you will understand everything. Here I could have solved it with respect to CDF as well. Like if I have solved it with respect to CDF, what I would have done? Fx of B minus fx of A. But I know that I usually remember this answer, no? I don't remember these answer. I usually remember this answer. So what I would have done? Better I would have made the diagram, and I know that I remember the answer for greater than, not for the lesser one. For lesser one I can make the answer, right? Just the way I made here. For lesser one I can make the answer, but for the greater one I remember the answer. That is Q of A minus mu x upon sigma x. So in this manner I will solve it. With respect to this as well I could have solved it. What I would have written? 1 minus Q of B minus mu x upon sigma x, then minus, then 1 minus Q of a minus mu x upon sigma x. So you can see that 1 and 1 will get cancelled and you will get the same answer. Q of a minus mu x upon sigma x minus q of b minus mu x upon sigma x. But usually what we will do is that we will solve the problem of Gaussian random variable with respect to the diagram. Okay. So diagram is much easier than all these kind of things. So always I will try making the diagram rather than going into complex expressions. And with respect to diagram only I remember one particular answer, which is this one. The probability of x greater than a would be equals to q of a minus mu x upon sigma x. That's it. Right. Now let's write down the conclusion. So let's just say this is the midpoint. Right. Normal distribution, this is the midpoint. At midpoint what will be the magnitude? 1 upon under root 2 pi sigma x square. 2 pi sigma x square. Right. And if someone asks you what is the PDF, so your PDF is 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square upon 2 sigma x square. Right. Probability of x greater than b, that means this is what I am talking about. So it would be equals to q of b minus mu x upon sigma x, b minus mu x upon sigma x. Right. X less than a, if I am talking about this probability I am talking about, that means what I need to do, 1 minus probability of x greater than a, because I remember the answer for greater than a. So what will be the answer? 1 minus q a minus mu x upon sigma x. And if I am talking about the probability between a to b, what does that mean? That I am saying that x is greater than a but x is less than b. Sorry, x is greater than a minus x is greater than b, right? X is greater than a minus x is greater than b, that means you will get the probability between a to b. So your answer would be q of a minus mu x upon sigma x minus q of b minus mu x upon sigma x. And all these combined from minus infinity to infinity, everything would be what? Everything would be equals to 1. And if I ask you x taking value greater than mu x, or if I ask you x taking value less than mu x, both will be equal and equal to half. Now there are other standard distribution as well. We have studied about two distribution. Which two distribution we have studied about? We have studied about uniform and Gaussian. Gaussian you can say, or you can call it normal as well. Both names I need to remember. So these two distribution we have studied everything. Okay. Now there is something called exponential distribution, Rayleigh distribution, gamma, Laplacian, chi-square, Cauchy, triangular, Bernoulli, binomial Poisson. So they are also important, but they are with respect to discrete random variable, and you will study it in engineering mathematics. Okay, so don't worry about that. Very simple, like basic probability in class 12th as well you have studied it. Do you remember that problem which we used to solve with respect to the probability, with respect to P and C, right? There was some Poisson, there was something called binomial distribution. There was something called Poisson distribution as well. So those you will study in mathematics. Don't worry about that. Okay. So in communication system, with respect to communication system, only two kind of distributions are important that we have studied. Two kind of standard distribution, uniform and normal, and we have studied that in a very good manner. Now from all these you don't need to remember any answer. Like here you need to remember answers. What you need to remember? For uniform distribution you need to remember the expected value a plus b by 2. You need to remember variance as well, b minus a square divided by 12. In Gaussian as well you need to remember certain things, that mean will be mu x, sigma x square. You need to remember the expression as well. So all these things you need to remember, but for all these kind of things nothing you need to remember. You will simply solve the question. So we will frame the question based on all these distributions now, like based on exponential, based on Laplacian, on all these distribution. If some question is coming, you will be able to solve it. In the first, second and third lecture, how did we study? Like there was some fx of x was given, you need to find the value of k, you need to find the probability greater than something. Like there was different kind of expression, no? Like as far as I remember, there was this expression, right? There was something kind of this expression was there. this kind of expression was there, right? Where x was going from minus infinity to infinity. This was your fx of x. And there I asked you probability of x greater than 2, all these kind of things. So if these kind of things are coming, then simply whatever the method is there, you draw the PDF, x is greater than 2, that means you go from 2 to infinity, fx of x dot dx. So there nothing we are going to remember. Are you able to understand this point? So any general question could be coming. With respect to that general question, we will be able to solve the problem. Well and good. Now let's solve this question. So what they are saying, x is a triangular distribution going from -1 to 4. X will be taking value -1 to 4, and you are having the maximum amplitude at x equals to 2. If I say triangular distribution going from A to B, in between C would come. What does that mean? That means A to B, in between C would come. That means you are having maximum amplitude at C. This is not the midpoint. This is the maximum amplitude point. You will be having the maximum amplitude at C. So it will be a triangular distribution. Here, sorry guys, this should be written x as triangular distribution. So A to B at C you will be having the maximum amplitude. All okay for you? Okay. And they will actually define it. They will not write down directly like this, because this is not that much standard. Uniform and Gaussian are very standard. In digital communication only these two will come. In the examination as well, these two only will come. Everywhere these two will keep on coming. But from all these distribution as well, some questions can be framed, and questions will be framed in this manner. Are you able to understand my point? Even if they define like this, they will tell you the definition. What is the definition? The definition is that between -1 to 2 there is different kind of curve. Between 2 to 4 there is different kind of curve, right? The equation of this line will be different. The equation of this line will be different. Are you able to understand this point? Now you need to find the value of k, and then you need to find the mean of random variable x. So how will you find the value of k? So you know that for finding the value of k, what I know, minus infinity to infinity, fx of x dot dx, that would be equals to 1. So half into base into height is k, is equals to 1. So k is coming out to be 2 by 5. So what is the value of k? 2 by 5. So value of k is actually coming out to be 2 by 5. Just you need to calculate the area. Area is half into base into height, that is equals to 1, right? So the k is coming out to be 2 by 5, right? Now what you need to find? You need to find the mean of a random variable x. So mean of random variable x, that would be from minus infinity to infinity, x fx of x dot dx. But fx of x is non-zero between -1 to 4 only. So you can change it in this manner, -1 to 4 x fx of x dot dx. Now let's define fx of x. What we are doing? We are defining fx of x. So what you can see, that between -1 to 2, if your x is between -1 to 2, there is some different equation. What will be the equation of this line? Can you write it down? Surely you can write down. The equation of this line will be y equals to mx plus c. What is the slope? 2 by 5 divided by 3. So slope will be 2 by 15. What is the x-axis? X plus c. That means at x equals to -1, you are getting the value 0. So this would be plus 2 by 15. So this is the definition. Are you able to understand? Right? This much thing you are able to understand or not? Just I am writing down the equation between -1 to 2. So the equation is 2 by 15 x plus 2 by 15. This is the definition between -1 to 2. And when your x is between 2 to 4, what is the definition? So y equals to, what is the slope? Slope will be 2 by 5 divided by 2. So -1 by 5. Slope is negative, right? So y-axis, length of y-axis divided by length of x-axis. So 2 by 5 divided by 2, but the slope is negative. So -1 by 5 x plus c. So at x equals to 4, you are getting the value 0. What does that mean? That c has to be 4 by 5. If I put x equals to 4 here, I am getting the value 0. So that means for 2 to 4, the definition is minus x by 5 plus 4 by 5. So this is the definition of fx of x, and otherwise it is 0. Otherwise it is 0. 0 otherwise. So this is the definition of fx of x. So now you need to break this integration. No? You have to break this integration between -1 to 4 x into, how will you break it? Between -1 to 2 there is different definition. Between -1 to 2 there is different definition. That definition is 2x plus 2 divided by 15 dot dx, and from 2 to 4 there is different definition, minus x by 5 plus 4 by 5 dot dx, and then you will get some answer. So you will solve this integration. The answer would come out to be this plus this divided by 3. What the answer will come? -1 plus 2 plus 4 divided by 3. You can solve it, you will get this answer only. Answer will come out to be 5 by 3. Solve this integration. I gave you the complete definition. First thing is that we found the value of k. Then we saw that what is the slope here? 2 by 5 divided by 3. So 2 by 15 is the slope. From there we find out this value 2x by 15 plus 2 by 15 between -1 to 2, and then the definition is changing from 2 to 4. So there as well we find out the equation. So in both of the cases we are just finding out the equation. Finding the equation is not a tough task. What is the slope here? -1 by 5 plus 4 by 5 would come, because at 4 this will throw the value 0, and at 2 this will throw the value 2 by 5, which is coming out to be here, and otherwise it is 0. So now the integration limit will be broken between -1 to 2 and then 2 to 4. So x into fx of x, x into fx of x dot dx, and when you solve this integration, this answer would come a plus b plus c divided by 3. Answer would be 5 by 3. So only for this triangular distribution you will remember the answer. What you will remember? If your triangular distribution is like this, a, b, c, going from a to c, maximum amplitude at b, then the mean of random variable x would be a plus b plus c divided by 3. Remember it. Okay. Who knows, it may be asked. If you are able to remember it, then it is good. Otherwise you will have to solve this integration and you will get the answer. Both of the things are possible. Now someone will say, sir, how to calculate the variance? So in the similar manner, the way I calculated e of x, can you calculate e of x square? Yes. So just this will happen. So in the similar manner, you will calculate e of x square as well, and then e of x square minus e of x. Basically, if I need to find out sigma of x square, so e of x square minus e of x whole square. So how will you calculate this thing? That you know. In place of x, you need to put x square. That's it. In place of x, you need to put x square, and then you need to solve the integration. You will get some answer. How will you get e of x? A plus b plus c divided by 3, and then do the square. Then this value will come. Calculation will be very complex, and there is no standard result as well. So you don't need to remember any result. So mostly if they are giving you this kind of triangular distribution, then they will ask you the value of mean only. So how will you calculate the value of mean? Mean will be simply a plus b plus c divided by 3. There you go. Or they can ask you the probability. Probability, what they are asking? Probability such that x is going from 0 to 2. X is going from 0 to 2. What does that mean? X goes from 0 to 2. Fx of x dot dx. Right? Between 0 to 2 is the definition getting changed? No. Between 0 to 2, what is the definition? 2x by 15. So 2 by 15 I can take outside. Between 0 to 2, what is the definition? 2 by 15 into x plus 1 dot dx. 2 by 15 into x plus 1 dot dx between 0 to 2. Between 0 to 2. So what you will be getting? 2 by 15 x square by 2 plus x from 0 to 2. 2 by 15 2 plus 2 8 by 15. This is the answer. Very simple thing, very straightforward, right? Or what you could have done, you just find out the value of this one and then you could have calculated the area. This probability I am asking, no. So basically that will be equal to the area of this one. So if you know the equation, then you know that this value will be 2 by 15. Why is that so? Because if you put x equals to 0 here, this value will be 2 by 15. So what will be the answer here? Half into addition of parallel side, that is 2 by 15 plus 2 by 5. 2 by 15 plus 2 by 5. 2 by 15 plus 2 by 5. Into the height. Height is 2. So what is the answer you will be getting? 3, 6, 8 by 15 only. So what is the answer you are getting? 8 by 15. So here also 8 by 15, or by simply integration as well you could get the answer 8 by 15. So nothing you need to remember, no standard result you need to remember, you just need to remember the mean, that would be a plus b plus c divided by 3. Okay for you? And what if they are symmetric about origin? So do you remember the results for this one? Yes. Sir, if my uniform distribution, here your random variable x is uniformly distributed between minus alpha to alpha, and here your random variable x is triangularly distributed between minus alpha to alpha with maximum amplitude being at 0. Minus alpha to alpha, maximum amplitude being at 0. Right? So what would be the mean? Do you remember? A plus b divided by 2. A plus b divided by 2. Mean was 0. What was the mean square value? Mean square value was, what was the mean square value? Sir, this width 2 alpha square divided by 12. So alpha square by 3. And what was the variance? The same thing, right? Actually, this was not the mean square value, this was actually the variance. Really sorry guys. Width divided by this, I should not write down like this. Actually, we remember the formula for variance. Formula for variance is width whole square divided by 12. So answer will be alpha square by 3. Now here, since your mean is 0, that's why your mean square value and variance would be the same. Because if mean is 0, then mean square value and variance would be the same. So alpha square by 3, alpha square by 3. Here, what do you think what will be the mean? Minus alpha plus 0 plus alpha divided by 3, that would be equals to 0. Now sir, for variance we don't remember any answer. So what you will do, you will think that if it was uniform, then what would be the answer? Alpha square by 3. Just you need to make it half. Alpha square by 6. Alpha square by 6. Are you able to understand this point? So what all things I am asking you to remember? One thing is that what will be the mean of triangular distribution? That would be a plus b plus c divided by 3. And if it is symmetric, then what will be its mean square value or what will be its variance? That will be alpha square by 6. This is what I am asking you to remember. Here you will be getting confused about 6, that sir, what value should come? Then what should come into your mind? That sir, if it was uniform, then what would be the answer? 2 alpha square divided by 12. So answer would have been alpha square divided by 3. So now just the half answer would be there, alpha square by 6, alpha square by 6. So answer would have been alpha square by 6. So this is how you need to remember. So this slide, will you be able to remember? Mean will be midpoint 0, 0. Forget about mean square value. For variance, I remember the formula, width square divided by 12. Width square divided by 12. Here I am getting alpha square by 3 answer. Here just the half of the answer would be there, alpha square by 6. And since the mean is 0, so mean square value and variance would be the same. There you go. All good? All fine? Let's go to this question. You need to find the mean. This particular distribution is given. Fx of x is x by 3 e to the power minus x square by 6 for x greater than 0. You need to find the mean. So what you will do? Sir, I need to find the expected value of x. That means minus infinity to infinity x fx of x dot dx. But I know that x is going from 0 to infinity only. So x goes from 0 to infinity x into x by 3 e to the power minus x square by 6 dot dx. So 0 to infinity x square by 3 e to the power minus x square by 6 dot dx. Now this particular thing you need to calculate. How will you calculate? What do you think? Can you relate it with something? Can you relate it with something? Right? Surely you can remember. What we remember? This is my target. I need to solve this integration. I know that x square is there, it will be difficult. So what we remember? We remember that here, since x is already given, no, fx of x, so that's why I am saying fy of y. Okay, so that would be equals to 1 upon under root 2 pi sigma y square e to the power y minus mu y square upon 2 sigma x square. So directly I can see that mu y should be equals to 0, right? And sigma x square should be equals to 3, right? So what you are getting? Fy of y is coming out to be 1 by under root 6 pi e to the power minus y square by 6, y square by 6, right? Now you know that here what I have put, mu y is equals to 0 and sigma y square, sigma y square, here y, right? Sigma y square is equals to 3. Sigma y square is equals to 3. Now you know that expectation of y square, expectation of y square, expectation of y square would be equals to minus infinity to infinity, since it goes from minus infinity to infinity, minus infinity to infinity y square into fy of y dot dy, and that would be equivalent to what? Sigma y square plus mu y square. So for here what you can see, minus infinity to infinity y square into 1 by under root 6 pi a to the power minus y square by 6 dot dy, that would be equals to sigma y square is 3 plus this would be equals to 0. So under root 6 pi goes here, what you are getting? Minus infinity to infinity y square e to the power minus y square by 6 dot dy is coming out to be 3 into under root 6 pi. Say yes or no? 3 into under root 6 pi. But what do you remember? What do you want? Here you want x square by 3, x square by 3 e to the power minus x square by 6 dot dx. This is what you want. So let's not what you want, x square by 3 e to the power minus x square by 6 dot dx. This is what I want, right? So what do I know? That this is your even graph, right? This graph is even. This particular graph is even. So what I can break down? 0 to infinity y square e to the power minus y square by 6 dot dy would be equals to this particular thing, 3 into under root 6 pi. And from here what I can get? 0 to infinity, from here to here I am going. So in place of y square, in place of y what I am putting x. Can I do it? Yes. X square e to the power minus x square by 6 dot dx would be equals to 3 by 2 under root 6 pi. What I need to calculate? I need to calculate this particular thing. So x square e to the power minus x square by 6 dot dx, that is coming out to be 3 by 2 under root 6 pi. 3 by 2 into under root 6 pi divided by 3. So what will be the answer? 3 and 3 get cancelled. Under root 6 divided by 2. So answer would be under root 3 pi by 2. Basically this 2 goes inside. So what you get? Under root 3 pi by 2. So this is the answer you are getting. Very simple, very straightforward. Just the calculation is there. So I used my brain. Basically my target became that you need to solve this particular integration. There I used my brain that how would I solve this integration. So then I saw that this is 3 by 2 under root 6 pi that I got from here, and then I put the value here. So 1 by 3 is there, 3 get cancelled. So 4 goes inside. So under root 3 by 2, this is the answer I am getting. All good, all fine. Solve this question on your own. Let me take a break. Why I am taking the break frequently? Because match is going on. Okay, India versus England. So I need to see the score. So you solve this integration, very simple, and then we will come back. Yeah, welcome back guys. Actually India lost the game just by 22 runs. Only by 22 runs we lost the game. That too test match. That too in Lords. Those who watch cricket, they would know that this is very heartbreaking. But forget about it. Let's solve this question. So what do I know? That I can solve the problem which are something like this. X square fx of x dot dx. But here x plus 3 is written. So what I will do? I will put x plus 3 as t. Right? So dx would be equals to dt. Basically I need to make a single variable square. So that's why I am doing x plus 3 equals to t. So dx will be equals to dt, and limit will go from minus infinity to infinity only. Because if x is minus infinity, then t is also minus infinity. If x is plus infinity, then t is also plus infinity. From minus infinity to infinity, t square e to the power minus 3t square dot dt. Right? And now the comparison game will start. Right? How will you compare? Fx of x, what do you know? 1 by under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square, right? So here directly I can see that mu x is coming out to be 0, but 2 sigma x square is coming out to be 1 by 3. 2 sigma x square is coming out to be 1 by 3. So sigma x square is coming out to be 1 by 6. So what is your fx of x now? Did you understand? 2 sigma x square is coming out to be 1 by 3, because if it is 1 by 3 then your job is done, right? So what is your fx of x now? So that would be 1 by under root 2 pi by 6. So under root pi by 3. So under root 3 by pi e to the power minus 3x square. Say yes or no, right? So under root 3 by pi, this will be the answer. Very simple. Well and good. Now this is your fx of x. Now what do you know? That from minus infinity to infinity, x square into under root 3 by pi e to the power minus 3x square dot dx would be equals to what? Would be equals to sigma x square plus mu x square. That means it would be equals to 1 by 6 plus 0. So x square e to the power minus 3x square dot dx, that would come out to be equals to 1 by 6 into under root pi by 3. There you go. This is the answer. Right? Very simple. This is the answer. How did I get this answer? This goes here. So what you are getting? 1 by 6 into under root pi by 3. 1 by 6 into under root pi by 3. And this is what you need to find, x square e to the power minus 3t square dot dt. Sorry, t square minus 3t square dot dt. So here what you are doing, x square e to the power minus 3x square dot dx, which is same. In place of x, if you put t, you are getting the same answer. 1 by 6 under root pi by 3. 1 by 6 under root pi by 3. So what you are getting, 1 by 6 into under root pi by 3. So this is the answer we are getting. This is the value of I you are getting. Okay, very simple. Let's solve this question. In this question you will get one concept as well. Okay, we will solve the problem, along with that we will understand a concept as well. So what is given? This fx of x is given. This is a valid PDF. This is surely a valid PDF. If they have given, that means surely it is a valid PDF. You need to find, so what is given? Probability of x greater than equals to 1 is given, that is 0.16. You need to find all these things. So let's try getting some information from here. This I understood that surely it is Gaussian random variable. So what do I know? Fx of x in this manner I know. Under root 2 pi sigma x square. I will keep on writing this expression so that it is there in your mind. Okay, so you should also keep on writing down this expression so that you don't ever forget it. So from here what you can see, that your mu x is equals to 0.5, sigma x square is equals to 1 by 2. Mu x is equals to 0.5, sigma x square is equals to 1 by 2, right? So can you draw the diagram for this one? Mu x is 0.5, sigma x square is 1 by 2. So mu x is 0.5 here, sigma x square I don't show. Now what they are saying, probability of x greater than 1 is equals to 0.16. Where will be x equals to 1? X equals to 1 will be somewhere here. This is your x equals to 1. So this probability they have shown, that is 0.16. Next what they are asking, probability between 0.5 to 1. Probability between 0.5 to 1. So can you let me know what will be the probability between 0.5 to 1? You know that this total probability from here to here, this total probability is 1 by 2 minus 0.6. That would be the answer, right? So answer would be 0.34. This is the answer of first one. Did you understand this point? This is the mean, no? This is the mean. So from here to till the end, you know that probability of x greater than 0.5 will be equals to what? 1 by 2. And probability of x less than 0.5, what that would be equals to? That would also be 1 by 2. Now I will tell you one more point. So this 1 is 0.5 ahead of mean, right? This 1 is 0.5 ahead of mean. So if your x is greater than 1, then probability is 0.16. And what did I tell you? That your PDF will be symmetric about mean. Your PDF will be symmetric about mean. So what you will do, From mean, if you are going 0.4, from mean, if you are going 0.5 ahead, so now from mean you will go 0.5 backward. So from mean you are going 0.5 backward. Where you will reach? You will reach at 0. So here what do you see? Greater than 1. Probability is 1 by 6. So here what you will see? Less than 0. This probability will also be 0.16 only. Are you able to understand this point? This probability will also be 0.16 only. I told you the graph is symmetric about mean. So let me draw the graph again. Okay. So I will draw this kind of graph. The graph is symmetric about mean. Let's just say this is the mean, which is mu x. So if I am going alpha ahead, that means if I am reaching here, mu x plus alpha, and there is some probability given that x is greater than, this is the value of x I am taking. If x is greater than mu x plus alpha, then there will be some probability, that is p. So what will happen is that if you go alpha backward, so this point will be your mu x minus alpha. This point will be your mu x minus alpha. Mu x minus alpha. So another thing is that these amplitude will also be same. It is not looking like that, but these amplitude will also be same. Along with that, their probability also will be the same. What I mean to say is that whatever the probability that I get here, the same probability I will get here as well. Are you able to understand this point? So the same probability, that means probability of x taking value mu x minus alpha. X should be lesser than mu x minus alpha. Okay, that means the graph is completely symmetric about mean. I went ahead by 0.5, I will go backward by 0.5. So if someone asks me what is the probability such that x is less than 0, they are asking it, yes. In the third question, they are asking it, what is the probability such that x is less than 0? So what that would be? That would be 0.16 only. Are you able to understand this point? Because graph is symmetric about mean. So going 0.5 ahead, then this probability, going 0.5 backward, this probability, both will be same. So x less than 0 will be 0.6. Probability of x less than equals to 0 will be 0.6. Next, what they are asking? Fourth question, because second is already done, no? Probability of x less than 0.5. X less than 0.5, which is 1 by 2. X less than 0.5 will be 1 by 2. Next, what they are asking? Fx of 1 they are asking. Fx of 1. That means probability of x taking value less than equals to 1. Probability of x taking value less than equals to 1. So that would be equals to 1 minus 0.16, right? What they are asking? X less than equals to 1. That means this much they are asking. So that would be 1 minus 0.16, that would be 0.84. And next is mode of, first let's solve this inequality. Mode of x minus 0.5 should be less than 0.5. So x minus 0.5 should be less than 0.5 and greater than minus 0.5. So if you add 0.5 in both of them, so x should be between 0 to 1. This is what they are asking. So in the fifth question, what they are asking? They are asking probability of x taking value between 0 to 1. Probability of x taking value between 0 to 1. So this is what they are asking. This is what they are asking. So you know that whole PDF will give you probability equals to 1. The whole PDF will give you probability equals to 1. But if you are getting the probability between 0 to 1, then answer would be 1 minus, this is 0.6, this is 0.6. So 0.16 plus 0.16. That would be 1 minus 0.32, that would be equals to 0.68. Okay. So these are all the answers. And this was the answer of second question. All good, all fine. So everything about Gaussian random variable or other kind of standard PDF we have studied, right? So I hope you enjoyed this lecture. This was a very simple lecture. Just usually it is taught just after the introduction of random variable, but this was a simple topic, so that's why I deal it a bit later on, because in the initial phase we should learn the tougher topic, you know. So if we learn the tougher topic in the initial stage, then it will become easy for us. So now all these things will sound very easy for you, right? So this was the topic which was here we studied about some standard distribution. So we mainly focused on uniform and Gaussian. So after focusing on uniform and Gaussian, we solve the questions of some other standard PDF. So this is also a standard PDF actually. This is also a standard PDF only, but these are not important. Only two important PDF are uniform and Gaussian, and these PDF will again and again keep on coming. And for all of these, we will solve the problem. Mostly we have already solved, and in the end, in the miscellaneous, we will solve more problems, or in the test series as well, you will get some problems. So on all of these, you will get the questions. So here you don't need to remember any standard results. So in this lecture, whatever the standard result that I am asking you to remember, that you need to remember. The most important one is probability of x greater than a, that we studied in Gaussian. This is very, very important. Very, very important. Q of a minus mu x upon sigma x. So you will draw the graph a minus mu x upon sigma x. This is what you need to remember. All good, all fine. So yeah, everything is done. Let's meet in the next lecture. In the next lecture, we are going to study about transformation of random variable. So we will convert random variable x into y or y into x. So we will study about transformation of random variables. Okay, then let's meet in the next lecture. Thank you very much. Hi everyone, welcome back. Now we are going to study about transformation of random variable. So here what will happen? A random variable x will be given, and for this random variable x you will be having its PDF as well. Now what you will be doing? You will be converting this random variable x into random variable y. You will be converting this random variable x into some random variable y. That means some function you will be applying. So this random variable x will be converted to random variable y. So now you will have to find the PDF of random variable y, or some probability also it can find. Basically they can ask question based on random variable y now. So from random variable x you are going to convert into random variable y. So for x as well you need to find the PDF. For x PDF will be given, you need to find the PDF for y. So this will be the scenario. This kind of questions will be asked. So first we are going to study about linear transformation, because in digital communication everywhere it will be used. In 99% of the cases, only linear transformation will be used in digital communication. That's why I am making it a separate topic. Although it is not a separate topic, it is a sub part of a particular topic, but I have made it a separate topic, that you are going to linearly transform. You are going to linearly transform random variable x into random variable y. What is the meaning of linear transformation? That means on x there will not be any power. X to the power 2 will not be there. Under root x will not be there, or sin x will not be there, or cos x will not be there, or ln x will not be there. Basically x will come as it is. Now it can be multiplied with any constant value. Let's just say it is multiplied with 3, and then after that you can add any constant value. Let's just say I am adding minus 2, or it is multiplied with minus 3, I am adding plus 2. So basically x will come as it is. If x is coming as it is, then how will you transform your random variable x into random variable y? So what they are saying, a random variable x is given, its PDF also given. PDF of random variable x, this is the PDF of random variable x. Its PDF is also given. Now another random variable y is defined as y equals to ax plus b, where a and b are constant. So you need to find the PDF of y. This is what they are asking. So there is one line that you need to remember. Okay, from where that line came, don't worry about that. But one line you need to remember, that if you are doing the linear transformation, then linear transformation will not change the nature of the random variable. That means if your x was uniform PDF, then y will also be uniform distribution. If your x was Gaussian, then y will also be Gaussian. If x was exponential, then y will also be exponential. If x was binomial, then y will also be binomial. So linear transformation will not change the nature of a random variable. So this is the line written. Linear transformation does not change the nature of a random variable. Okay, so let's just say you are having a random variable x which was uniform, and now you have done the linear transformation. Only linear transformation. This is very, very important. Okay, which topic you are studying? Linear transformation. Any other kind of transformation can surely change the nature, but linear transformation will never change the nature. And I am telling 99% chances are there that only linear transformation will be asked. Till this date in any examination, always linear transformation they ask. So linear transformation will not change the nature of random variable. So if x is uniform and you are doing the linear transformation, then y will also be uniform. And if x is Gaussian, you are doing the linear transformation, then y will also be Gaussian. Is that okay for you? Surely it is okay for you. Okay, very simple thing. Now we will solve the problem and we will understand the concept as well. So only thing from this particular slide you need to remember that what is the meaning of linear transformation? What is the meaning of linear transformation? Y is equals to ax plus b. That's it. This is the meaning of linear transformation. And linear transformation does not change the nature of random variable. This is what you need to remember. Let's see the questions. Now it will be more clear to you. So x is a uniform PDF or x is a uniform random variable which is spread between -2 to 3. Another random variable y is defined. You need to find the PDF of y, you need to find the expectation of y, you need to find the probability of y taking value greater than or equals to 2. So let's just say you did not study this topic. Let's just say you did not study this topic, then how would you solve this question and this question without even studying this topic? So what I will do? Sir, what I need to find? Expectation of y. So sir, expectation of y would be 2x minus 3. Sir, I can write it down as 2 into expectation of x minus 3. Sir, what will be the expectation of x? So that would be a plus b divided by 2 minus 3. So it would be minus 2. Okay, the job is done. And how would you find the probability of y taking value greater than 2? So probability of 2x minus 3 taking value greater than or equals to 2. Probability of x taking value greater than 5 by 2. This is what you need to find. Now what I will do? What I will do is that I will make the PDF of x. Can I make the PDF of x? Surely you can make. It is uniform PDF between -2 to 3. Uniform PDF between -2 to 3. Between -2 to 3. Right? So what is this length? This length is 5. So what will be this height? 1 by 5. Right? Because 5 into 1 by 5 will be 1. Now what they need to find? Greater than 5 by 2. So this is, let's just say this will be your 5 by 2. Greater than 5 by 2. Probability of random variable x taking value greater than 5 by 2. That means from here to here you need to find this probability you need to find. So answer would be 3 minus 5 by 2 into 1 by 5. So answer will be 1 by 10. This is the answer. So if I don't know the concept, then this is how I will be solving it. This is the answer, and there is nothing wrong in solving in this manner, and it is very easy as well. Well and good, right? Now I need to find the PDF of y. So if I am not having the concept, if I am not having this concept, then I will not be able to find the PDF of y. But now I know one thing, that this is a linear transformation. This is a linear transformation where my x is uniform between -2 to 3. And since this is a linear transformation, then linear transformation will not change the nature of y. That means y will also be uniform. Y will also be uniform only. Now you just think about one particular thing, that if x is taking value between -2 to 3, that means what is the minimum value of x? That is -2. So what do you think, what will be the minimum value of y? That would be 2 into -2 minus 3. That would be equals to -7. If I put x equals to -2, so what I will be getting? -7. And what will be the maximum value of y? That would be 2 into 3 minus 3. That would be equals to 3. So y will be going from -7 to 3, uniformly distributed. So basically your PDF of y will be uniformly distributed between -7 to 3, because I told you one line, linear transformation does not change the nature of random variable. So if this was uniform, this was also uniform. Only the matter of concern was from where to where you will be taking the value. So if it is going from -2 to 3, so here if you put -2, what you are getting? -7. If you put 3, what you are getting? 3. So y will be going from -7 to 3. So let's make the PDF of y. Let's make the PDF of y. So how will you make the PDF of y? Fy of y going from -7 to 3. -7 to 3. What is this length? This length is 10. So what will be this height? 1 by 10. Say yes or no, right? Now this is the PDF that I have made. Now what they are asking, expectation of y. So what do you think, what will be your expectation of y? From this PDF, can you let me know the expectation of y? Yes, a plus b divided by 2. So that will be equals to minus 2, right? And what would be your probability of y taking value greater than 2? Y taking value greater than 2. So probability of y taking value greater than 2. That means this area I need to find. So probability of y taking value greater than 2 will be 1 by 10 into 1. That would be 0.1. So this is 0.1 minus 2. So what is the answer? Minus 2 and 0.1. Here also minus 2 and 0.1. So did you understand the point? The point is linear transformation will not change the nature of a random variable. That's it. So in case of uniform, what you will do? You will pick the minimum value, and there you will get the minimum value. You will pick the maximum value. Here you will pick the maximum value, which is 3. You will put it here. So 3 into 2, 6 minus 3. So maximum value of y will be 3. And what about the minimum value? So minus 2 you will put here, what you are getting, minus 7. So y will be going from minus 7 to 3, uniformly distributed. And since it is uniformly distributed between minus 7 to 3, so on your own you can tell what will be the amplitude. Because I know that area should be 1. What I know, area should be 1. Since y is also a random variable, and fy of y is also a PDF. So it will follow all the property of PDF. The property of PDF says that the total area should be equals to 1. So for that, this is the length, this is the width, or you can call it, this is the width, this is the height. So height into width should be equals to 1. So if this width is 10, so height will be 1 by 10. There you go. Okay, let's solve the next question. X is a Gaussian random variable which is having a mean of 2 and variance of y. Another random variable y is defined. The relation between random variable x and y is given by the following graph. This is the relation between random variable y and random variable x. You need to find the PDF of y, and you need to find the probability of y taking value between minus 1 to 3. So if I had directly asked you this question, probability of y taking value between minus 1 to 3, how would you solve it? What is the relation between random variable y and random variable x? Why I am interested in this? Because I know the distribution of random variable x. Can you let me know what will be your fx of x? Surely I can let you know. 1 by under root 2 pi sigma x square. Sigma x square is 4. So 1 by under root 2 pi sigma x square. Sigma x square is 4. So 4 into 2, 8. E to the power minus x minus mu x whole square divided by 2 sigma x square. That would be 8. Very simple. This will be the PDF of x. So if I know the PDF of x, then what I can do, I can find this probability as well, right? So I'm interested in the relation between y and x. So what do you think, what is the relation between y and x? This is a straight line. Again, this is a linear transformation. If there is a linear transformation, you should be happy, because linear transformation will not change the nature of random variable. So if this is Gaussian, then y will also be Gaussian. So y equals to mx, what is the slope? Minus 1, plus c. What will be the value of c? The point it cuts on y axis, that would be 3. So this is simply a straight line. You can write down the equation of straight line, right? So y is equals to minus x plus 3 is coming. So if I don't know the concept, then how I will be solving it, that I am telling. Minus x plus 3 to 3, right? Probability. Okay, if I subtract minus 3, what I will be getting? Minus 4. So basically you are getting x is from 0 to 4. Say yes or no? Because if your x is 4, then y will be minus 1. And if your x is 0, then y will be 3. Yeah, so x is going from 0 to 4. Did you understand this concept? Right? Just you are solving the inequality. So minus x plus 3, then what I did, I subtracted 3 from all the side. So here I subtracted 3, what I am getting? Minus 4, minus x, 0. And if I am multiplying negative sign to all the inequality, what I am doing? I am multiplying negative. So what will happen? 4 greater than x greater than 0. So x is between 0 to 4. This is what they are talking about. X is between 0 to 4. So this can be written as probability of x greater than 0 minus probability of x greater than 4. Probability of x greater than 0 minus probability of x greater than 4. Right? So Q 0 minus mu x. What is the value of mu x? 4 divided by sigma x. q 0, sorry, q a minus mu x. What is the value of mu x? From here I can tell my mu x value is 2. Okay, mu x value is 2. Really sorry guys. What is the formula? Probability of x greater than a. What is the formula? q a minus mu x divided by sigma x. What is the value of mu x here? 2. And what is the value of sigma x square? That is 4. That means what is the value of sigma x? This is a blunder that everyone can do. People will think here they will directly put the value 4. So I was doing a blunder. So here mu x and sigma x both are 2 only. Okay. So 0 minus 2 divided by 2. And here what you will get? 4 minus 2 divided by 2. So you are getting q of 1 here, and here you are getting q of minus 1. So what is the answer we are getting? Q of minus 1 minus q of 1. This is the answer we are getting. Q of minus 1 minus q of 1. So this would have been our answer if I don't know the concept. But I know the concept that since this is a linear transformation, it will not change the nature of random variable x. So what I will do now? Y is equals to minus x plus 3. I know that x is Gaussian. So y will be also Gaussian. Now you just let me know, when I am defining x, what all two things I require? I require the mean and variance. Say yes or no. What do I require? Mean and variance. What was my mean? Mean was 2, variance was 4. Mean was 2, variance was 4. Now I know that my y will also be Gaussian only. And what all two things I will be requiring? Mean and variance. If I know both of them, surely I can write down the expression of fi of 5. Say yes or no. So what is my target? My target will be finding mu y and sigma y square. That's it. So what will be my mu y? Mu y will be equals to minus mu x plus 3, because you know that expectation of y would be equals to minus expectation of x plus 3. So what is the expectation of here? It is 2 plus 3. Answer will be 1. So mu y value is 1. What about sigma x square? Sorry, what about sigma y square? So sigma y square would be equals to minus 1 whole square plus minus 1 whole square plus sigma x square. It will not do anything with the constant value. So sigma y square would be equals to minus 1 whole square will be 1. What is sigma x square? That is 4. So sigma y square is also coming out to be 4. So what does that mean? That means your random variable y is normally distributed. Two things I was interested in, this thing and this thing. Normally distributed with mean 1 and variance 4. There you go. Job is done, right? Now fy of y, if you want to write down, you can surely write down 2 pi sigma x square, that means 8 pi e to the power minus y minus 1 whole square divided by 2 sigma x square, that would be 8. So everything is same, only thing that converted here, it was 2 and this is 1. Now what I need to find? I need to find the probability between minus 1 to 3. Probability between minus 1 to 3. So what I will write down? Probability of y greater than minus 1 minus probability of y greater than 3. So what this will be equivalent to? Minus 1 minus mu x, sorry mu y. What is the value of mu y? Minus 1 divided by sigma y. Here this is sigma y square, which is 4. So sigma y will be equals to 2 minus probability of y greater than 3. So 3 minus mu y divided by sigma y. Probability of y greater than 3 would be q a minus mu y divided by sigma y. So what you are getting? Q of minus 1 into q of 1 minus 1 to 3. Are we getting the same answer? Surely we are getting the same answer only. Here also the same answer was there, here also the same answer is there. Answer would be the same, only it is just the matter of concern is that what if they ask you, mostly chances are there that they will ask you this particular thing, that you tell the distribution of y will be normally distributed with the mean of 1 and variance of 4. Why is that so? Because it was a linear transformation, and linear transformation will not change the nature of random variable. Other transformation are also there which are not at all important. Surely we are going to see those transformation, but this is the most important transformation, which is linear transformation. Other transformation are also important, but as of now you focus on linear transformation. Let's see more questions. So fx of x, any kind of random variable is given, a random variable x is given, whose PDF is given. So this PDF is not standard, right? You haven't studied this PDF. What do you think, what kind of structure you will get? Can you draw the graph of fx of x? Can you draw the graph of fx of x? X is taking value between 0 to 2. X is taking value between 0 to 2. And after that and before that it is 0 only. X is taking value between 0 to 2. So 0 to 1 it is following this graph. Then at 1 you are getting the value 1, and then slope becomes negative. So this kind of graph you will get. In basics of signal, we study this kind of graph a lot of times. So surely you will be able to make this graph. So what kind of PDF it is? It is a triangular PDF. And where it is changing, where it is giving you the maximum value, it is giving you the maximum value at 1. And this value is also 1. This is fx of x. Is that okay for you? So this is the PDF of your random variable x. So what do you think how I can define x? X is a triangular random variable going from 0 to 2 with the maximum amplitude at 1. Now another random variable y is defined as 3x minus 1. You need to find the PDF of fi of y, and then you need to draw the graph and define it, and you need to find the expectation of y. So if this question is coming in the examination, how will I solve it? If I directly want to solve expectation of y, so what I would do, I will not find the PDF, I will do this thing. Then I will say 3 into expectation of x minus 1. 3 into, what will be the expectation of x? I told you one formula. What is that? A plus b plus c divided by 3 minus 1. What is the answer you are getting? This is 3. 2 plus 1 3. 3 by 3 get cancelled out. Answer is 2. Right? What is the mean of random variable x? That is 0 plus 1 plus 2 divided by 3. The mean of random variable x is 1. So 3 into 1 minus 1, answer will be 2. So this is the expectation of y. This is the expectation of y you would have got, and you would have directly clicked on the answer. But now I am expecting the PDF of y. So what do you think, what will be the PDF of y? So I know that x is taking value between 0 to 2. Linear transformation is there, that means nature will not change. And x is taking value between 0 to 2. X is taking value between 0 to 2. So how your y will take the value? So what will be your y minimum? Put 0 here, y minimum will be minus 1. And what will be your y maximum? So your y maximum will be 5. 3 into 2. How I am getting minus 1? Are you able to understand this point? 3 into 0 minus 1. What is the answer? Minus 1. 3 into 2 minus 1. What is the answer? 6 minus 1, that would be 5. So y will be taking the value from minus 1 to 5. Right? Along with that, you can define this middle point as well. Basically, when your x is equals to 1, so what would be your y? 3 into 1 minus 1. So that would be equals to 2. So now I can define my random variable y, which will be minus 1 to 5 with the middle point at 2. There you go. Say yes or no. Did you understand this point? It will go from minus 1 to 5 with the middle point at 2. Because here the middle point was at 1. I should not say middle point. I should say the point where you are having the maximum amplitude. The point where you are having the maximum amplitude. So maximum amplitude was at 1. Y is going from minus 1 to 5. You got to know y is going from minus 1 to 5. Here the maximum amplitude was at x equals to 1. So if I put x equals to 1 here, what I am getting y equals to 2. That means my maximum amplitude will be at y equals to 2. So it will go from minus 1 to 5 with the maximum amplitude being at y equals to 2. So can you draw the PDF? Surely I can draw the PDF. minus 1 to 5 in the triangular manner with the maximum amplitude being at minus 1 to 5. Now just let me know one thing. Like some people would be thinking that, sir, here the magnitude is 1. So how will I find the magnitude of this PDF? So sir, I will put this 1 here. So magnitude of this PDF will be 2. Here the magnitude is 1. So if I want to find the PDF, if I want to find the magnitude of Fy of y, if I want to find this particular thing, then what I will do? I will put this 1 here, answer will be 2. No, this will be very dumb, no? Because these are the value of random variable x, and these are the value of random variable y. These are the value of random variable y, and these are the value of random variable x. And your relation is defined between x and y. It is not defined between fx of x and fy of y. The relation is defined between random variable x and random variable y. Here also we did not do this thing, no? Like nowhere we did this thing. That here, how did I find this amplitude? I found the amplitude with the property of PDF. Not that sir, here you put 1 by 5. What is the answer you are getting? 2 by 5 minus 3. So this amplitude will be 2 by 5 minus 3. That will be very, very foolish, right? Because the relation is between the value of random variable y and the value of random variable x. It is not the relation between fx of x or fy of y. So don't do this kind of blunder. Like those who study for the first time, they might do these kind of blunders. Okay. So amplitude will be defined with respect to the property of PDF, because this is also a PDF, this is also a PDF, right? So here also we followed the property of PDF. If you see the expression of Fi of y, what will be the area of this one? 1 only. What will be the area of this? That will be 1. So always we will follow the property of PDF. So if I need to find this particular value of k, so what will be the value of k? The value of k will be half into base into height. That will be equals to 1. So value of k will be equals to 1 by 3. So this value will be 1 by 3. So it has nothing to do with the relation. The only relation is between the value of random variables. So random variable y is taking value between minus 1 to 5, and random variable x is taking value between 0 to 2. And how did you get that? By the relation of y equals to 3x minus 1. That means when random variable x is taking value 0, then y will take the value minus 1. And when random variable x is taking value 2, then y will take the value 5. So between minus 1 to 5, this was triangular, so this will also be triangular. You just need to find the maximum point. Maximum point was coming at 2. There you go. Okay. So this is my PDF. What they are asking now? They are asking the expectation of y. Expectation of y. So what that would be? A plus b plus c divided by 3. So expectation of y is coming out to be 2. Although if this question is coming in the examination hall, I will not find the PDF. What I will do? I will directly solve like this. I am just telling you that answer will come same. And it is pretty obvious that answer should always come same only. Let's go to the next question. And here this is the definition. This is the definition of Fi of y. Basically what is the slope here? 1 by 9, right? And what is the slope here? Minus 1 by 9. So y equals to 1 by 9 into y plus c. Value of c you can find, because at minus 1 it is going to give you the value of 0. So this will be 1 by 9. So you can define the definition. Between minus 1 to 2, it is following the equation of y plus 1 divided by 9. Y plus 1 divided by 9. And then here the slope is minus 1 by 9. The slope is minus 1 by 9 into y, and at y equals to 5, it is giving you the value of 0. That means the value of c will come out to be 5 by 9. So this is how you can define the answer. So this is the definition of Fi of y. So this can also be mentioned in the option. Either they will make the graph or they will give the definition. So first you will make the graph, and then from here you can write down the definition on your own. Simply you need to write down the equation of straight line, nothing else. Let's go to the next question. x is a random variable taking value between, sorry, not between, taking value between 0 and 1. It is only taking two values, 0 and 1. It represents a binary random variable indicating bit sent in a digital communication system. Probability of taking value 0 is 0.7 and probability of taking value 1 is 0.3. Let the modulator output signal be s, which is 2x minus 1. You need to find the PMF of s. You need to find the PMF of s. So what they are giving, that a random variable x can take two values, 0 and 1. The probability is such that it is taking value 0, that is given as 0.7. The probability such that it is taking value 1, that is given as 0.3. Now there is something like this question is related with digital communication system, but you are not studying digital communication system, you are studying random variable. So another random variable x is defined as 2x minus 1. So let's go to the next page. Another random variable s is defined as 2x minus 1. So if x is taking values 0 and 1, if x is taking value 0 and 1, right, x is taking value 0 and 1, so s will take how much values? S will take minus 1 and s will take plus 1. So s will take two values, which is minus 1 and plus 1. What you need to find? You need to find the probability such that s takes the value minus 1, which will be equals to probability such that x take the value 0. Because when, okay, this is wrong, this notation is wrong actually. It is taking only two values, no, minus 1 and 1, minus 1 and 1, minus 1 and 1. So minus 1 is associated with 0 and plus 1 is associated with 1 only. So probability of s taking minus 1, s taking minus 1 is interlinked with x taking 0. So that would be the same, which will be equals to 0.7, right, 0.7. And probability of s taking value 1 would be equals to probability of x taking value 1, that would be equals to 0.3. So can you draw the PMF? Surely I can draw the PMF. So Px of x versus x, taking two values, minus 1 and plus 1. One probability is at minus 1, the probability is 0.7 and at 1 the probability is 0.3, 0.7 and 0.3. So here the probability is 0.7, here the probability is 0.3. Now can you draw the PDF from here? Can you draw the PDF from here? Surely you can draw the PDF as well, because I told you how to go from PMF to PDF. Going from PMF to PDF is very easy. What you need to do, just you need to convert it into impulse. Fx of x. So what will be the expression of fx of x? That will be, those who have studied signal system, they will be able to relate, 0.7 delta of, okay, this is not x, really sorry guys, this is s, right? This is not x, this is s. We are talking about s, not x. That would be equals to 0.7 delta of s plus 1 plus 0.3 delta of s minus 1. There you go, this is the answer, right? So sometimes they can ask you the expression of PMF or PDF. This will be the expression of PMF only. What do you think, what will be the expression of PMF? From this particular expression, if you write down PS of s, what it will come out? PS of s. Do you remember this thing? This used to be your x of n versus n. Let's just say here it was giving you amplitude of minus 3 and this was giving you amplitude of, let's just say this is giving amplitude of 3, or let's call it amplitude of 0.7 only. This is giving amplitude of 0.7 and this is giving you amplitude of 0.3. So how will you write down your x of n? X of n will be 0.7 delta of n plus 1 plus 0.3 delta of n minus 1. This is how you will write down. So how will I write down here? 0.7 delta of s, delta of n, so this n. So delta of s plus 1 plus 0.3 delta of s minus 1. So expression of PMF or PDF will be the same, because in the options what may happen is that they will frame this question and they will ask you the PMF of random variable s, and they will frame these options. So you know how to draw the graph, you know how to find out the probabilities, then you need to write down the expression. That's it. This is the bottom line, right? Just find the expression, nothing else. So this is how you can find the expression. What is the next question? If received signal R is given as S plus N, what is N? N is a zero mean unit variance Gaussian noise. So what is your N? N is also a random variable. N is a Gaussian random variable having zero mean and unit variance. N is a zero mean unit variance Gaussian noise. Find the expected value of R. So expected value of R would be equals to expected value of S plus expected value of N, right? So what we need to do, we need to find the expected value of S. So what will be the expected value of S? So from here I can find out the expected value of S. That would be equals to S is taking value minus 1, the probability is 0.7, plus S is taking value 1, the probability is 0.3. So what is the answer? Minus 0.4. S takes the value minus 1, probability is 0.3, S takes the value 1, probability, sorry, minus 1, probability is 0.7, plus 1, probability is 0.3. So what is the answer you are getting? Minus 0.4. So minus 0.4 plus what is the mean of random variable n, that is 0. So what is the answer? Expected value of R. So expected value of R is coming out to be minus 0.4. So this is the answer of second one. Here another thing is there, for finding the expected value of S, you don't need the PMF. How will you find the expected value of S? Expected value of S I need to find. I know that what is the relation between S and X, that is 2x minus 1. So 2 into expected value of X minus 1. Now I just need to find the expected value of X. So what will be the expected value of X? As X takes the value 0, here only I am finding the expected value of X. X takes the value 0 with the probability 0.7, X takes the value 1 with the probability 0.3. So what is the answer? 0.3. So expected value of X is 0.3. So here you put 0.3 minus 1. So what is the answer you are getting? Minus 0.4. So expected value of S is coming out to be minus 0.4. So you are having a lot of methods, whatever that work for you in the examination, that method you are going to use. Whatever that works in the examination hall, that you will use. You are having a lot of method. Expected value of S is minus 0.4, minus 0.4. Here expected value of X was 0.3. From here you can get the expected value of S as well, minus 0.4, minus 0.4, and then you go to know that expected value of R is equals to expected value of S only, which is minus 0.4 only. So very easy question, very straightforward, nothing different is there. Every single thing you already know. Let's go to the next question. Now you are doing discrete random variable to discrete random variable transformation. Here also the same thing happened, no? This was a discrete random variable and S also became discrete random variable only. This was a discrete random variable and this also became discrete random variable only, right? Here this was a continuous random variable, X was a continuous random variable, this also became a continuous random variable only. So in linear transformation, nature was nowhere changing. Like if it was uniform continuous random variable, then you are getting uniform continuous random variable. If it is Gaussian continuous random variable, then you are getting Gaussian continuous random variable. Now if it was discrete random variable, then here also you are getting discrete random variable only. So there are other ways as well for discrete random variable to discrete random variable transformation. So what you are going to do, you are going to transform your discrete random variable from discrete random variable to discrete random variable only. What is the meaning of that? What is this X? X is a discrete random variable. What is this y is equals to x square. What is the relation given? Y is equals to x square. The relation is not linear, but the question is based on discrete random variable. It will be very easily solved. How it will be solved? These are the values of x. X can take value -2, -1, 0, 1 and 2, and all the probabilities are 1 by 5. What does that mean? That if your x is taking value -2, or if your x is taking value -1, or if your x is taking value 0, or if your x is taking value 1, or if your x is taking value 2, all the probabilities are 1 by 5. Now let's just say in the examination this question came, find the variance of y. So what is the relation given? Y is equals to x square. So can you write down sigma of y square equals to what? Can you write down anything? Basically, if it was the scene y equals to -2x plus 3, then I can write down sigma of y square is equals to 4 sigma x square, and 3 is a constant that will be gone. But here the linear relation was there, no? So for the linear relation y equals to ax plus c or ax plus b, for this relation we wrote down that sigma y square would be equals to a square sigma x square. And for another relation we wrote down the thing. What was the relation? So let's write down what all we already know. We know that if y equals to ax plus b is given, then I write down sigma of y square is equals to sigma of x square. And if y equals to ax plus by is given, then what do I write down? Okay, z equals to ax plus by is given. If z equals to ax plus by is given, so what do I write down? Sigma z square will be equals to a square sigma x square plus b square sigma y square plus 2ab sigma xy. So these things I know, but I don't know. So these things I know, but I don't know anything for these two guys. If y is equals to x square is given, then I don't know what is sigma y square. So surely I have to find the PMF of y now. So basically this problem cannot be solved directly. I have to find the PMF of y. This is the bottom line now, right? So let's find the PMF of y. So what all values y will take now? What is the relation? Y is equals to x square. When x can take the value -2, when x is -2, what will be the value of y? 4. Just let me know another thing. When x is +2, because x can take value +2 as well. When x is +2, what is the value of y? 4. When x is -1, what is the value of y? 1. And when x is 1, what is the value of y? 1. When x is 0, what is the value of y? 0. Right? So basically y can take value 1, 4 and 0. So y can take these values 0, 1, 4. So this was a discrete random variable. This is also discrete random variable. So point is, just by some transformation you can never go from discrete to continuous. This process is not possible. From discrete to continuous you cannot go. Now someone can say that, sir, I will define a random variable y where x is a discrete random variable plus n is a Gaussian noise, like this previous question. So now here this r random variable will be continuous, because what you are doing, n is taking continuous values and s is taking discrete values. So kind of you can say that r will be mixed random variable. It will not be purely continuous because s is taking discrete value and n is taking continuous value. So it will be a mixed random variable. But from discrete to continuous you can never go. This was discrete and you ended up getting discrete random variable only. Discrete to continuous you can never go. Okay. This is just a point, no one will ask you. The point is that now you are doing that discrete random variable to discrete random variable transformation. So what you got to know is that x was taking value -2, -1, 0, 1, 2. Now our y is taking value 0, 1, 4. So probability of y taking value equals to 0 will be equals to, when your y will be equals to 0, when your x is equals to 0. If your y is equals to 0, then x will be also equals to 0. So probability of x taking equals to value equals to 0 will be equals to 5. Probability of y taking value 1, what that would be equivalent to? When y can take value 1, when x is -1 or +1. y equals to 1 is equivalent to when x is minus 1 or x is plus 1. So that would be 1 by 5 plus 1 by 5 would be 2 by 5. And when y can take value 4, what is the relation given? Y equals to x square, y equals to x square. So if y is 4, that means x can take value minus 2 and 2. That means x can take value minus 2 or 2. So x taking value minus 2 is 1 by 5, x taking value 2 is 1 by 5. So 1 by 5, 1 by 5 will be 2 by 5. So this is the PMF of y. Are you able to understand this point? So PMF of y also you have find out. You can draw the diagram. I will directly write down the expression. So let me know if you guys can relate or not. Fy of y will be 1 by 5 delta y plus 2 by 5 delta y minus 1 plus 2 by 5 delta y minus 2. There you go. Sorry, 2 by 5 delta y minus 4. There you go. This will be the PMF of y. Do you agree to this point or not? PMF, or you can say PDF of y. Y is taking value 0 with the probability of 1 by 5. Y is taking value 1 with the probability of 2 by 5. Y is taking the value 4 with the probability of 2 by 5. What I need to find? I need to find the variance of y. So variance of y I need to find. That will be equivalent to expectation of y square minus expectation of y whole square. Right. So let's find out expectation of y square. So what all values your y square can take? If y is taking value 0, y square will be 0 only with the probability of 1 by 5. If y is taking value 1, then y square will also take value 1 only. So here I should put square. Here I should put square with the probability of 2 by 5. And if y is taking value 4, with the probability of 2 by 5. Right? So what you are getting? 2 by 5 plus 32 by 5. That would be 34 by 5. This is your expectation of y square is coming out to be. What will be your expectation of y? Expectation of y will be 0 into 1 by 5 plus 1 into 2 by 5 plus 4 into 2 by 5. 10 by 5. Say yes or no. Are you able to understand this point? This will be 10 by 5. Why is that so? Because value of y 4 into 2 by 5. This much till this point you should be able to calculate all these things. This you should not be checking, because you have been studying random variable for roughly around 12 hours now. It's been 30 hours I guess. So in 13 hours I guess you should be able to find out these values at least. So expectation of y is 4 into 2 by 5, 1 into 2 by 5, 0 into 1 by 5. So answer is 10 by 5. Here it is 34 by 5. So what will be the answer? 34 by 5. 10 by 5 is equals to 2 minus 4. 14 by 5. So sigma y square is 14 by 5. Yeah, so this is the answer. So here if this question was coming, they would surely ask the variance of y, because here you cannot apply any formula now. You have to find out the PMF and then only you will find out the variance of y. And how will you find out the PMF? Very easy process. Whatever the value x is taking, based on that you find out whatever the value y will take and then write down the probability. Now if you need to find out the variance, then what you know is that y can take value 0, 1, 4, 0, 1, 4. It can take value 0, 1, 4. So probability of taking value 0 is 1 by 5. Probability of taking value 1 is 2 by 5. Probability of taking value 4 is 2 by 5. Right? So 0 square into 1 by 5, 1 square into 2 by 5, 16 into 2 by 5, 32, 34 by 5. And then expectation of y, 0 into 1 by 5, 1 into 2 by 5, 4 into 2 by 5. So 10 by 5, answer is 2. So 34 by 5 minus 4, 14 by 5, this is the answer. Okay. What is the answer? 14 by 5 is the answer. Well and good. Let's go to the next question. X and Z are independent discrete random variable. Okay, X and Z are independent discrete random variable. They are independent of each other. Probability of X taking value 0, probability of X taking value 1, probability of Z taking value 0, and probability of Z taking value 1 is given. Another random variable Y is defined as X XOR. This is your XOR. Okay, this is XOR. X XOR Z. You need to find the PMF of Y, you need to find the expectation of Y. So let's just say only this question was given. Find the expectation of Y. Okay, so will you do this thing? Y is given as XOR operation. Okay, so expectation of Y will be equals to expectation of X XOR Z. Till this point, no issue. So will you do this? Expectation of X XOR expectation of Z. There is no property like that, right? There is no property like that. Here I told plus minus could be there, but I did not teach about XOR. So no property, nothing you can apply now. First you will have to find out the PMF of Y. Then only you can find out the expectation of Y. So first thing is, if this question is coming, then you cannot solve like this. That I will find the expectation of X, I will find the expectation of Z, and then I will do XOR operation. You cannot do like that. So first thing is, I need to find the PMF of Y. So how will I find the PMF of Y? My first target would be what all values Y can take. So what do you think what all values Y can take? So X can take values 0 and 1, and Z can take value 0 and 1. And what is your Y? X XOR Z. So what may happen? First, X is taking value 0 and Z is also taking value 0. X is taking value 0, but Z is taking value 1. X is taking value 1, but Z is taking value 0. X is taking value 1 and Z is also taking value 1. All these scenarios can happen. Are you able to understand this point? X is taking value 0 and Z is taking value 0. X is taking value 0, Z is taking value 1. X is taking value 1, Z is taking value 0, and X is taking value 1 and Z is taking value 1. All these scenarios can happen. That means Y can take only two values. What that would be? 0 and 1 only. Y can also take 0 and 1 only. What do you think? What will be the probability of Y taking value 0? When you can get Y equals to 0? What do you think? What will be the probability of Y taking value 0? When you can get Y equals to 0? You can get Y equals to 0 when X equals to 0 and Z equals to 0, or when X is equals to 1 and Z equals to 1. Say yes or no. X equals to 0, comma means and means intersection, plus X equals to 1 and Z equals to 1. X equals to 1 and Z equals to 1. Can I write it down like this? Can I write it down like this? And I have replaced with multiplication. When I can do so? Only when independent random variables are given. That means X and Z are independent. There is no relation between X and Z. X and Z are not depending on each other. That means what probability of X taking value 0 multiplied with probability of Z taking value 0 and plus probability of X taking value 1 multiplied with probability of Z taking value 1. Probability of X taking value 0, 0.6 into 0.7 plus 0.1 into 0.3, 0.42 plus 0.12, that would be equals to 0.54. So probability of Y taking value 0 will be 0.54. Now if someone asks you probability, what we have got, probability of Y taking value is 0.54. So what do you think what will be the probability of Y taking value 1? Y can take only two values, that are 0 or 1. So if it is taking value 0, probability is 0.54. If it is taking value 1, probability will be 0.46, which is pretty obvious, or you can calculate as well. When it can take value 1? When X is taking value 0 and z is taking value 1, or when x is taking value 1 and z is taking value 0. So x is taking value 0, 0 and 1, 0.6 into 0.3, 0.6 into 0.3 plus 0.7 into 0.4. 0.44, sorry, 0.46, really sorry guys, 0.46, and which is pretty obvious, no? If it is taking value y having probability of 0.54, you know that it can take only two values. That means this will be 1 minus 0.54, that would be 0.46. So you have got the PMF of y. Now if I am asking you what is the expectation of y, so y is taking value 0 with the probability of 0.54. Y is taking value 0 with the probability of 0.54, and y is taking value 1 with the probability of 0.46. So expectation of y is 0.46. This is the answer. Right, expectation of y is 0.46. Very simple. So here as well I tried doing something different, but again discrete random variable, this y was also discrete random variable. So very simply, this is very simple. First we studied about linear transformation. In linear transformation I told you one thing, the nature of random variable will not change. That doesn't change, very easily I can solve the problem. Then discrete random variable to discrete random variable transformation, just we are seeing that some expression is defined, some relation is defined. Based on that I can find out the values, that what all values your random variable y can take. What all values here your random variable y can take, and based on that I can write down their probabilities and I can calculate expectation, variance, whatever they want me to calculate. All good, all fine. Let's go to this question. You try doing it on your own. X is taking value 1, 2, 3, 4. Probability of x taking value 1, probability of x taking value 2, probability of x taking value 3, and probability of x taking value 4 is given. Now random variable y is defined in this manner that y will be equals to x when x is even, and y will be equals to 5 minus x when x is odd. You need to find the value of fy of 4 minus fy of 2. What does that mean? That you need to find the probability of y taking value lesser than equals to 4 minus y taking value lesser than equals to 2. This is what you need to find. This is what you need to find. So try doing it. So this can be written as probability of y taking value 2 to 4. Is this how I can write it down? Or if you don't want to write down in this manner, then also you can solve it. But the important part would be that what all values y will take. So try doing it on your own. I will take a break and then I will come back. Okay, this is a very good question. You try it on your own. Yeah, welcome back. So did you try this question? So here what is our target? Our target is to see what all values our y can take. But first we will see what all values x can take. So x can take values 1, 2, 3 and 4. These values x can take, right? Now y is defined when x is even, when x is odd. So basically you need to see that at this time x is odd. When x is taking value 2, it is even. Here it is odd. When x is taking value 4, it is even. So what they are saying, the value of y will be equals to when your x is equals to 1, when x is equals to 1, that means x is odd. So what will be your y? Y will be equals to 5 minus x. Y will be equals to 5 minus x, that means y will be 4. So basically what did you get to know? That when x is 1, y is 4. Now when x is 2, that means it is even. So what will be your y? Y will be, when x is even, then y will be equals to x. Y will be equals to x. So when x is 2, y will be equals to 2. When x is 3, what it is? X is equals to odd, right? X is 3, x is odd. So when x is 3, y is equals to 5 minus that number, that is equals to 2. So when x is 3, y is equals to 2. And when x is 4, that means it is even. So at that time y will be equals to what? Y will be equals to 4. So y can take only two values. Y can take only two values. Y can take only two values, which are 2 and 4. So probability of y taking value equals to 2. that would be equals to when y can take value 2, when x is equals to 2 or x is equals to 3. That would be equals to when x take value 2 or x take value 3. Are you able to understand this point? When x is taking value 2, y is equals to 2. When x is taking value 3, y equals to 2. So what is the probability of x taking value 2 and 3? That is 1 by 8 plus 1 by 4. 1 by 8 plus 1 by 4. What that would be? 3 by 8. And surely you know that y taking value 4 will come out to be 5 by 8. And you can check as well. How will you check? Y taking value x equals to y taking value 4. So when it can take when y can take value 4, when your x is equals to 2, sorry, not x equals to 2, when your y can take value 4. Y can take value 4 when x is equals to 4 and x equals to 1. When x is equals to 4 or when x is equals to 1. X equals to 4 plus x equals to 1. X equals to 4 plus x equals to 1. 3 by 8 plus 1 by 4. 3 by 8 plus 1 by 4. That would be equals to 5 by 8. So y equals to 2 is 3 by 8, y equals to 4 is 5 by 8. So y is taking value, these two values, and these are the probabilities. What they are asking? They are asking fy of 4 minus fy of 2. Fy of 4. That will be equals to probability of random variable y taking value lesser than equals to 4. That means y can take only two values. And 5 by 8 plus 3 by 8, that will be 1. And next what they are asking, fy of 2, that means probability of y taking value lesser than equals to 2. That means it can take value equals to 2. So what is the probability? 3 by 8. So basically I need to subtract both of them. So fy of 4 minus fy of 2 is coming out to be 1 minus 3 by 8, which is equals to 5 by 8. This is the answer. Very simple, very simple question. Nothing different is there. Only the way of defining is different. When x is even, y is equals to x. When x is odd, y is equals to 5 minus x. So when x is odd, y equals to 5 minus 1. When x is even, y equals to 2. When x is 3, that means it is odd. So 5 minus 3, 2. When x is even, that means it is 4. When x is 4, that means it is even. So y equals to 4. So y can take two values, 2 and 4. What is the probability of y taking value 2? X could be 2, x could be 3. What is the probability of y taking value 4? That would be 1 minus 3 by 8, or you can check from here, it would be 5 by 8 only. Right? Next they are asking you fy of 4 minus fy of 2, which is practically probability of y taking value 4 only, because here what they are saying, value of y should be less than equals to 4. That means value of y could be 2 or 4. Probability is 1. Probability of y taking value less than equals to 2. That means value of y could be only 2. So this is 3 by 8. So 1 minus 3 by 8 would be equals to 5 by 8. Now x1 and x2 are two identical and independent random variable. What is the meaning of identical and independent random variable? That means both guys are same, ditto same. Everything is same about them. They are taking value 1, 2, 3. They are having the same probability as well. So everything is same, but they are independent of each other. They don't depend on each other. Basically, there is some guy who looks like me. His job is also teaching. His company name is also PrepFusion. He also teaches for electronics and communication engineering. He does the same, but I don't know him, and neither he knows me. Same face, everything is same, but two guys don't know each other. That means they are identical and independent of each other. That means x1 and x2 will take the same values with same probabilities, but let's just say if x1 is taking value 1, so it will not depend on the value of x2. Whatever the value x1 is taking, it will not depend whatever the value x2 will take. And whatever the value x2 is taking, it will not depend whatever the value x1 will take. They both can take any value independently. Identical and independent random variable. So it will be written as IIDRV. A lot of times I will be using this text, or you can say I will be using this word IIDRV. So identical and independent. And examples would click to you. Everything is same, just they are independent of each other. Well and good. Okay. So x1 and x2 can take value 1, 2 or 3. Their probabilities are, if I take the value 1, 0.2, if I take the value 2, 0.5. If I take the value 3, 0.3. These are their probabilities. What you need to find? We are defining another random variable m, which is maximum of x1, x2. And we are defining another random variable small m, which is minimum of x1, x2. So you need to find the PMF of capital M and small m. Then you need to tell me capital M and small m are independent or not. And then you need to find me the value of capital M taking value 3, given that small m has already taken value 3. What I mean to say, what is this question? Probability of C question is given. Probability of m taking value 3, given that this is the conditional probability. Small m has already taken value 3. So this is the C question. Okay, if you are not able to see, this is what I have written in the C option. So think about it and let me know what will be the answer. Do you understand the meaning of maximum of x1, x2? That means let's just say what will be the maximum of 1, 2. What is the maximum value between 1 and 2? That would be 2. What will be the maximum of 1, 3? What is the maximum value between these two? 3. What will be the minimum of 1, 2? 1. What is the minimum value between 1 and 2? What will be the minimum of 2, 3? 2. What is the minimum value between these two? That will be 2. So how many scenarios could be there that x1 is taking value 1 and x2 is taking value 1? x1 is taking value 1 but x2 is taking value 2. x1 is taking value 1 but x2 is taking value 3. Then more scenarios will be there. So basically 9 scenarios will be there. Are you able to understand this point? That x1 is taking value 1 and x2 is taking value 1. x1 is taking value 1, x2 2. Because what do we know is that x1, x2 are identical, taking values 1, 2 or 3. So 1, 1, 1, 2, 1, 1, 1, 3. This guy is taking value 2, 1, 2, 2, 2, 3. This guy is taking value 3, 1, 3, 2, 3, 3. What is the maximum of x1, x2? Maximum of 1, 1. Both are equal only, so maximum of 1, 1 will be 1 only. Who is larger? I earn 10,000 per month and some guy is earning 10,000 per month. Who is earning more? 10,000 per month only, no? Right? If both are same, that means that is the maximum, that is the minimum as well. Are you able to understand this point? Who is earning minimum? 10,000 only, right? So who is maximum? 1. Who is minimum? 1. Who is maximum here? Who is the maximum between 1 and 2? 2. Who is maximum here? Who is minimum here? 1. Between 1 and 3, who is maximum? 3. Who is the minimum? 1. Between 2 and 1, who is the maximum? 2. Who is the minimum? 1. Here, who is the maximum here? 3. Who is the minimum? 2. Who is the maximum here? 3. Who is the maximum here? 3. Who is the maximum here? 3. Who is the minimum here? 1, 2 and 3. There you go. This table will you be able to make? Very easily I can make this table. Right? Maximum are 1, 2, 3. Then here 2, 2, 3 and there here 3, 3, 3. Here minimum are 1, 1, 1. Then 1, 2 and 2 and then 1, 2, 3. Now what they are asking? Now what is this? This is your random variable m. So what all values your random variable m can take? Your random variable m is taking value 1, 2 and 3. Your random variable, what I mean to say is that your random variable m is taking value, your random variable capital M is taking the value 1, 2 or 3. Now if I ask you what is the probability such that m is equals to 1, what will be your answer? M is equals to 1. So when you can get capital M equals to 1? In this condition only. Capital M equals to 1 only in this condition. What is that condition? The condition is such that x1 is taking value 1 and x2 is also taking value 1. Since there is an and sign and they are independent of each other, x1 and x2 independent of each other, what I can do? Probability of x1, probability of, right? When your capital M could be 1, from this table you know that this is the condition when x1 equals to 1, x2 equals to 1. x1 equals to 1 and x2 equals to 1. What is the probability of both of them? 0.2 into 0.2. What will be the answer? 0.04. When your capital M could take value 2. Now here there are a lot of conditions. When it can take value 2, 1, 2, and 3. So 3 conditions are there. What all are those 3 conditions? When x1 is taking value 1 but x2 is taking value 2, or when x1 is taking value 2 and x2 is taking value 2, or when x1 is taking value 2 and x2 is taking value 1. These are the 3 conditions. 1 2 2 1 2 2. How did I write it down without looking at the table? How did I write it down without looking at the table? I was thinking 1 and 2, what will be the maximum? 2. 2 and 2, what will be the maximum? 2. 2 and 1, what will be the maximum? 2. So these are the only conditions. Can you think of any other condition such that the maximum value becomes 2? No, there is no other condition. So you can think as well if you are able to think. So that would be equivalent to x is taking value 1. Basically x1 taking value 1. What is the probability? 0.2. Multiply with x2 taking the value 2. x2 taking the value 2. What is the probability? 0.5. Both are having the same probability. If someone asks you what is the probability of x1 taking value 1, that would be equals to x2 taking value 1. Both are equal 0.2. If someone asks you what is the probability of x1 taking value 2 and x2 taking value 2, both are equal 0.5. And if someone asks you x1 taking value 3 and x2 value taking value 3, both are equal, will be equals to 0.3. So identical and independent, identical and independent, right? Now both are taking value 2 2, both are taking value 2 2. So 0.5 into 0.5 plus 2 1 2 1, 0.5 into 0.2, 0.5 into 0.2. So what you are getting? 0.1, 0.25 plus 0.1. So what you are getting? 0.45. Now what is the probability such that m will take value 3? What do you think? What will be the probability? Do I need to calculate? No. What I will do? 1 minus 0.04 minus 0.05, because I know that total probability will be 1. So what will be my answer? 0.51. So what did I get to know here? That m is taking values 1, 2 and 3 and their respective probabilities are, with respect to 1 it is 0.04, then it is 0.45 and then it is 0.51. So these are their respective probabilities. This is the first case. What is the second case? Small m can take value 1, 2, 3. So what is the probability such that small m is taking value 1? Small m is taking value 1. A lot of cases are there, so I am not interested in that. Here I can see that small m can take value in these cases, these cases, these cases. So a lot of calculation will be there. So I will be interested in this one, such that small m is taking value 3. Small m is taking value 3. So when this case could be there, such that x1 takes value 3 and x2 takes value 3. That would be x1 takes value 3, x2 takes value 3. So 0.3 into 0.3. That would be 0.09. Right? Then I will be interested in this, when it can take value 2. So minimum value should be 2. Minimum value should be 2. So what do you think? What could be the condition? When x1 is 3 and x2 is 2, or when x1 is 2 and x2 is 3, or when x1 and x2 both are 2. Right? Minimum value should be 2. So minimum 2, minimum 2, minimum 2. Nowhere else minimum could be 2. So what will be the answer? x1 taking value 3, 0.3. x2 taking value 2, 0.5. 0.3, sorry, x1 taking value 2, 0.5 into 0.3 plus here 0.5 into 0.5, because for 2 0.5 0.5, otherwise 0.3 0.3. So 0.25 0.25 0.15 0.65 0.25, right? Okay, there is a mistake, 0.3 plus 0.25, so that would be 0.55. So this would be 0.64. That would be 1 minus 0.09 minus 0.55. So that would be equivalent to 0.36. 0.36. So here you can see that small m is taking value 1, 2, 3. Here I should not write small m, right? Probability of m taking any value. I'm taking some value, because if I write down small m, because small m is another random variable, no, so I cannot write down small m here. So probability of small m taking any value, that is, if you take value 1, that is 0.36. If you take value 2, that is 0.55, and if you take value 3, that is 0.09. So any of the question could have been asked, right? What they are actually asking, PMF of m and small m, capital M and small m, these are the PMF that we have already written here. So this is the answer. These are the PMF: 0.36, 0.55, 0.09. Right? These are the PMF. Next, they are asking if capital M and small m are independent of each other. So let's solve this question. Then we will be able to understand if this option is correct or not. So what I am solving? I am solving the C option. I am solving the C question. What this will be equivalent to? Probability of capital M taking value 3, capital M taking value 3 and small m taking value 3 divided by probability of small m taking value 3, right? So what does that mean? That capital M should take value 3 and small m should take value 3. So let's go to this table. Capital M and small m both should take the value 3. That means only this case will come into action, no? Only this case will come into action. Are you able to understand this point? Capital M and small m both should take value 3. Intersection means and. So both should take value 3. So only this case will come into action, such that x1 is 3 and x2 is 3. Such that x1 is 3 and x2 is 3 divided by probability of small m taking value 3. Probability of small m taking value 3, which is 0.09. Small m taking value 3. Small m taking value 3, which is 0.09. So here x1 taking value 3, x2 taking value 3, both are 0.03, 0.3 divided by 0.09. That would be equals to 1. So what does that mean? If small m has taken value 3, that means for sure capital M will take the value 3. That means if minimum of x1, x2 is 3, then surely maximum of x1, x2 will be 3 only. What I mean to say, if minimum of x1, x2 is 3, then surely maximum of x1, x2 will be 3 only. Can you see it? Is there any other case where you can get minimum of x1, x2 equals to 3? Is there any other case where you can get small m equals to 3? No, there is only one case. So if this case is happening, then surely you are getting capital M equals to 3 only. That's why the probability is 1. Otherwise, if you don't want to see by the concept, then you can see by the expression as well. What we are getting? Probability of capital M equals to 3 and small m equals to 3. That means only one case would be there. By this table you can see only one case could be there. x1 equals to 3, x2 equals to 3. x1 equals to 3 and x2 equals to 3 divided by probability of small m equals to 3. Probability of small m equals to 3. So divided by probability of small m equals to 3, which we have already find out, 0.09. So answer is coming out to be 1. So answer of this question is coming out to be 1, which is surely not equals to probability of m equals to 3, because probability of capital M equals to 3 is 0.51. Are you able to understand this point? This is 0.51. But if your capital M and small m were independent, if they were independent, do you remember this? For independent event, probability of A by B would be equals to probability of A. That means event A will not depend on event B. But here what do you see? Capital M is depending on small m. So yeah, it is not coming out to be. So are they independent? No. Now just think about it without even solving this problem. Without even solving this problem, just think about it. Can capital M and small m be independent? No, because both are depending on x1, x2. Basically, your brother, your elder brother, and you, both of you are depending on your parents, no? So can you be independent of each other? No. This guy is depending on your parent and you are depending on your parent. Both are, capital M and small m will be defined by the value of x1, x2. Both are depending on the same variable. That means both of them cannot be independent, no? x1, x2 can be independent. But how capital M, small m will be independent? Because though both are the function of x1, x2. The function is different. Here maximum function is there, here minimum function is there. But they are function of x1, x2 only, no? That means your elder brother and you are also depending on each other. This guy is depending here, this guy is depending here. So that means both of you are surely depending on each other. Are you able to understand this point? Although this analogy is not that good, okay, because someone will argue, I don't depend on my elder brother. So this analogy is not that good, but try understanding from here that capital M is depending on x1, x2, small m is also depending on x1, x2. So surely your capital M and small m will depend on each other, no? If I say my small m is x1 plus x2, sorry, my capital M is x1 plus x2 and my small m is x1 minus x2. And if I ask you, capital M and small m, are they independent of each other? Answer will be no. They are depending on each other. Why they are depending on each other? Because it is pretty simple that capital M is also a function of x1, x2 and small m is also a function of x1, x2. So surely they are depending on each other, right? Okay. Yeah, fine. But whatever that I said previously, I don't think that is 100% correct. Because like, let's just say this is my capital M, x1 plus x2, and this is my small m, x1 minus x2. Okay. And I am saying that x1 and x2 are independent. x1 and x2 are independent. This is I am saying they are independent. This I am saying. And then I am defining capital M, then I am defining small m. Okay. Now from here, what will be the value of x1? That will be this. And what will be the value of x2? That will be equals to this. Capital M minus small m divided by 2, capital M plus small m divided by 2. So this is the value of x1, this is the value of x2. Right? Now I am saying that x1 and x2 should be independent. But x1 is also a function of m plus m. Basically, x1 is also a function of capital M and small m, and x2 is also a function of capital M and small m. So according to this, you can say that x1 and x2 cannot be independent, but I am saying that they are independent, right? But here, what is the scenario? These two are depending on each other, no? Here they are not independent. Capital M and small m are not independent. So by adding up or by subtracting up, they can cancel their independency. Are you able to understand this point? So what I should have said, that this capital M is a function of two independent random variable and small m is also a function of two independent random variable, then I can say that capital M and small m will be depending on each other. Let me repeat the statement. If you want to write down, you can write down somewhere this particular statement as well. That what I am saying, that your capital M is a function of two independent random variable and your small m is also a function of same independent random variable. Whatever capital M was function of, small m is also the function of same independent random variable, then I can say that capital M and small m will be depending on each other. But what if x1 and x2 are not independent? Then I cannot comment anything about capital M and small m. Are you able to understand this point? Okay. Otherwise, if you don't want to go into complexity, then simply you can take any value, take any random value, capital M equals to 3 divided by small m equals to 3, calculate this and you will get to know that yes, they are not coming equal. then your job will be done. Basically here this intersection cannot be converted into multiply, because if capital M is 3, then it can affect the value of small m as well. Or if small m is 3, it can affect the value of capital M as well. Basically, if I say my small m is 3, that means minimum of 2,3. Okay. What I am saying that my small m is 3, that means minimum of x1 and x2 is equals to 3. Then surely your maximum value will be defined, no? Because minimum of x1, x2, 3 could be there in only one condition. What is that? That is, this should also be 3, this should also be 3. Then only minimum of 3, 3 will be 3. That means maximum of 3, 3 has to be 3 now. Are you able to understand this point? So whatever the minimum value you are getting, that is affecting your maximum value as well. So surely they are depending on each other, right? So just by understanding about the random variable, you can also comment. You don't need to do the calculation all the time. Just by thinking about the random variable, that what all values it can take, if a particular value is being affected by the other value or not. So in that manner also you can think, right? Let's go to the next topic. You can say, or again we are studying the transformation only. Now what you are doing, a continuous random variable will be converted to discrete random variable. What we have seen, discrete random variable to discrete random variable, right? And I told you, from a discrete random variable to, you cannot go to continuous random variable. Now we are going from continuous random variable to discrete random variable. Have we gone to continuous random variable to continuous random variable? Yes. In the beginning example, linear transformation. In this linear transformation, this was continuous. PDF of y was also continuous. So we were going from continuous to continuous. But all the examples we did not see. We only saw few examples, not all the examples. So here more examples we will see. But whatever the example that are remaining, they are not important. Here only one kind of example is important. What is that? Y equals to ax plus b. Only this kind of example is important, that we have already seen. Other examples will also come which are not important. So this we have seen, this is not even possible. Now this we are going to see. So in the examination, you don't need to think that, sir, from which particular topic the question is coming. In the examination, you will see the question. Next, what you will see, that what all values my other random variable can take, and based on that you can solve the problem. That's it. So here this question was given that x is a uniform PDF between 0 to 5. Another random variable y is defined. The relation between x and y is given by this graph. So here what you can see, that x is taking non-zero value between 0 to 5. X is taking value between 0 to 5 only. After that, x is not taking any value. You can say that, sir, x is going from minus infinity to infinity. Yes, I agree. But non-zero values are between 0 to 5 only, no? Right? And forget about the value of x. You know that x will take value from 0 to 5 only in the uniform manner. What about the value of y? So you can see that y can take value 1, 0, 2 and 3. So what I will understand from here, that my y can take values 0, 1, 2 and 3. There you go. This is what I understood. Now what will be my target? What all these are? Discrete values. So what I go to know that it is a discrete random variable. Y can take only values 0, 1, 2, 3. So I go to know that it is a discrete random variable. Now my question will be, sir, what is the probability such that y is taking value 0? So when your y is taking value 0, when your y is taking value 0, y is taking value 0 when x is between minus 1.5 to 2.5. When x is between minus 1.5 to 2.5. Is that the only condition? No. Or when your x is greater than 5 as well. No, because here y is taking value 0, here also y is taking value 0, here also y is taking value 0. These are not the value of x, these are the value of y. No, y is taking value 0, y is taking value 0, y is taking value 0. Y is taking value 1, y is taking value 2, y is taking value 3. So y is taking value 0 when x is between 1.5 to 2.5, or when x is greater than 5, or when x is less than 0. So this is when your y is taking value 0. So what is your fx of x? What is your fx of x? So x is taking value between 0 to 5 in the uniform manner. 0 to 5 in the uniform manner with the amplitude of 1 by 5. So they are saying that probability such that it is 1.5 to 2.5, 1.5 to 2.5, 1.5 to 2.5. So this length is 1 and height is 1 by 5. 1 into 1 by 5. What is the probability such that x is greater than 5? 0. What is the probability such that x is greater than, what is the probability such that x is less than 0? 0. X less than 0, this is also 0 and this is also 0. But what is the probability such that x is between 1.5 to 2.5, 1.5 to 2.5, that is 1 by 5 into 1. So what you are getting? Probability such that random variable y takes value 0, that is 1 by 5, or you can say 0.2. So this is the first thing you are getting. Next, what you need to find? Probability such that y takes value 1. Y takes value 1. So when your y will take value 1? So your y is taking value 1 when your x is between 0 to 1.5. When x is between 0 to 1.5. So when your x is between 0 to 1.5. When x is between 0 to 1.5, y takes a value 1. X is between 0 to 1.5. So what do you think what will be the probability? 1 by 5 into 1.5. That will be equals to 0.3. When your y will take value 2. So y will take the value 2 when x is between 2.5 to 4. When x is between 2.5 to 4. So what will be the answer? 1 by 5 into 1.5, that will be 0.3. And when your y will take the value 3. When your x is between 4 to 5. 1 by 5 into 1, that would be equals to 0.2. So what did you get to know here? PMF of y I have find out. Y can take these values, okay, and the PMF of y such that it takes value yi, that is given by 0.2, 0.3, 0.3 and 0.2 such that I is going from 0 to 3. Kind of I can write down. You understood, right? Y equals to 0 is 0.2. So basically if I need to find out the PDF of or PMF of y, if I need to find out PDF of y or PMF of y, how will I write it down? I will write down y can take the value 0. So at 0 the amplitude will be 0.2 plus y can take the value 1, amplitude will be 0.3. You draw the graph and you write down this expression. And y can take the value 2, amplitude is 0.3. Then y can take the value 3, amplitude is 0.2. There you go. This will be the expression that will be mentioned in one of the options. Okay, so this will be your answer. Find the expression of fi of y, find the expectation of y. So shall I leave it on you? Can you do it on your own? Expectation of y. Expectation of y. So 0 into 0.2, that would be 0. 1 into 0.3, 0.3. 2 into 0.3, 0.6. And 3 into 0.2, 0.6. 3 into 0.2. And 2 into 0.3. 1 into 0.3, 0 into 0.2. So what is the answer you are getting? 1.5. This is the answer. Okay, so expectation of y is 1.5 and the expression I have already written here. Let's go to the next question. This is a gate question, okay, gate PYQ it is. So try doing it on your own. It is much easier than the previous one. So what they have given, x is uniformly distributed random variable, PDF is given. What do you think? What is the PDF of fx of x? What is the PDF of x? Can you draw the PDF of x? Surely I can draw the PDF of x. Amplitude is 1 by 10. U of x plus 5 minus u of x minus 5. That means it is going from minus 5 to plus 5. At minus 5 there is a jump and then at plus 5 there is a decay. That means it is going from minus 5 to plus 5 with the amplitude of 1 by 10. Is it a valid PDF? Surely it is a valid PDF, right? Surely it is a valid PDF. This is your fx of x. It is passed through a transformation. It is passed through a transformation given in the figure below. So this is the relation between y and x. So what all values your y can take? Y can take value 1, 0 or 0. Y can take only two values, right? Y can take value 1 or 0. So you can see here is that always whenever the question is coming from on transformation, my target would be that what all values my random variable can take. So it can take value 0 or 1. Now I will be thinking when it is taking value 0. So when it is taking value 0, when x is greater than 2.5 or when x is less than 2.5. When x is greater than 2.5 or when x is less than minus 2.5, sorry, when x is less than minus 2.5. At that time only it is taking value 0. Random variable y is taking value 0 only at that time. So greater than 2.5, this is your 2.5, this is your 2.5 and this is your minus 2.5. So that would be 2.5 into 1 by 10. 2.5 into 1 by 10 plus, because this length is 2.5, this length is also 2.5. So 2.5 into 1 by 10, 2.5 into 1 by 10. That will be equals to 1 by 2, or you can call it 0.5. And what is the probability such that y will take the value 1? Which is pretty obvious that it will be 0.5 only. Because if y is taking value 0, it is 0.5 and y can take only two values, that means it will be 0.5 only. Right? Very simple. Or you can calculate as well when it will take the value, basically when your y will take value 1. So y is taking value 1 when x is between minus 2.5 to 2.5. When x is between minus 2.5 to 2.5. So when x is between minus 2.5 to 2.5, so 5 into 1 by 10, what that would be? Because this length is 5, so 5 into 1 by 10, what that would be? 0.5. So what did you get to know? What will be your fy of y? Y is taking value 0 with the probability of 0.5. Plus it is taking value 1 with the probability of 0.5. You can draw the graph, you can draw the PMF. It will take the value 0 with the probability of 0.5. It will take the value 1 with the probability of 0.5. So you can see that 0.5 into del y plus 0.5 into del y minus 1. So this is the answer. There you go. Very simple, very straightforward. Right? Very simple question. Now this question also came in GATE only in 2023. That came in 2006 as far as I remember. I don't actually remember, okay, I'm not sure. It was in 2006 only. I guess it was in 2006 only. And this I remember it was in 2023. Okay. So a random variable x is normally distributed. The information about x is given. Normally distributed between 0 to 1. It undergoes a transformation y equals to hx. The form of probability density function of y is. So this is what they are asking. Basically they are asking what kind of fy of y you will be getting. They are not asking the exact value, but what kind of fy of y you will be getting, where a, b, c are some non-zero constants and gy is a piecewise continuous function. So this is a continuous function. This is a piecewise continuous function. What do you mean by piecewise continuous function? What I am saying, piecewise continuous function. Continuous function. Basically it means that between 0 to 2, let's just say between 0 to 2, this kind of curve I am following. Between 2 to 4, this kind of curve I am following. Between 4 to 6, this kind of curve I am following. So this is piecewise defined. Basically between 0 to 2, there will be different definition. Between 2 to 4, there will be different definition. And between 4 to 6, there will be different definition. So piecewise continuous, but it is continuous function. Okay. So always whenever any question is coming in the examination, read that question carefully. So again it is based on transformation, you got to know. Again the graph between y and x is given. So what do you think, what all values your y is taking? Y is taking discrete value 1, y is taking discrete value 0. Here what you will say, it is taking sir value 1, it is taking value 0, and it is taking value -1. Is that it? Only these three value it is taking? No. It is taking value between -1 to 2, continuous value between -1 to 2, and continuous value between 1 to 2. Are you able to understand this point or not? So what all values your y is taking? Y is taking discrete values -1, 0 and 1 plus continuous values between 1 to 2. Sorry. Did I say 1 to 2? No. This is the value x is taking. Continuous value between 0 to 1. This is the value of y, no? Continuous value between 0 to 1. Continuous value between 0 to 1. And here, continuous value between 0 to -1. Continuous value between 0 to 1 and continuous value between -1 to 0. So what kind of random variable y is there? It is a kind of a mixed random variable. Their discrete part is there, also continuous part is there. Now if I directly go into the options, what I can see? There is only one option where y can take value -1, 0 and +1. There is only one option where y is taking discrete value of -1, 0 and +1. Because if I draw the graph, I will surely get impulses at -1, 0 and +1. Say yes or no? Because it is taking the discrete values, no? In the previous question you can see that it was taking 0 and 1. So you are getting the impulses at 0 and 1. So here it is taking discrete value of 0, 1 and -1. That means you will get the impulses at 0, -1 and +1. That means 3 impulses at -1, 0 and 1 has to be there. Is there any other option? Here impulses are there at 1 and -1. This is a continuous function. This is also a continuous function, so forget about it. Now think. Impulses are there at 1 and -1. This option is wrong because at 0 as well I will have the impulse. Here impulses are there at -1, 0 and +1. This option is at hold. Impulses are there at -2. At -2, y is not even taking the value -2. Y is taking the values between -1 to 1 only. So this option is 1. Here also -2, this option is 1. Only option remaining is B. There you go. But let's solve the question, but this is how I could have answered it. Very smartly. But let's try solving it. So here, let's define y. Let's make the definition of y. So let's define y. So it will be a big definition. So y will take the value 0. Y will take the value 0 when your x is between -1 to 1. When x is between -1 to 1. Y will take the value 1. Y will take the value 1 when x is greater than 2. And y will take the value -1 when x is less than -2. Less than -2. Now, what is this? What kind of graph you can see? A linear graph, right? A linear equation will be there. Y equals to, what is the slope? 1 plus c. That means y equals to x minus 1. And what do you get here? Y equals to, again the slope is +1 only. You can see slope is positive. So you can find out the slope y2 minus y1 upon x2 minus x1. Slope is +1 and y equals to x plus 1. So when x is between 1 to 2, when x is between 1 to 2, what is the equation of y? The equation of y is x minus 1. And when x is between -2 to -1, when x is between -2 to -1, the equation is x plus 1. So this is how y is defined. Are you able to understand this point? And how your x is defined? It is a distributed normal distribution of 0 mean and unit variance. 0 mean and unit variance. So if I need to write down probability of y taking value 0, what I will do? Probability of x taking value between -1 to 1, and that can be written as x taking value greater than -1 minus x taking value greater than 1. Right? So what do you think, what will be the answer of this one? -1, 0 divided by 1 minus q of 1 comma 0 divided by 1. So answer is coming out to be q of minus 1 minus q of 1. Whatever the answer is there, it will be a constant value. Q of minus 1 minus q of 1, that will be a constant value, no? Are you able to understand this point? This, how did I write down? You understood. X should be greater than minus 1, minus x should be greater than 1. That means I will get the value between minus 1 to 1. So whatever the answer I am getting, what is this? A minus mu x upon sigma x. What is the value of A? Minus 1 minus mu x 0 sigma 1. So q of minus 1 minus q of 1. So whatever the answer I get, this will be a constant value. Right? Probability of y taking value 0. What about probability of y taking value 1? So that will be equivalent to probability of x taking value greater than 2. And that will be equivalent to 2 minus mu x upon sigma x. So that will be equivalent to q of 2. Again, this is also a constant value. And what about probability of y taking value minus 1? So that will be equivalent to q of minus 1 minus mu x upon, oh sorry guys, brain fade. Probability of y taking value greater than minus 1. Probability of y taking value equals to minus 1, that will be equivalent to probability of x taking value lesser than minus 2. X taking value lesser than minus 2, right? X taking value lesser than minus 2. That means it should be equals to 1 minus probability of x taking value greater than minus 2. So that will be equivalent to 1 minus minus 2 minus 0 divided by sigma x, that is 1. That will be equivalent to q of 2. Again, this is also a constant value, right? So as per the question, minus 1, this constant value is defined as A, and this constant value is defined as B, and this constant value is defined as C, right? A, B and C. So these 3 points I got to know. Now what about these two guys? These are the linear transformation, no? Y equals to x plus 1 when x is between 1 to 2. When x is between 1 to 2. So y equals to x minus 1. So if your x is Gaussian, and I told you if linear transformation is there, this will surely be Gaussian. So linear transformation will never change the nature of a random variable. So if it is Gaussian, this will also be Gaussian. Although mean and everything will change. Here mean will change, you know. What will be the mean of y? Mean of y would be equals to mean of x minus 1. So mean of x is 0 minus 1 minus 1. And what will be your y square? Sigma y square. That would be sigma x square. This will remain same. That is equals to 1. So basically it will be Gaussian. Fy of y will be Gaussian only when your x is between 1 to 2. When your x is between 1 to 2. So when your x is between 1 to 2, what will be the value of y? Y will be between, if I put x equals to 1 here, so y will be between 0 to 1. And you can directly see here, y is actually between 0 to 1. When y is between 0 to 1, when y is between 0 to 1, you are getting 1 upon under root 2 pi sigma y square e to the power minus y minus 1 whole square upon 2 sigma y square. Sigma y square is 1 only. So this is the expression you are getting when y is between 0 to 1. When y is between 0 to 1. And when your x is between minus 2 to minus 1. When your x is between minus 2 to minus 1. So what is the relation we are following? Y equals to x plus 1. Y equals to x plus 1. So this is Gaussian. And this is also Gaussian. Because linear transformation will never change the nature of a random variable. So here you can see that expectation of y will be equals to 1. How did I write it down? Expectation of x is 0. So expectation of y will be equals to 1. And sigma y square will be equals to sigma x square, which will be 1. And if y is between minus 2 to 1, sorry, if x is between minus 2 to 1, so where your y will be there? So y will be there between, if x is minus 2, so y will be minus 1. And if x is minus 1, so y will be 0. So y will be there between minus 1 to 0. So y will be there between minus 1 to 0. So this is your fy of y, which is having a mean of 1 and variance of 1. Right? So this is the answer we are getting. So Fy of y is like if I define Fy of y in one manner, what I am defining now, I will define Fy of y. So if I write down the definition of Fy of y, what do I get? Although answering the question was not that important. Answering the question was very easy. I could have only see that 1, 0, 1, minus 1. I would have clicked on option B. But if I am defining, so what I am getting? Probability of y taking value 0 is actually coming out to be, I cannot actually define in this manner, no, or I can define it. No, defining Fy of y will not be that good, right? Because here you will have to write down that y is equals to 0. When y is equals to 0, what you are getting? The probability is coming out to be constant b, right? So here I should write down it is b del y. In that manner I need to write down. Are you able to understand this point? When y is equals to 0, the probability is coming out to be b. But when you write down the PDF, you don't write down the probability. When you write down the PDF, you don't write down the probability at a point. PDF never represent the probability at a point. So I cannot write down b here. No. B del y I will have to write. When y is equals to minus 1. When y is equals to minus 1. So it is coming out to be a del y plus 1. A del y plus 1. And when y is equals to 1, it is coming out to be c del y minus 1. And when your y is between minus 1 to 0, minus 1 to 0, it is coming out to be some function of y. Can I call it py? And when it was between 0 to 1, when y was between 0 to 1, when y was between 0 to 1, 0 to 1, it was coming out to be some qy. So now Fy of y I will write down as b, or I will start from a del y plus 1 plus b del y plus c del y minus 1. There you go. This is how I can write it down. So, sorry. Only the discrete value I have written, no. Plus another function will come, which is py and qy. So kind of this is your what they have given in the question, gy. So this will be your gy. So answering the question was very easy actually. In roughly around 1 minute I could have answered the problem, but here I have understood every single aspect of it, that what all values y is taking. So y is, this is a different kind of a transformation where you can get the discrete value as well and you can get the continuous value as well. So for continuous value, I told you another reference would be there, that if a linear transformation will be given, and it is pretty sure, I am 100% sure that if they are giving the continuous value, that means 100% linear transformation will be there. That means if you are going from CRV to CRV, then 99.99% chances are there that they will give linear transformation. Y equals to x square can also be possible when you go from CRV to CRV. If I am saying that x is taking value between 0 to 2 uniformly, another random variable y is defined, that is given as y equals to x square, then find the PDF of y. This question can also be possible, and we will solve these kind of problems. But here you cannot say that, sir, if this is uniform, then this will also be uniform. I did not tell this thing. I told only one thing, that if the relation was x plus b, if it was a linear relation, then you can say that, sir, if this was uniform, then this would also be uniform. Only when linear relation is there. But now non-linear relation is there. So if non-linear relation is there, there will be some other method to find out Fy of y, which will not be used in your digital communication. It will not even be asked as well. Only linear cases will be asked. Okay. Well and good. So you can solve this question. I have given the complete solution, so you can understand it. Now what I have written, we will see more example of CRV to CRV transformation. Okay. Continuous random variable to continuous random variable non-linear transformation. Because linear transformation we have already seen. What we need to see? Non-linear transformation. but those are not much important, so we can see these examples after the next lecture, because next lecture is important. So once the next lecture is done, after that we will see it. This lecture is not completed, okay? In this lecture we are going to see some miscellaneous points, we are going to see some miscellaneous questions we are going to solve. So I guess roughly around 40 minutes it will more take. This lecture will take 40 minutes more. After that we will move to the next lecture. So in the next lecture, first we will solve some questions and then we will proceed to this concept, CRV to CRV non-linear transformation. But since it is not that important, that's why I am taking it for the further lecture. So this topic which we started on the first slide, transformation of random variable, this is actually not completed. This will complete when you cover this part as well. Which part? This part as well. But this part is not that important. It will not be asked in the examination. So that's why we are covering it later on. But whatever the part that we have studied in last 2 hours, that part is very, very important. Well and good. I will take a break and we will solve this question. This is a miscellaneous concept. Now we are studying miscellaneous concept. This concept is not related with whatever that we studied previously. Okay. So this question is not related with the concept that we have studied previously. This is a new question. You also think about it. X, Y, Z are 3 identical and independent random variable. Find the probability such that random variable X is largest. So think about it and let me know your answer. I will take a break and then I will come back. Yeah, welcome back. So did you try this question? I don't think you would be able to solve it. Okay, because this is 3-dimensional random variable. Here there are 3 random variables now, X, Y and Z. So this is 3-dimensional random variable, and I did not tell you how to solve the problems based on 3-dimensional random variable. So how would you solve this question, right? Previously what was the scene, that there were 2 random variables X and Y, and then there was a joint PDF defined, and based on that we were making the graph between X and Y, and then I was asking you probability of X plus Y greater than 1. Then what you would do, you would make the graph X plus Y greater than 1, and this area would have find, this region, this surface area, this surface integration you would find dx dy, and then your answer would come. This was the process for 2-dimensional random variable. For 3-dimensional random variable, it is not important to learn, okay, because it will never come in the examination. I am pretty sure 3-dimensional random variable will never come in the examination, but this question can come. This is a standard problem, okay. So this is a very standard question, and this has been asked as well. In one of the previous years, this question came as well. So this can come. So X, Y, Z, 3 independent and identical random variables are there. You need to find the probability such that X is largest. So identical and independent. So if I am saying that my X is, let's just say, uniform random variable between 0 to 1. So Y will also be uniform random variable between 0 to 1, and Z will also be uniform random variable between 0 to 1. Now what they are saying, that X is largest. What does that mean? That means whatever the value X is taking, that should be larger than Y and larger than Z. So is this the only condition they are asking? No. Whatever the value X is taking, that could be greater than Z and Z is greater than Y. So these 2 conditions are possible, no? Are you able to understand this point? X is greater than Y and Y is greater than Z. X is greater than Z and Z is greater than Y. These 2 conditions are possible. Say yes or no. Do you agree to this point or not? Right? Now along with that, what all possibilities are there? What is the meaning of this? Let's just say X is taking value 0.5. What I am saying, X is taking value 0.5. So now Y has to take value lesser than 0.5 and Z has to take value lesser than 0.5. This is what they are saying. That means X is largest. That means random variable X should take the maximum value. So if X is taking value 0.5, then Y should take value less than 0.5 and Z should take value less than 0.5. There is no condition between Y and Z. If Y is taking 0.3 and Z is taking 0.2, then also I am fine. If Y is taking 0.2 and Z is taking 0.3, then also I am fine. Only condition is this guy should be the largest one. Is that okay for you? Right? So this is what they are asking. But you are saying that, sir, these conditions are possible. Along with that, what all possible conditions are there? It might happen that basically you know that X will take some value, Y will take some value and Z will take some value, because they are between 0 to 1 and they are independent of each other. So this can take independently any value, Y can independently take any value and Z can independently take any value. So they will take some values, that I am pretty sure about that. So let's just say they took the value in a manner that x was greater than y and y was greater than z, and then they took the value in a manner that x was greater than z and z was greater than y. They may take the value in a manner that y is greater than x and x is greater than z, or they may take the value in a manner that y is greater than z and z is greater than x, or they can take the value in a manner that z is greater than y and y is greater than x, or they can take the value in a manner that z is greater than x and x is greater than y. Only these conditions are possible. These 6 conditions are possible. Now someone will say that, sir, z could be equals to x, could be equals to y. This condition can also come. Someone may argue that, sir, z equals to x is equals to y. That means all three are taking the same value. This condition can also come. Now let's go back to our first lecture. What did I tell you? Probability at a point in case of continuous random variable. Let us say at a point in case of a continuous random variable will be equals to 0. So possibility of this event is not even there, no. They are taking so many values and you are saying that z would be equals to x would be equals to y. Is that possible? So this event will not even come into action. That all of them are taking the same value. Are you able to understand this point? They are taking a lot of values, no, 0 to 1, infinite values, infinite values, infinite values. So taking the same value, this condition is nearly next to impossible. So you will never take this condition, z is equals to x, x equals to y equals to z. This will never come into action. So only these 6 conditions are possible. These 6 conditions are possible. So what I am asking, probability of x being largest. So out of these 6 conditions, in 2 conditions x is largest. So what is the answer? 1 by 3. Out of these 6 conditions, this I am cutting down. So this will not even come. Out of these 6 conditions, in 2 of the condition, in this condition and this condition, x is largest. If I had asked you y is largest, what will be the answer? In these 2 conditions, this condition and this condition, y is largest. Out of these 6 conditions, what is the answer? 1 by 3. If I had asked you x is smallest, in how many conditions x is smallest? In this condition and in this condition. 2 out of 6. So here there were 2 random variables. Sorry, here there were 3 random variables. So what is the answer coming out to be? 1 by 3. The answer of x is largest, x is smallest. The answer of y is largest. The answer of z is largest will also come as the same, right? 2 by 6, 1 by 3. The answer of x is smallest is 1 by 3. The answer of y is smallest will also be 1 by 3. And the answer of z is smallest will also be 1 by 3. Right? Will be equals to 1 by 3. And if I ask you, what is the probability that x is equals to y is equals to z? What do you think? What will be the answer? Sir, 0. Do you remember 2-dimensional random variable? There I asked you, what is the probability that x plus y is equals to 1? So I said that it is representing a line. So on a line, probability has to be 0. That means x plus y, probability of x plus y taking value equals to 1 is nearly, it is surely 0 only. Why it is 0? Because it is not even possible, no? How much area the line will take? How much area a line will enclose? That would be 0 only. So similarly, here what will happen? Here x, y, z are three identical and independent random variables. I am saying that x is taking value 0 to 1. Let us say this is x, this is y, and this is z. So x takes the value from 0 to 1, y takes the value from 0 to 1, and z takes the value from 0 to 1. So it will become simply a cube. Here what we used to do, x is taking value from 0 to 1 and y is taking value from 0 to 1. So what we used to make? This was a surface. This was a rectangle. Now here x is taking value from 0 to 1, y is taking 0 to 1 and z is taking 0 to 1. So this will become a cube. Here what we used to do? Double integration, that means I am calculating surface integration. Here what I will do? Triple integration, that means I will be calculating the volume. Although this much concept will not be asked in the examination, that I am pretty sure. Although in the miscellaneous, when the whole chapter ends, when complete communication system ends, in the miscellaneous we will solve some problem of 3-dimensional random variable as well, but they will not be asked, that I am pretty sure. But only this question can be asked. So I'm just telling what is actually happening here. Now if I am saying that x equals to y equals to z, what this will represent? X equals to y equals to z. This will be simply a plane. No, it will not be a plane. X equals to y equals to z. This will not be a plane, right? X equals to y equals to z. This will be equation of plane or not? Yeah, it will be equation of plane only. So this will be equation of plane. X equals to y equals to z will represent a plane. In this 3D, x equals to y equals to z will represent a plane. So just like 2D, on a line, your probability will be 0. Just like in 2D, on a line, your probability will be 0. So just like in the same manner, in 3D, on a plane, your probability will be 0. On a plane. Are you able to understand this point? I am explaining it in a very crude way. In a very rough way, I am explaining it. But just like in 2D, if you are asking the probability on a line that x plus y is equals to 1, that means you are fixing the value of x, fixing the value of y. That means if x is taking 0.5, then y has to take 0.5. X is taking 0.3, y has to take 0.3. And here, if x is taking 0.3, y has to take 0.3, z has to take 0.3. So you are fixing a particular value which is not even possible. So probability of x equals to y equals to z will be equals to 0. If I ask you, what will be the probability of x plus y plus z is equals to 1? That will also be 0. So this is also a plane. X plus y plus z equals to 1. This is also a plane. Are you able to understand this point? This plane will be passing from 1, 0, 0, 0, 1, 0 and 0, 0, 1. So you make these points and then you join them. This will be the plane. So even if I ask this question equals to 1, but if I ask you probability of x plus y plus z greater than 1, then you would say it will be non-zero. X plus y plus z greater than 1, then it will be non-zero. Why it will be non-zero? Because now it will represent a volume. Because x plus y plus z equals to 1 will represent a plane. Now I am saying that x plus y plus z greater than 1. So it will represent a volume like this. Similarly here, if I had asked you probability of x plus y greater than 1, probability of x plus y greater than 1, then it would represent a x plus y greater than 1. So I don't know where it will come, x plus y greater than 1, that 0, 0, yeah. So this would be the region. So this would represent a surface area. This is representing a surface. Since it is representing a surface, so you can calculate the surface integration, it will give you non-zero value. Similarly here as well, x plus y plus z greater than 1, it will represent a volume. So you can calculate the volume integration and it will give you non-zero value. But this was representing a plane. If I give you a plane, let's just say this is a plane, this mobile is a plane, this mobile is a plane. What is the volume it is enclosing? Don't see at the width. I am saying that width is 0. So what is the volume this surface is enclosing? If this is a simple surface, there is no width. What is the surface it is enclosing? Sorry, what is the volume it is enclosing? 0, no. A simple surface will enclose how much volume? 0. This paper, how much volume it will enclose? 0. But this notebook will enclose some value. This notebook will enclose some volume, but this paper will enclose 0 volume, right? So similarly, this is a plane. This is also a plane. So all these planes will enclose how much value? All these planes will enclose how much volume? Volume enclosed will be 0. But this is not an equation of plane. Here, this will enclose a particular volume. So the answer will be non-zero. Is that clear to you or not? Okay. So I hope the concept is clear. What I wanted to deliver here, I hope that is clear to you. So just let me do a small correction. So what was our point here? That if 3 variables were there, if 3 identical and independent random variables were there, probability of x is largest or y is largest or z is largest, 1 by 3, 1 by 3, 1 by 3, z is smallest, x is smallest, y is smallest, 1 by 3, 1 by 3, 1 by 3. So if n these kind of random variables are given, identical and independent random variable, identical and independent random variables are given, x1, x2, x3, n random variables are there, and if I ask you what is the probability such that x1 is largest, answer will be 1 by n, x2 is largest, 1 by n, xn is largest, 1 by n, x1 is smallest, 1 by n, x2 is smallest, 1 by n, and xn is smallest, 1 by n. 4 random variables, I am asking another question, 4 random variables, 4 random variables x, y, z, w are IID random variables. Find the probability, first question, find the probability such that x is largest. What will be the answer? Sir, answer will be 1 by 4. Find the probability such that x is greater than y is greater than z is greater than w. Tell the answer. 1 by 4. What will be the answer? 1 by 4. What do you think? Think about it and write down the answer. Pause the video and write down the answer. What is the probability such that x is greater than y, greater than z greater than w? Pause the video and write down the answer. Okay, I will do the same. Pause the video, write down the answer. So what do you think? What was the answer? 1 by 4 factorial. Actually, I thought of this question here only. Okay, when I am teaching, I thought of this question here only. That's why I had to pause the video, because I also had to make the solution. So answer is coming out to be 1 by 4 factorial. Why is that so? Because here how many combinations were possible? X, y, z are there. X, y, z are there. So they can interchange the position, no? That x is coming at first, y, z. Then x is coming at first, z and y are being interchanged. Then y is coming at first, x and z. Y is coming at first, z and x. Basically, you are having 3 spots. Here you are having any 3 chances that x, y, z, any of them could come. Now, if any of them has come, then here you are left with 2 chances and here you are left with 1 chance. So, basic concept of PNC. What is the answer? 3 into 2, 3 factorial. Similarly, here as well, x, y, z, w. So, one of them can come here. Then here there are 3 chances, 2 chances and 1 chances. Total 4 factorial. So, basically here total 4 factorial, which is 24. So, here total 24 chances would be there. Can you try writing down those 24 chances? I will try writing it down. X is greater than y, greater than z, greater than w. So I am fixing the x. Now I will interchange all of them. So I am fixing the y as well, but I am interchanging w and z. Now what I am doing? In the first place I am bringing the z now. Y and x are interchanged. Now what I will do? In the first place z is there, but x and y. Sorry guys. What I am doing? Blunder. In the first place z is there, but y and w. In the first place, here x and z are fixed, but I am interchanging w and y. Now what I will do? Now I will fix x and w, but I will interchange z and y. I have fixed x and w, but I will interchange z and y. So these are the 6 cases with respect to x being fixed. That means x is at highest. These are the 6 cases. So 6 cases like this for x, 6 cases for y, 6 cases for z and 6 cases for w. So total 24 cases will be there. 6 for x, 6 for y, 6 for z and 6 for w. So total 24 cases will be there. 6 into 4, 24 cases will be there. Out of them, one of the cases x is greater than y, greater than z, greater than w. Is that okay for you? So if they are asking x is largest, that means all these cases will come into action. So answer would have been 6 divided by 24, because in all these cases x is largest. So answer would have been 6 by 24. But if they are asking one particular case, then answer would have been 1 by 24. Did you understand this question? Kind of it is based on mathematics. Okay. But since we are studying random variable, so that's why I thought of dealing it here. Although it could have been solved with respect to 3-dimensional random variable as well, but that we did not study. We are studying it with respect to mathematics. So you need to think of the cases. Okay, x is greater than y, greater than z. This kind of case can come. Okay, x greater than z greater than y. So these 6 cases can come. Out of these, 2 are the desired one. So 2 by 6. And if I am just generalizing it now, that if are n identical random variable. So if n identical random variables are there, so x1 is largest 1 by n, x2 is largest 1 by n, xn is largest 1 by n, x1 is smallest 1 by n, x2 is smallest 1 by n, xn is smallest 1 by n. So similarly x, y, z, w are there, x is largest, answer is 1 by 4. But if x is greater than y, greater than z, greater than w, then answer will be 1 by 4 factorial. So in the similar manner, if I had asked you what is the probability that x1 is greater than x2 is greater than x3 and so on greater than xn, so what would have been the answer? Answer would have been 1 by n factorial. Why is that so? Because you will be having n spaces. You will be having n spaces like this. So here n chances can come, here n minus 1 chances can come, here n minus 2 chances can come, and here 1 chance will come. So this will be n factorial. So total n factorial chances will be there, and one of them will be the desired case. So 1 by n factorial. Nothing you are going to mug up. You are not going to mug up any of these formula, nothing like that. These are just the generalized expression, but you are not going to mug it up. What you are going to do in the examination, you will solve like this, you will think like this. All good, all fine? Let's go to the next concept. These are just the miscellaneous concept that we are studying now. The lecture has ended. Linear transformation lecture has ended, but some miscellaneous concept we are studying as of now. So now what I am asking, given that maximum of x comma y is greater than z, then which of the following statement is true? Solve this question. If maximum of x comma y is greater than z, which of the following statement is true? Let's take the case. Let's take x is equals to 3, z is equals to 2, and y is equals to 1. So what I want to ask, maximum of 3 comma 1, is it greater than z, which is 2? So maximum of 3 comma 1 will be 3 greater than 2. Yes, it is true. That means x is greater than z and z is greater than y, or you can say y is less than z. So if your x is greater than z and y is less than z, then this condition can be fulfilled. X is greater than z and y is less than z. This condition can be fulfilled. Now let's take another example. Let's take another example where your x is 1, z is 2, and y is 3. So what I am asking, maximum of 1 comma 3, maximum of x comma y, maximum of 1 comma 3, is it greater than 2? Yes, because what is maximum of 1 comma 3? That is 3. 3 greater than 2. Yes, that means yes, this statement is true. So what you can understand from here, that x is greater than z and x is less than z and y is greater than z. So yes, this condition is also true. Now if I say x is 3, y is 2, and z is 1. So what I am saying, x is 3, y is 2, and z is 1. So maximum of 3 comma 2 will be 3. 3 is greater than 1. Yes, that means yes, this inequality is true. So here what you can see, x is greater than z, y is greater than z. So this is also true case. That means all of them is true. So maximum and greater sign, you are getting a lot of possibilities, right? But let's see the next question. Maximum and less sign. Okay, maximum and less sign is there. So what they are asking, again, which of the following statement is true? So let's take x is equals to 1, y is equals to 2, and z is equals to 3. So maximum of 1 comma 2 is less than 3. What is the maximum of 1 comma 2? That is 2. 2 is less than 3. Yes, that means x is less than z and y is less than z. So yes, this case is true. Let's take another case. Let's take the value of x equals to 1, y equals to 3, and z equals to 2. X equals to 1, y equals to 3, and z is equals to 2. So what is the maximum of 1 comma 3? That is 3. Less than 2. Is this true? 3 is less than 2. Not true, right? 3 is not less than 2. That means if x is less than z, x is less than z and y is greater than z, this condition is not fulfilled. Similarly, this condition will also not be fulfilled and this condition will also not be fulfilled. Only one condition will be fulfilled. So when maximum and lesser sign is there, only one condition is fulfilled. Maximum and less sign is there, only one condition is fulfilled. But when maximum and greater sign is there, a lot of conditions are there. So why I took this question, you will understand when we take the next problem. So this is the next question. X and y are two independent continuous random variable. Probability of x taking value greater than 1 by 2 is 0.3. That means what will be the probability of x taking value lesser than 1 by 2? That will be 0.7. And what will be the probability of y taking value lesser than 1 by 2? That will be 0.6. You need to find the probability such that maximum value of x comma y should be greater than 1 by 2. So here what all cases can come? Such the probability that x is greater than 1 by 2 and y is greater than 1 by 2. Say yes or no. Or probability even though x is less than 1 by 2 but y is greater than 1 by 2. Even though x is less than 1 by 2 but y is greater than 1 by 2. Let's just say y is greater than 1 by 2. That means let's just say y is 0.7 but x is 0.3. So 0.3, 0.7, what it will be? 0.7 greater than 1 by 2. Yes, 0.7 is greater than 0.5. So this will also work. So x is less than 1 by 2 but y is greater than 1 by 2. So this condition will work. Along with that, plus x is greater than 1 by 2 but y is less than 1 by 2. So these three conditions will work. Say yes or no. And both of them are independent continuous random variable. So this comma can be converted into multiplication. So what is the answer you will be getting? Probability of x greater than 1 by 2, that is 0.3. Probability of y greater than 1 by 2, y greater than 1 by 2 is 0.4 plus probability of x less than 1 by 2, 0.7 into probability of y greater than 1 by 2, 0.4 plus x greater than 1 by 2, 0.3, y less than 1 by 2, 0.6. What is the answer you are getting? 0.12 plus 0.28 plus 0.18, right? So 0.58. This was one of the way of solving this particular problem. Took a lot of time because with respect to maximum, greater sign is coming. With respect to maximum, greater sign is coming. A lot of cases are there. But with respect to maximum, if less sign comes, with respect to maximum, if less sign comes. But this is what you don't want to, this is what they are not asking. What they are asking, maximum of x comma y is greater than 1 by 2. This is what they are asking. So what I will do, can I write it down in this manner? Maximum of x comma y is less than 1 by 2. Did you? This is just a random variable, no? This is another random variable. Let's just say this was a random variable z. So if probability of z is greater than 1 by 2, so can I write it down in this manner? Probability of 1 minus z is less than 1 by 2. Because z would take a value between minus infinity to infinity only, no? This is pretty obvious. This is very simple thing. So this you already know. Now I know that with respect to maximum, if lesser sign is coming, then only one case will be there. What is that? 1 minus probability of x is less than 1 by 2 and y is also less than 1 by 2. Only one case is there. What they are saying, maximum of x comma y should be less than 1 by 2. What does that mean? That means none of them should be greater than 1 by 2. What does that mean? That x should be less than 1 by 2 and y should be less than 1 by 2. Let us say x is 0.3, y is 0.4. So maximum of 0.3 and 0.4 will be 0.4, less than 0.5. Yes, correct. Right? Are you able to understand this point? But let's just say if y was 0.6, then 0.6 less than 0.5. Not true. Are you able to understand this point? So 1 minus probability of x less than 1 by 2. X less than 1 by 2 will be 0.7 minus y less than 1 by 2 will be 0.6. 1 minus 0.58. So what do you think, which method you will follow? This or this one? Surely this one. So now what is the bottom line? With respect to maximum, always try making lesser sign. That's it. This is the bottom line. With respect to maximum, always try making lesser sign. Then without even thinking x less than 1 by 2, y less than 1 by 2. Your job is done. Here also, with respect to maximum, greater than 1 by 2 was sign there, but I made it lesser. 1 minus. Just by doing 1 minus, I can make it lesser. X less than 1 by 2, y less than 1 by 2. Your job is done. Solve this question. The same kind of concept is there. Given that minimum of x comma y is greater than z, which of the following statement is true? Just 1 second, guys. So which of the following statement is true? So here you will do it on your own and you will realize that only this case is coming. X is greater than z and y is greater than z. But here all these cases will come. So with respect to minimum, you will look for the maximum sign. With respect to minimum, you will look for the maximum sign, not for the lesser sign. With respect to minimum, you will look for the greater than sign. With respect to maximum, you will look for the lesser sign. So maximum less sign, minimum greater sign. Just I am taking one example. Let's just say I will take this case. Okay, let's say x is 3 and y is 2. So minimum of and z is 1. So minimum of 3 comma 2 should be greater than 1. What is minimum of 3 comma 2? That is 2. 2 greater than 1. Yes, this case is satisfied. But rest all the cases will not be satisfied. Take any other case. Take y equals to 1 and z equals to 2. So minimum of 3 comma 1 should be greater than z. What is the value of z? 2. So what is the minimum of 3 comma 1? That is 1. 1 is greater than 2. Not satisfied. So this case, all these will not be satisfied. But here you check any case you take. X is 1, y is 3 and z is 2. So minimum of 1 comma 3 should be less than 2. What is minimum of 1 comma 3? That is 1. 1 should be less than 2. Is this true? Yes. So that means one of them cases is coming true. X greater than z and y, sorry, x less than z and y greater than z. X less than z and y greater than z. So this case is coming true. So in the similar manner, all other cases will also come true. Okay. So here you will have to consider, if this question is coming, you will have to consider a lot of cases. But if this question is coming, you will not have to consider a lot of cases. So how will you solve this particular problem in the examination? The same kind of problem is there. What they are asking, with the minimum sign, they are asking lesser sign. So what you will do? With respect to minimum, you expect the greater sign. So probability of minimum of x comma y less than 1 by 2, this is what they are asking. That would be equivalent to 1 minus minimum of x comma y greater than 1 by 2. Probability of x is greater than 1 by 2 and y is greater than 1 by 2. All fine. Minimum of x comma y is greater than 1 by 2. That means x should also be greater than 1 by 2 and y should also be greater than 1 by 2. Because I told you with respect to minimum, I look for the greater sign. Or should I solve it first? Should I solve it in the conventional way? That how I would have thought. So what they are asking, that minimum of x comma y should be less than 1 by 2. So what I would have thought, that x is less than 1 by 2 and y is less than 1 by 2. Or let's just say x is less than 1 by 2, but y could be greater than 1 by 2 as well. Because let's just say x is 0.3 and y is 0.7. So minimum of 0.3 and 0.7, what that would be? Minimum of 0.3 and 0.7, what that would be? 0.3. Is it less than 1 by 2? Yes. So this condition will also be satisfied. Or what I could have thought, or x is greater than 1 by 2, but y is less than 1 by 2. So one of them should be lesser. This was the desirable condition, right? So x less than 1 by 2, what is the probability? 0.7. Y less than 1 by 2, what is the probability? 0.6 plus x less than 1 by 2, what is the probability? 0.7. Y greater than 1 by 2, what is the probability? 0.4. X greater than 1 by 2, what is the probability? 0.3. Y less than 1 by 2, what is the probability? 0.6. Right? 0.42, 0.28 plus 0.18. 0.88. 0.88. But what if I will solve in a smarter manner? What I would do, I know that with respect to minimum, I expect a greater sign. So I have to do 1 minus. So here what I will get, 1 minus probability of x greater than 1 by 2 and y greater than 1 by 2. So what you are getting, x greater than 1 by 2, probability of x greater than 1 by 2, which is 0.3, into probability of y greater than 1 by 2, which is 0.4. So 1 minus 0.12, that would be equals to 0.88. So with respect to minimum, lesser sign. With respect to minimum, lesser sign is not required. With respect to minimum, greater sign is required. And with respect to maximum, lesser sign is required. Okay. Based on this concept, use your whole brain and solve this particular problem. So answer also I have written. All the answers I have written. X and y are two independent random variable. X is uniformly distributed between -2 to 4. Y is uniformly distributed between -1 to 3. Capital M, it is another random variable only, and this is also a random variable only. So capital M is defined as maximum of x comma y, and small m is defined as minimum of x comma y. You need to find the following probabilities such that small m is taking value lesser than 0, capital M is taking value greater than 0, then small m is between -1 to 2, capital M is between -1 to 2, and small m is between -1 to 0, and capital M is between 0 to 2. So this question is most important. And at least everyone, if I mean something to you, if this channel means something to you, if this content means something to you, or if this gate examination means something to you, then everyone will at least spend 10 minutes here. Because I know that you guys will be doing it wrong. That I'm pretty sure. No one will do it correctly. If someone does it correctly, he will comment down that, sir, in one go I did it correctly. Because I was not able to do it in the correct manner. Although I only thought of it, but I did it correctly. Sorry, I did it wrong in the first go. So here great kind of brain will be used. Okay, a very good question. And for sure ChatGPT helped me, because I told you I took a lot of help of AI, but not ChatGPT. In just for saying ChatGPT would come, because this is the first AI tool that we are using. But actually this DeepSeek AI, this tool is very good. Okay, DeepSeek AI. So as an electronic student, you use this feature, and here it is having a feature of deep think. It is having a feature of deep think. So you can use this feature. Okay, in this AI you can use this feature, deep think. A very good tool it is. So he would give a much better answer than ChatGPT. Okay, so I take a lot of help when it comes to teaching. Like whatever the definition that I have written, what do you think? These questions that you saw, although this is a gate PYQ only, right? So what I did, I gave it the question, and then I told them that write it down in your own manner. So he wrote it down in his own manner. He framed the question as well. Because if I had directly copied the question, then some logo would come, no? So I wanted to erase the logo. So ChatGPT could do it. And if I want to frame these kind of good questions, some questions I frame on my own, but if I want to frame like this good level of problem, so what I would do, like I will talk to him. First I will be talking about this concept only. How do I verify my concept? By talking to DeepSeek, no? This is how I verify my concept. So again and again I will be talking with him about random variable, 2-dimensional random variable, sometimes this, that, uniform, Gaussian. I'll be talking about random variable. Then I'll be talking about this minimum maximum concept as well. I'll be talking about these kind of things as well. And then I will be saying him that based on whatever the conversation is there, frame some good level of problems, frame some excellent level of problem, compromising of every concept that we have just discussed, and then he will frame these kind of problems. So although these are very straightforward, but this is a very good problem. Okay, he straight away did not frame in this manner, but I modified the question, then I framed this question, then I solved it, and then I sent it to the ChatGPT, then I sent it to the DeepSeek, and then I told him what will be the answer of this one, and then we verified the answer will be 1 by 6. So just I'm telling that this is the process, this is how the teaching goes. Whatever you see on this slide, there are a lot of effort behind these slides. A lot of efforts are there. Okay, and those who put the effort, they will surely do pretty well, whether it is teaching or being a student or working in the industry. No matter wherever you go, You get into PSU, you get into masters, you get into some VLSI industry. Always remember that I need to work hard. That's it. I need to keep grinding. Always keep grinding. Okay. So as of now, you try this question. Okay. So deep think, deep seek AI. Forget about all of them. As of now, you try this question, and then we will see the solution. A, B, C, D, I guess most of you or 70% of you will be able to solve A, B, C, D, but E is the main criteria. I will take a break and then I will come back. Okay then? Yeah. So let's solve this question. Probability of M should be less than 0. In the first one, what they are asking? Probability such that small m is less than 0. What is your small m? Small m is minimum of x comma y should be less than 0. Minimum of x comma y should be less than 0. I told you one thing, whenever I see minimum, I look for the greater sign. So minimum of x comma y greater than 0, right? 1 minus minimum of x comma y greater than 0. So probability of x greater than 0 and y greater than 0, that could be written as 1 minus probability of x greater than 0 dot probability of y greater than 0. That means you would require these probabilities. And why I could convert it into dot? Because they are independent, right? So you would require the probability of x greater than 0 and y greater than 0. For that, what you will do? You will make the PDF. Can you make the PDF of random variable x and y? Surely you can make the PDF of random variable x and y. Very easily you can make the PDF of random variable x comma y, because they are uniformly distributed between -2 to 4 and -1 to 3. So -2 to 4, -1 to 3. What will be this amplitude? Since this width is 6, so this amplitude will be 1 by 6. Since this width is 4, this amplitude will be 1 by 4. So probability such that x is greater than 0. X greater than 0. This is 0. X greater than 0. So 4 into 1 by 6. That would be 2 by 3 into y greater than 0. Y greater than 0. That would be 3 by 4. So 1 minus 1 by 2. That would be 1 by 2. So answer of first one is 1 by 2. Right? B. Probability such that m is less than 0. Right? Sorry, m is greater than 0. Sorry guys. M is greater than 0. What does that mean? Probability such that maximum of x comma y is greater than 0. So with respect to maximum, I will always expect the lesser sign. So I will always expect the lesser sign. 1 minus x comma 0, y comma 0. 1 minus x comma 0 multiply with y comma 0. So x greater than 0, I have already know it is 2 by 3. So this will be 1 by 3, or from here you can say 2 into 1 by 6, that would be 1 by 3. Y less than 0, so that would be 1 by 4. So what will be the answer? 11 by 12. So what is the answer we are getting? 11 by 12. Small m is between -1 to 2. Small m is between -1 to. Just 1 second guys, just 1 second. Yeah, sorry for the interruption. So -1 to 2. So what is this? M is corresponding to minimum. With respect to minimum, I always expect the greater sign. With respect to minimum, I always expect the greater sign. So what I would do, like one possible way could be that I write down in this manner: probability of m less than 2, m less than -1. This is how I can write it down. But with respect to minimum, I always expect the greater sign. So this is something that I will not prefer. Although this is correct, m less than 2 minus m less than -1, that means you are talking about between -1 to 2. Although this is correct, but what I will be majorly interested in, I will be interested in this one: probability of m greater than -1 minus probability of m greater than 2. Greater than -1, greater than 2. So between -1 to 2 you are talking about, right? Between -1 to 2. Say yes or no. So this is what I will be interested in. Why is that so? Because now I can write down minimum of x comma y greater than -1, and I am interested more in this minus minimum of x comma y, although it is capital X comma y, capital X comma y greater than 2. Because with respect to minimum, I expect the greater sign. So probability of x greater than -1, y greater than -1, minus probability of x greater than 2, y greater than 2. So x greater than -1. x greater than minus 1. So 5 into 1 by 6 into y greater than minus 1. Y greater than minus 1 will be 1 only. Minus x greater than 2. So 2 into 1 by 6, that would be 1 by 3. Into y greater than 2. Y greater than 2 will be 1 by 4. So 5 by 6 into 1 by 12. So 10, 9 by 12. 9 by 12. So what is the answer? 3 by 4. This is the answer you are getting. Right? Answer is 3 by 4. Similarly, think about option D. Not option D. Question C. Minus 1 to 2. So minus 1 to 2. So here I am interested in maximum. This is your maximum. So with respect to maximum, I am interested in the lesser sign. So what I will do? M less than 2 minus M less than minus 1. Between minus 1 to 2, so M less than 2 minus M less than minus 1. Right? Now I can write down maximum of x comma y less than 2 minus maximum of x comma y less than minus 1. What does that mean? X less than 2 and y less than 2 minus x less than minus 1 y less than minus 1. So x less than 2, x less than 2, x less than 2. So 4 into 1 by 6, that would be 2 by 3 into y less than 2, y less than 2, y less than 2, that will be 3 into 1 by 4, that would be 3 by 4 minus x less than minus 1, x less than minus 1, that would be 1 by 6 and y less than minus 1, that would be y less than minus 1, that would be 0. So what is the answer you are getting? 1 by 2. 1 by 2 is the answer. Now the question that we are waiting for, that would come. Here answer is 1 by 2. Now minus 1 to 0, 0 to 2. Minus 1 to 0 and 0 to 2. Let me see the question again. Yeah, minus 1 to 0, 0 to 2. So let's write down what is there. Like, can you apply some trick? Like what you are understanding from here? That minimum value of x comma y should be between minus 1 to 0 and maximum value should be between 0 to 2. This is what you are understanding. So what some people can think? Probability such that minimum value is between minus 1 to 0 and maximum value is between 0 to 2. Till this point it is fine. This is fine. But can you write it down in this manner? 0 multiplied with this step is wrong. Why is that so? Because small m and capital M depends on each other. What is small m? What is small m? Minimum of x comma y. What is capital M? Minimum of x comma y. Have we done this discussion before? Did we do this discussion before or not? Yes, we have done this discussion before, no? In one of the problem, as far as I remember, it was here only, minimum maximum. Yeah, here. That capital M and small m are not independent. They are depending on each other. So if they are depending on each other, then how can you write down which step? This step. Because capital M and small m depends on each other, then simply this comma cannot be converted into multiplication. So this step is wrong. So some people would have solved in this manner, minus 1 to 0 and then 0 to 2, and they would have got some different answer. But they directly thought that they will be independent and this is how we will solve it. So they are not independent for sure. So now let's write down what does that mean. That minimum value of x comma y should be between minus 1 to 0 and maximum value of x comma y should be between 0 to 2. So let's just say I take value of x as minus 0.5 and value of y as minus 0.7. So will I satisfy my condition or not? So minimum of minus 0.5 and minus 0.7, what that would be? Minus 0.7. Is it between minus 1 to 0? Yes. So this condition is satisfied. But maximum of minus 0.5 comma minus 0.7. Maximum of minus 0.5 comma minus 0.7. What will be the maximum? 0 minus 0.5. Is it between 0 to 2? No. What does that mean? That means this possibility is not possible. What is this kind of possibility? That both x and y are between minus 1 to 0. Both x and y are between minus 1 to 0. This condition should not be there. Now let's just say I take x is 0.5 and y is 0.7. X is 0.5, y is 0.7. So maximum of 0.5 and 0.7, what that would be? 0.7. Possible, right? Correct. But minimum of 0.5 and 0.7, what that would be? 0.5. Is it between minus 1 to 0? No. That means both x and y cannot lie in this range as well, and both x and y cannot lie in this range as well. Are you able to understand this point? Right? So this condition I have taken, these two conditions. Now what I will do? I will take x equals to 0.5 and y equals to minus 0.7. So what will be minimum of 0.5 and minus 0.7? That would be minus 0.7, which is lying between minus 1 to 0. And what will be maximum of 0.5 and minus 0.7? That would be 0.5, which is lying between 0 to 2. So that means yes, this condition is true. That x is 0.5 and y is minus 0.7. That means one of them will belong to this guy and one of them will belong to this condition. I wrote it down opposite. One of them will belong to this condition and one of them will belong to this condition. You could have done the opposite as well. What do I mean? That means my x is 0.7 and y is 0.5. So again what will happen? Y is belonging here and x is belonging here. Again minimum of minus 0.7, 0.5. What that would be? Minus 0.7. That is minus 1 to 0. And maximum of minus 0.7 and 0.5. That would be 0.5. That would be between 0 to 2. So yes, this condition satisfied. This condition also satisfied. So what does that mean? What did you understand from here? From here what I understand is that it is like probability such that x is belonging between minus 1 to 0 and y is belonging between 0 to 2, or x is belonging between 0 to 2 and y is belonging between minus 1 to 0. Did you understand this point? One of them should belong to one of the condition. X belongs to minus 1 to 0, y belongs to 0 to 2. X belongs to 0 to 2 and y belongs to minus 1 to 0. So what do you understand from this particular question? That whenever you are stuck in random variable, always take the examples. In random variable, whenever you are stuck in random variable or in signal system or in general aptitude, these three subjects are same only. Okay, we needlessly think that communication system is difficult. You are studying this random variable for last 15 hours or 16 hours. Do you really think that it is difficult? No. So we needlessly make things which are simple in a complex manner. They are not complex. Communication system is aptitude only, and signal system is communication system only, and communication system is aptitude. So everything is aptitude. So whenever you are stuck in aptitude, always take the example. You will surely find some way. In probability, or in PNC, whenever you are stuck, always take some example. This is probability only, so we are taking an example. Okay, so we took the example and we got the condition. So from here what we understand, probability such that x is between, because x and y are independent now, x and y are independent. So probability that x is between minus 1 to 0, minus 1 to 0, minus 1 to 0. So 1 into 1 by 6. And y is between 1 into 1 by 6 and y is between 0 to 2. Y is between 0 to 2. 2 into 1 by 4, that would be 1 by 2. Plus x is between 0 to 2. X is between 0 to 2. 2 into 1 by 6, that would be 1 by 3. and y is between minus 1 to 0, 1 into 1 by 4, 1 by 4. So what answer you are getting? 1 by 12 plus 1 by 12, that is 1 by 6. So that's the answer. A very good question it was. Okay, well and good. So did you understand this particular lecture? So in the first 2 hours we were studying about discrete random variable to continuous, discrete to discrete transformation. Basically we were studying about random variable transformation, and then we saw some miscellaneous concept, or you can say some miscellaneous questions we saw. So this was the important problem. They were just a practice problem, but this was the important problem which can be asked in the examination, and this is one of the best question of the whole random variable, right? And along with that we saw this particular case as well, or this particular question as well, that if identical and independent random variables are given, then these kind of questions can be asked. So this was our last 1 hour. From last 1 hour, this is what we were studying, and before that we were studying about these transformations. Okay, so yeah, this is the end of this lecture. In the next lecture as well, we will see some miscellaneous concept, whatever that are left. So those miscellaneous concepts we are going to see, and with that we will be able to end our random variable. So in the next lecture, your random variable will be completed. Okay then, yeah, thank you very much. Let's meet in the next lecture. Hi everyone, welcome to PrepFusion. So in this video we are going to end our random variable. So this is the video where we will complete our random variable. So whatever those topics are left, those topics we are going to cover. Okay, so everything that is left, you can call it miscellaneous concept, or you can call it addition of random variable. Look, a lot of concept we are going to solve in this particular video. Okay, so whatever that is left, that we are going to solve. So let's just say this question is coming in your examination hall, that x is a random variable uniformly distributed between minus 2 to 2, y is a random variable uniformly distributed between minus 3 to 3, x and y are independent random variable. This is a very good information, independent random variable, and you need to find these probabilities. So can you solve this question? With respect to the concept of two-dimensional random variable, we can solve this question. With respect to lecture 3, we can solve this question. But in the lecture 3, what was given? Fx comma y, fxy, x comma y was given. That means joint PDF was given. But here there is no joint PDF. Can you find the joint PDF? Surely you can find the joint PDF. How can you find the joint PDF? Since they are independent random variables, so joint PDF would be equals to fx of x, fy of y, right? So what we will do, first we will write down fx of x. So what is our marginal PDF they have given? Fx of x. What is that? Uniformly distributed between minus 2 to 2. So what will be the amplitude? Since the length is 4, amplitude will be 1 by 4. Uniformly distributed between minus 2 to 2. And what about fy of y? Uniformly distributed between minus 3 to 3. Fy of y. Uniformly distributed between minus 3 to 3. That means amplitude will be 1 by 6. Otherwise it is 0. What you need to find? You need to find the joint PDF, because if I have the joint PDF, my job will be done. So fx comma x dot fy comma fy of y. So how will you multiply both of them? So what will happen? Amplitude to amplitude will be multiplied. So 1 by 4 will be multiplied with 1 by 6. What you answer you will be getting? 1 by 24. And what is the condition? X being from minus 2 to 2 and y being from minus 3 to 3. Basically, if your x is between minus 2 to 2 and your y is between minus 3 to 3, then you can multiply both of them. Otherwise, 0 multiplied with 0 will be 0 only. So when you can multiply both of them? When your x is between minus 2 to 2 and means intersection, or you can simply put comma, and y is between minus 3 to 3. So this is the marginal, this is the joint PDF you are having. Now you need to solve this particular question, this particular question, and this particular question. Basically, what you need to do is that you need to make the region of operation. Once you make the region of operation, your job will be done. So region of operation we need to make, that is our major target. So x plus y less than 2. First condition is that x is going between minus 2 to 2 and y is going between minus 3 to 3. So first I will make that region of operation. So x is between minus 2 to 2 and y is between minus 3 to 3. So this is my region of operation, right? And since this will be again and again used, so what I will do is that I will copy it. Now my first question says that x plus y should be less than 2, less than equals to 2. This is what my first question is saying. So what I will do? X plus y should be less than 2. Can I make the line of x plus y less than 2? Can I make the region of x plus y less than 2? Yes, surely I can make it. So x plus y equals to 2. This is the line x plus y equals to 2. So this line will pass from this particular point and this particular point, which will be x equals to 0 and y equals to 2. Now when x is equals to minus 2, y will be equals to 4. So this point will be something else. And this point when y is equals to 3, when y is equals to 3, x is equals to minus 1. So this point is when x is equals to minus 1 and y is equals to 3. So this point is minus 1 comma 3. Why I am interested in this point? Because now I need to take the strip. Because what is the region they are asking? X plus y less than equals to 2. So what I will do? I will put 0 comma 0 here. So 0 plus 0 less than equals to 2. Yes, satisfied. That means this is the region I need to work on. This particular region. Which region? This particular region. So in this region I need to work on. In this region I need to work on. Okay, so what I will do is that I will choose a strip. So if I choose this strip, let's just say I am choosing this strip. So what will happen? You will say that, sir, x is going between minus 2 to 2. If I move this strip, what will happen? X goes from minus 2 to 2, but in the vertical direction, y is going from minus 3 to 2 minus x. Y is going from minus 3 to 2 minus x. But there is an issue. If you move this strip, just as this strip reaches here, so what will happen? Y will go from minus 3 to 3. So that means you will have to break it down. What I mean to say is that if I need to solve it like this, what I will say that, sir, when your x is going between minus 2 to 2, when your x is going between minus 1 to 2, minus 1 to 2, at that time, if I choose the vertical strip, when x is going between minus 1 to 2, at that time my y is going from minus 3 to 2 minus x. Y is going from minus 3 to 2 minus x. fxy x comma y dx dy plus when my x is going from minus 2 to minus 1, when my x is going from minus 2 to minus 1, my y is going from minus 3 to plus 3. Y is going from minus 3 to plus 3. fxy x comma y dx dy. So this is how you need to break your integration, and this is how you can solve it. But if I had taken the strip here, then there would not be any issue, because in this strip you can directly see how your y is going, right? If you had taken the strip here, you can see that y is going from 2 minus x to 3 and x is going from minus 1 to 2. In this particular region, what I am doing, I am calculating the surface integration of this particular region, because what I can do is that 1 minus this area will be equals to what? This particular area. 1 minus this particular area will be equals to this particular area. This I have already told. So here what I will do, I will take this particular strip where my y is going from 2 minus x to 3. Y is going from 2 minus x to 3 and x is moving from, if you move this strip, what will happen? X moves from minus 1 to 2. X moves from minus 1 to 2. fxy x comma y dx dy. Okay. So what answer we will get? 1 minus, what is fxy dx comma dy? fxy is 1 by 24. 1 by 24 dx dy. Y moves 2 minus x to 2 minus x to 3. 2 minus x to 3. And x moves from minus 1 to 2. So 1 minus 1 by 24. 3 minus 2. This becomes 1 minus x, right? What will happen? Y will be, dy will be integrated, that will be y. So 3 minus 2 plus x. So that would be 1 plus x, not 1 minus x. 3 minus 2 plus x, so that would be 1 plus x. Dot dx. X is going from minus 1 to 2. Right? So that will be equivalent to 1 minus 1 by 24 x plus x square by 2. X plus x square by 2 minus 1 to 2. So answer will be 1 minus 1 by 24, 2 plus 2 minus minus 1 plus 1 by 2. It would be 4 plus 1 by 2. So what that would be? 9 by 2. 4.5 divided by 24. Minus 1, 1 plus 1 by 2, that would be minus 1 by 2, 4.5. So 1 minus 4.5 divided by 24. So just solve it and let me know what is the answer you are getting. Okay. So I am not having the calculator. So let me pause the video and yeah, so after the calculation 0.8125, this is the answer that is coming out. Okay, very easily you can solve it. Now these questions also you should be able to solve on your own. This you will solve on your own, and this also you will solve on your own. So what they are saying, probability of x plus 2y minus 3 should be less than 2. So this can be written in a better manner, x plus 2y less than 5. So you know that your region of operation is between minus 2 to 2, minus 3 to 3. So this is the region of operation. And what about the line? You can make the line x plus 2y equals to 5, and then you can get to know that in which region you need to perform this surface integration. So now I will write down the answer directly. All the calculation you can do on your own. So these calculation you can do on your own. So this is the line. What is this line? X plus 2y equals to 5. So what you need to make, x plus 2y should be less than 5. Should be less than 5. That means 0, 0 it will satisfy. So this is the region where you will be working. But you know that here if I take the strip, I will have to break it down into two parts. So where I will take the strip, here I will take the strip. So this strip will be going from, this strip will be going from 5 minus x divided by 2. So basically what will be your answer? Answer for x plus 2y minus 3 should be less than 2, or you can write down x plus 2y should be less than 5. That will be equivalent to 1 minus taking the strip. I will take the strip where y will go from 5 minus x divided by 2. Y is going from 5 minus x divided by 2 to y equals to 3. And where your x is going from minus 1 to 2. X is going from minus 1 to 2. Here I will write down fxy x comma y, which is 1 by 24 dx dy. So you will perform this calculation and then you will subtract it from 1. So what is the answer you will be getting? 0.90625. So all these calculation you can do on your own. I am not going to do the calculation. Basic integration we are going to solve. Like more than 20 problems I have solved for you, right? So now this I can leave up to you. And in the next one, what we need to do? X plus y, mod of x plus y is less than 2. What does that mean? How can you solve it? That means your x plus y should be between minus 2 to 2. So you need to point out the region x plus y being minus 2 to 2. So basically you need to make one equation, that is x plus y equals to 2, and other equation will be x plus y equals to minus 2. So two equations you need to make, x plus y equals to 2, x plus y equals to minus 2. And what is your region of operation? Sorry, what is your region of operation where you need to calculate the surface integration? This will be the region of operation. But I know that if I take the strip here, I will have to divide it, because here you know that in this region strip will change its value, and in this region strip will change its value. So which strips I will take? So the strip I will take will be these, this strip and this strip. So here I know that if I move it horizontally, that strip is not changing its value. Okay. So what will be my answer of probability of mod of x plus y should be less than 2? That probability is coming out to be, so we are just doing whatever that we have already studied. That would be 1 minus, here x goes from, sorry, here y goes from 2 minus x to 3. Y goes from 2 minus x to 3, and x goes from minus 1 to 2. X goes from minus 1 to 2. fxy dx dy minus, you take this strip, here your y goes from minus 3. Always I told you from lower limit to higher limit I need to write. So y goes from minus 3 to minus 2 minus x, minus 3 to minus 2 minus x, and x goes from minus 2 to plus 1. How did I get this value? I know that at this particular point y is equals to minus 3. So I will put y equals to minus 3 here. So what I will get? X equals to 1. So x goes from minus 2 to plus 1. X goes from minus 2 to plus 1. So these much integration you should know how to solve. Dx dy. When you solve it, you will get to know that this answer and this answer is coming out to be the same. Okay. So what will be the answer? 1 minus whatever we solve it, answer will come out to be 0.625. So this will be the answer. So very simply I can get these answers. Okay, very simple it is. Nothing difficult is there. Is that okay for you? So this is something that I already know. For the first 15 minutes we were solving the problem with the concept that I already know. But why I am teaching this concept again? So there is a theorem for all kind of independent random variables. Random variables has to be independent. So this is a very important for all kind of independent random variables. So let's just say I am having x1, x2, x3. All these three are independent random variables. They could be uniform, they could be Gaussian, they could be exponential, they could be anything. For example, I am taking that they are uniform. So x1, x2, x3 are my independent random variable. Now what I am doing? I am doing some operation here. I am adding up or I may subtract them as well. What I am doing? X1 plus x2 plus x3, or I can do x1 plus x2 minus x3, x1 minus x2 minus x3. All these things I am doing. And then I am defining another new random variable x. So new random variable x is x1 plus x2 plus x3. This is your new random variable x. x1 plus x2 plus x3. So what will be the PDF of a new random variable x? That will be PDF of x1 convolution with PDF of x2 convolution with PDF of x3. Are you able to understand this point? x4 could be there, x5 could be there, xn could be there. Okay, like it can be extended to xn as well. So what I will keep on doing? I will keep on doing the convolution. So this is a theorem which we might use to solve some problems. Here I would not have to do all this calculation. Very easily in a very shorter manner I can solve the problem. So what does the theorem says? The random variable should be independent. If these random variables are independent, they could be added. I will remember with respect to addition. So if these random variables are added, then their resultant PDF will be convolution of these PDFs. So let's try understanding with respect to the example. So what they have given, I will just take this question again. So this is what they have given, and in option A what they are asking. The first problem is x plus y should be less than equals to 2. This is what they are asking. So what I am saying, I am defining another random variable which is equals to z. Z is x plus y. Okay. So what they are saying, probability of z taking value lesser than equals to 2. So now if I need to find this particular thing, that means what I need to do, minus infinity to 2 fz of z into dz. Right. I am having the PDF of a random variable z, and then I can follow this particular process. Now the point is, how will I get the PDF of z? I am having z equals to x plus y. So PDF of z would be PDF of random variable x convolution with PDF of random variable y. But the point is, this will have the axis of z. Basically, if I make the fz of z, let's just say if I make fz of z, so I will make it with respect to z only, no? I will make it with respect to z only. So this will have the x-axis with respect to x. This will have the x-axis with respect to x, and this will have the x-axis with respect to y. Are you able to understand this point? What I am saying, this horizontal axis resultant will have with respect to z. Horizontal axis this will have with respect to x, and horizontal axis this will say I am having with respect to y. Basically, what I mean to say is that if I make fx of x, what I will do? What is my fx of x? So my fx of x is uniformly distributed between minus 2 to 2. So uniformly distributed between minus 2 to 2. And what is my fy of y? That is uniformly distributed between minus 3 to 3. So what I can do is that I can simply copy it here. Fy of y minus 3 to 3. And what I need to do, I need to convolve both of them. So in signal system, we used to do the convolution. Their axis used to be of time. This was also of time. This was also of time. Now I know that my resultant axis will be of z. So what I need to do? I need to change them. No, this axis should be of z only. So basically, this is not your fx of x. This is your fx of z. Nothing. I am just changing the axis. Nothing else. So here also I will write down fx of z. So whatever the PDF that you are having, you already know the PDF. Just that the random variable x will take the value small z. Random variable y will take the value small z. And if you do the convolution, the resultant would come. This will be the resultant. So resultant I have to make. I hope you know how to make the resultant of 2 square wave convolution. What is the amplitude here? 1 by 4. What is the amplitude here? 1 by 6. So lower limit added minus 5. Higher limit added plus 5. What is the minimum width? Minimum width is 4. So from minus 5 you will work for 4 minus 1. From plus 5 you will work for 4 plus 1. And then you know that what is the slope here? 1 by 4 into 1 by 6, that would be 1 by 24. This process you should know. I hope you know this process. So slope will be 1 by 24. So this will be your PDF of Z. And otherwise it is 0. Otherwise it is 0. What is the slope? 1 by 6 into 1 by 4 into 1 by 6, 1 by 24. The slope is 1 by 24. So what do you think? What will be this amplitude? This length is 4. So this amplitude has to be 1 by 6. Because 1 by 6 divided by 4 will be 1 by 24. So this amplitude is 1 by 6. So this is your Fz of Z. So this is your Fz of Z. And this is pretty obvious that if x and y are taking value between minus 2 to 2 and Z is defined as x plus 5. So what do you think? What will be the minimum value of Z? That will be here minus 2, here minus 3, minus 5. And what do you think? What will be the maximum value of Z? 2 plus 3, that would be 5. So Z will take the value between minus 5 to 5. But how it will take? So here the nature is changing, no? When we studied about linear transformation was 1 plus ax plus b. Sorry, y equals to ax plus b. Y equals to ax plus b. So here there was only one random variable. If there was x was uniform, then y will also be uniform. But now what is the scenario? Y equals to ax plus bz. This is another random variable. This is also another random variable. You are adding both of them. So if you add both of them, what you will do? You will do the convolution. Is that clear to you? All good? You are understanding this point? This was a different point. Here only one random variable was there, that was converted into another random variable. Here you are adding two random variables. Both are different cases. In this case, if x was uniform, y was also uniform. But now x and y are uniform, but z is not uniform. Z is something different. Are you able to understand this point? Okay. Now what they are asking? Probability that such that z is less than 2. So this is the point 2. So you stand here. What will be the amplitude here? So slope is 1 by 24. Here the slope will be minus 1 by 24. So 1 by 6, you are working for 1. So slope will go down by 1 by 24. Look, you can write down the equation of this line and then you can get to know what will be this point. How I am doing? What is the slope here? Minus 1 by 24, right? So here, if I work for 1, then amplitude will decay by 1 by 24. In the basics of signal system, I told you this particular concept. If you are working for 1, the amplitude should decay by 1 by 24. So what will be the answer? 3 by 24 here, 3 by 24, that means 1 by 8. So this point will be 1 by 8, right? This point is coming out to be 1 by 8. 1 by 6 minus 1 by 24, multiply by 4 here, multiply by 4 here, 3 by 24. Yeah. So this point is coming out to be 1 by 8. So what will be the probability? Probability such that z is taking value lesser than equals to 2. That will be 1 minus half into base. Base is 3 into height, that is 1 by 8. So 1 minus 3 by 16. So surely we will get the same answer only. 3 by 16. 0.8125. Was this the same answer? 0.8125. Yeah, so the answer is coming out to be 0.8125. So this is just the another way of solving the same problem. Are you able to understand this point? Here, how did we solve? Very simple. This was also very simple calculation. There was nothing difficult. X being from -2 to 2, y being from -3 to 3. What we need to do? We need to calculate the surface integration. Very easily you can do the surface integration and you can get the answer. Right? Here we build up a theorem that if two independent random variables are being added, then their resultant PDF will be convolution of the given PDFs. Convolution of the PDF X and convolution of PDF X with PDF Y. So convolution we did, and from here we solved it. Solve the next question on your own. What was B saying? Probability of x plus 2y minus 3 should be less than 2. So probability of x plus 2y should be less than 5. So what I am assuming, that z is x plus 2y. So probability of z less than 5. This is what I need to find, and that would be equals to minus infinity to 5 fz of z dot dz. Small z I am writing down, so this is how I am writing it down. Or you can write down in the same manner as well. Just for the sake of change, I am writing it down in this manner. Right, this was the question. Let me just confirm the question. Okay, yeah. Now you said that, sir, here the PDFs were x1, x2, x3. But now 2 is being multiplied. 2 is being multiplied. So what I will do, let's just say I will convert this into W. What I am given? X is uniformly distributed between -2 to 2, and Y is uniformly distributed between -3 to 3. Can you find the PDF of 2Y? What I am saying? W is equals to 2Y. Can you find the PDF of 2Y? Y equals to AX plus B. What was this? Linear transformation. I put value of B equals to 0 and value of A equals to 2. So similarly, Y equals to 2X. Here what is happening? W equals to 2Y. So what is this? Linear transformation only, no? W equals to 2Y is nothing but linear transformation. This is linear transformation, nothing but linear transformation. Are you able to understand this point? This is nothing but linear transformation. So if this is the linear transformation, what you will do? How will your W go? So W will go from uniformly distributed. If Y is equals to -3, then W will be equals to -6, and if Y is equals to +3, then W will be equals to +6. So now what is my target? My Fz of Z would be equals to Fx of X will take the value small z, and W will also take the value small z. So you need to write down, you need to make the PDF of X and you need to make the PDF of W and then convolve them. So basically my convolution theorem, this particular theorem that we studied on the first page, that would have worked if simple things were there, x1, x2, x3, simple random variable would have been there. Here I did not put down 2, or I did not multiply with anything else. So what I will do, I will convert it into this form. I will convert it into this form, x plus w, where w is equals to 2y. So can I write down the PDF of w? Yes, I can write down the PDF of w now. So my target is, I will convolve the PDF of x with the PDF of w. That's it. So I have the PDF of x as well, I have the PDF of w as well. Are you able to understand this point? What if in place of plus there was a negative sign? What if this was the scenario? What if they asked me to calculate probability of x minus 2y should be less than 5? What if this was the scenario, x minus 2y? So what I would have done, z equals to x plus w, where my w would have been equals to minus 2y. Again this is linear transformation. So where my w would go? If y is going from -3 to 3, so w will also go from -6 to 6 only. So everything would have been same, nothing different. Are you able to understand this point? Let's just say y was going from -1 to 4. Okay, uniformly PDF, uniformly distributed PDF. Okay, so where your w would go? So w would go from x equals to, if you put y equals to -1, if you put, so this will be 2, and if you put y equals to 4, this will be -8. So w would go from -8 to 2. So you will make the PDF -8 to 2, and then you will make this PDF of x that is going from -2 to 2, -2 to 2, and then you will convolve both of them. So even if there is a negative sign, you will convert it into positive only, because our theorem says that x1 plus x2 plus x3. So purely random variable, purely random variable, purely random variable, and all are added. Then what you will do, you will convolve them. So if there is a negative sign, if there is some constant factor, what you will do, you will convert it into this form, and then you will solve it. Is that okay for you? Okay, I should have picked one example, but I am not picking it up So here in brief, I have explained that even if there is a negative sign, I will convert it into the positive sign and then I will solve it. Is that okay for you? Okay, well and good. Very easily you can solve it. Now what I need to do, I need to do the convolution. So what I will do is that I will simply copy it from here. So PDF of X is not changing, but PDF of W has changed. So PDF of W is saying that I am going from -6 to 6. So what do you think, what should be this amplitude? That would be 1 by 12. So lower limit added, that means -8 to +8. Higher limit added, that would be 8. What is the minimum width? That is 4. So from -8 to -4 you will go, and from 8 to back you will come 4. What will be the slope? Slope will be 1 by 48. Slope will be 1 by 48. So since this length is 4, so what should come here? 48 divided by 4, 1 by 12. So this amplitude will be 1 by 12, because 1 by 12 divided by 4 will be equals to 1 by 48, because slope is 1 by 48, right? So this slope is 1 by 48. In signal system we study this process, okay? So that's why I'm doing it a bit in a quicker manner, because in signal system you have done enough practice. So this is the PDF of Z now. This is the PDF of Z, right? So Z less than 5, Z less than 5, Z less than 5. This is the point of 5, Z less than 5. So this area you need to calculate. So what I will do, what I need to calculate, probability of Z less than 5. And here I just need to write down, this is linear transformation. So probability of Z less than 5. So what I will do, 1 minus this particular area. What is this area now? This area is half into base into what is the height. So 1 by 12 minus the slope is 1 by 48, because if you are going ahead 1, then the amplitude will decrease by 1 by 48. So 3 by 48. So this will be 3 by 48. So answer will be 1 minus 9 by 96. So what will be the answer? 1 minus 9 by 96 minus 1. So 0.90625. Surely the answer has to be same only. Answer is coming out to be same. So just another concept I have taught, that independent random variables are given. If independent random variables are given, what you can do, you can convolve them. And if you are able to convolve them, you will get the resultant PDF. And from this resultant PDF, you can get any answer. But here, for this particular question, I need to make different PDF. For this particular question, I need to make different PDF. Now I am going to solve another one. For that particular problem as well, I will have to make a different PDF. Luckily, here I don't have to make different PDF, because x plus y only is given. So here what I need to do, x plus y is going from -2 to 2. So basically here different PDF I need to make for this one and this one. But what about this particular question? So here region of operation was this one. Here also same region of operation, just the line equation got changed. And here also same region of operation, line got changed. Right? So whatever that you are comfortable with, solve in that manner. Okay. If you are not comfortable with double integration, then why would you go here? You will directly come here, because you know how to easily convolve two particular PDF. But there is one condition for this particular concept. There is one condition. What is that condition? Very, very important. The condition is independent. If they are not independent, then you will have to go to lecture 3. So lecture 3 is not becoming irrelevant. Okay. Lecture 3 is still very much relevant. Why is that so? Because if x and y are not independent, then only lecture 3 will help you. If they are independent, then this lecture may also help you. Okay, are you able to understand this point? So lecture 3 is still relevant. If I am an educator, if I need to frame a question paper, I will surely frame the question paper in a manner that they will not be independent, so that lecture 3 becomes relevant as well. Okay, but if in the question, if they have given independent random variable, then you can do the convolution property as well. Okay, so what you will do, I have already explained. You will make another random variable, that is z equals to x plus y. Then you can understand from here that you just need to convolve the PDF of x and PDF of 2y. Okay, so after the convolution, very easily I can get the answer. Here between -2 to 2 you need to find. So what is my z? Z is equals to x plus y. Do I already know the PDF of z? Yes, right? What is my task? It should be between minus 2 to 2. So minus 2 to 2 fz of z dot dz. So z is equals to x plus y. So this process I have already done in one of the previous problems. This process have been already done in one of the previous problems. There you go. So between minus 2 to 2 they are asking. This will be minus 2. So what do you think? Whatever this area is there, this area would be the same only, no? Are you able to understand this point? So what will be your probability such that your mode of z is less than 2? That would be 1 minus whatever the area that I got here. What was this area? 3 by 16. 3 by 16. So double of this area. 2 into 3 by 16. Are you able to understand this point? This area I got as 3 by 16. This particular area was 3 by 16. And I know that now this area and this area would be the same because it is symmetric about the origin. So what you are getting? 6 by 16. 6 by 16 minus 1. 6 by 16 minus 1. So 0.625. So in this 35 minutes of discussion, what did you understand? That we already know everything, just we understood a new way of solving the problem, and that way is convolution. If two independent random variables are given, or two or more than two, if any number of independent random variables are given, then I can convolve them to find the resultant PDF. If they are in the addition, only this theorem is working for addition. If there is a negative sign in between, what I will do? I will introduce another PDF. Or if there is some constant factor is being multiplied, what I will do? I will introduce another PDF like I have done in this particular problem. Here x plus 2y was given. So I introduce another PDF, that is w. I introduce another random variable, that is w. W is equals to 2y. So I can find out the PDF of w very easily because this is linear transformation. And then I simply need to do the convolution. But now the question is, what if there were three random variables? What I mean to say is that if z was x plus w plus x plus y plus w, and x was also uniformly distributed, y was also uniformly distributed, and w was also uniformly distributed. What I am saying, find the PDF of z. X is uniformly distributed, y is uniformly distributed, and w is uniformly distributed. So you will say that, sir, it is very easy. Take the PDF of x, take the PDF of y, and take the PDF of w and convolve them. So convolving 2 square wave is easy, but convolving 3 square wave will be difficult. For convolution of 2 square wave, you know this is the answer. Very easily you can get the answer. But what if you need to convolve 3 square wave? There is no method. You have to apply the formula and it will go very difficult. You can try it on your own. Okay, there will be parabolic response. Basically, parabolic answer would come. So it is not that easy. Basically, convolving 3 square wave is not that easy. So there, what we will do, that I will tell you. But those who are having this doubt, so for them I am telling that hold on. Hold on. In this lecture only we will understand that if more than 2 random variables are coming. Here, luckily, only two random variables were given. Only 2 random variables were given. Luckily, here only 2 random variables were given, x and y. So convolution was not a difficult task for me. Convolution was not a difficult task. Here also not a difficult task, and here also not a difficult task. But more than 2, if more than 2 are given, then convolution will become a hectic task. Convolution will become difficult. There, what you will do, that I will tell you. You need to hold on. Okay. Let's go to the next concept where addition and subtraction of a Gaussian random variable would be given. So this will work for any kind of PDF. This will work for any kind of distribution. Any kind of distribution could be there. It could be Gaussian. It could be uniform. It could be Gaussian. Or it could be anything else. So this method will work for everyone. Anything else. But there is something special about Gaussian. Okay, because everywhere Gaussian will keep on coming. So there is something special about Gaussian. Gaussian will say that even if you do the linear transformation, or even if you add up some Gaussian PDFs, even if you add up some Gaussian random variables, even if you do the linear transformation, even if you add up some Gaussian random variables, my nature will not change. So with respect to Gaussian, we can take this advantage. Are you able to understand this point or not? So Gaussian will say that I will not change my nature whether you are doing the linear transformation or you are doing something else. My nature will not change. Okay. So X is a Gaussian random variable with the mean 1 and variance 4. Y is a Gaussian random variable with the mean 3 and variance 1. Right? X and Y are independent. You need to find that. And here I did not write independent random variable. Okay. Here independent word is not mentioned. Whether they are independent or they are not independent, every time, every single time, Gaussian, if Gaussians are being added or subtracted, the resultant will be Gaussian only. So this is the beauty of Gaussian PDF. In case of uniform, if you are doing the linear transformation, then the nature will not change. But if you are adding them up, then nature will change. But in case of Gaussian, here also nature will not change and here also nature will not change. Gaussian will never change its nature. Okay. And that convolution property that we studied, that is only applicable, the convolution property is only applicable for independent random variable. But here independent word is not even written. So this is a different point, okay? This is a new different point which is only for Gaussian random variable. Gaussian will say that no matter whatever you do, I will remain Gaussian only. So what you need to find? Probability of x plus x is greater than 3y by 2. Probability of x is greater than 3y by 2. So probability of 2x minus 3y should be greater than 0. Say yes or no. So what I am doing? I am defining another random variable, that is z. Z is 2x minus 3y. So probability of z greater than 0, what that would be? 0 minus mu z upon sigma z. Say yes or no. Right? Q of 0 minus mu z upon sigma z. So another random variable z I am defining. I know that x is Gaussian, x is normally distributed, y is also normally distributed. So what is the beauty of Gaussian? That z will also be Gaussian only. So what I am interested in? I am only interested in mu z and sigma z. So what will be your mu z? Mu z will be equals to 2 into mu x minus 3 into mu y. So 2 into mu x minus 3 into mu y. So 2 minus 9 will be equals to minus 7. So mu z is coming out to be minus 7. Well and good. Do I have the page? Yes, I have the page. So mu z is coming out to be minus 7. Very easily, what I did, z equals to 2x minus 3y. This is how I wrote it down. Always take all the random variables one side and all the constant value one side. Basically, let's just say if this was given x minus 3 divided by 2y by 3. This is something you need to find. So what I will do, x minus 2y by 3 greater than 3. Then 3x minus 2y greater than 9. So this is what I would have done, and here I would have put this equals to z. So always take random variable one side and constant value one side. Okay. So this is what I have done here. Yeah, so mu of z I needed to find. So 2 into 1 minus 3 into 3. So answer is minus 7. Next, what I need to find? Z equals to, again I am writing down 2x minus 3y. What I am interested in? Standard deviation, or first I will find the variance. So sigma z square would be equals to 4 into sigma x square plus 9 sigma y square minus plus 2ab. What that would be? 12 sigma xy. Do you remember this particular answer? I told you to remember this. That variance of z would be equals to 4 into variance of x plus minus 3 square, that would be 9 into variance of y minus, sorry, plus 2ab, basically this thing, y equals to, or z equals to ax plus by, z equals to ax plus by. So sigma z square was equals to a square plus sigma x square plus b square sigma y square plus 2ab sigma xy. Right? What is this sigma xy? Covariance of x comma y. Covariance of x comma y. But x and y are independent. X and y are independent. This is given in the question. X and y are independent. So if x and y are independent, what does that mean? Expectation of xy would be equals to expectation of x multiply with expectation of y. So what would be your covariance? Covariance would be expectation of xy minus expectation of x into expectation of y. This is your covariance. What that would be equals to 0. So if x and y are independent, then their covariance would be equals to 0. So this will go down to 0. So sigma z square would be equals to 4 sigma x square plus 9 sigma y square. So basically, if x and y are independent, then directly without even thinking anything, you will directly write down this particular thing. 4 sigma x square plus 9 sigma y square. You will not even write down your covariance. So 4 into sigma x square. Sigma x square is 4 and sigma y square is 1. 4 sigma y square is 1. 25. So what will be the value of sigma z? 5. No one will say, sir, it will be plus minus 5. I told you, always positive value. Sigma z standard deviation will always be equals to under root. So positive value will come. Plus minus 5 will not be the answer. Sigma z will be plus 5 only, right? So 16 plus 9 is 25. So sigma z is coming out to be plus 5. So what will be the answer? Answer of probability x is greater than 3y by 2. X is greater than 3y by 2. That would be equals to q of 0 minus mu z. Mu z is minus 7. So that would be 7 divided by sigma z. What is the value of sigma z? 5. So q of 7 by 5. That would be the answer. Okay. Well and good. So q of 1.4. This will be mentioned in the option. So beauty of Gaussian random variable, that if you add up or subtract two Gaussian random variable, resultant will also be Gaussian random variable only. So I can find its mean and variance, or you can say standard deviation, and then my job will be done. Okay, let's go to this question. X is a Gaussian random variable, y is also a Gaussian random variable. Covariance of x comma y, covariance of xy is given as 3. You need to find the probability such that x minus y is greater than 2. Mode of x minus y is greater than 2. So first thing, what do you understand from here? What do you understand? That x and y are not independent. X and y are not independent. And y are not independent. That means that convolution property, that thing will not work. But I know that if Gaussian is given, I will not even think of convolution. Gaussian means the question is very simple. If Gaussian is given, what is my task? My task is mod of z greater than 2, probability of mod of z greater than 2. That means z would be greater than 2 or less than minus 2. Z would be greater than 2 or z could be less than minus 2, right? You understand this? Mod of z is greater than 2. That means z could be mod of z greater than 2. That means 2 and minus 2. So here this condition plus minus plus. Wavy curve method we call it. So z should be less than minus 2 or z could be greater than 2. So this equation we have already solved in one of the initial lectures. Now for z greater than 2, I can easily write down the answer, but for z less than minus 2, I should convert it. So probability of z greater than 2 plus 1 minus probability of z greater than minus 2. So what will be the answer? 1 plus q 2 minus mu z upon sigma z plus q minus 2 minus mu z upon sigma z. Is that okay for you? Okay. Now what is your z? Z is actually equals to x minus y. Z is actually equals to x minus y. So what will be your mu z? Mu z will be equals to mu x minus mu y. What is my mu x? 0 minus 0. That would be equals to 0. And what would be my sigma z square? Sigma z square will be sigma x square plus sigma y square, because here minus 1 square will be plus 1 only. That's it. This is the answer. No. Minus plus 2ab. What is the value of a? 1. What is the value of b? Minus 1. 2 sigma xy. So sigma x square is 4, sigma y square is 9, minus 2, sigma xy is 3. So what is the answer? 7. Right? 9 minus 6, 3, 7. So sigma z square is 7. That means sigma z is coming out to be under root 7 and your mu z is coming out to be 0. So these are the two answers, right? So what do you see here? 1 plus mu z value is 0, 2 under root 7 plus q of minus 2 by under root 7, because mu z is 0, right? Minus 2 by under root 7. Now you solve this question, and what you saw is that this answer was not even given. Okay, sorry. This would be negative, no? This would be negative here. This would be negative. So you solve this question and this answer was not even given. So what you will do? You can convert it, right? You remember this thing. Right? So what you can do? You can convert this. This will be 1 minus q of minus 2 by under root 7 will be equals to q of x only. So what you will get? Answer could be written as 2q of 2 by under root 7. Is that okay for you or not? So this could be the answer. Very, very simple. Okay. Normally distributed, that means Gaussian. This will also be Gaussian. I defined z, then I can find its mean and variance. What was the mean? 0 minus 0, 0. What will be the variance? Variance will be sigma x square plus sigma y square, but here it is not independent. So minus 2 sigma xy will also come. 2 sigma xy is given as 3. So 4 plus 9 minus 6, that would be 7. So sigma z is under root 7, mu z is 0. What I need to find? Probability of a mode of z greater than 2. That means z could be less than minus 2 or z could be greater than 2. So this is how I can write it down. And then from there I remember the Q formula. Q of a minus mu x upon sigma x, or a minus mu z upon sigma z. So here also I did the same thing, and I know that what this will be equivalent to, this will be 1 minus q of minus x. 1 minus q of minus x is equivalent to q of x. That means 2q of 2 by under root 7. This will be my answer. Okay. Now let's see more questions. More question also we can see. I will try to frame one more problem on my own. So x is a uniformly distributed random variable with the mean 1 and variance 4. Y is a uniformly distributed random variable with the mean 2 and variance 9. And another random variable z is also given, normally distributed again with the mean 3 and variance 4. Okay. X and x, y, z are independent. What you need to find? Find the probability such that x minus 2y by 3 is greater than z plus 2. This is what you need to find. Random, anything randomly I have written down. So what did you see here? Whenever you see this question, what will come to you? Sir, great. Normally distributed. That means, sir, Gaussian. Sir, if it is Gaussian, then my job is done. The question is actually very easy. So what I would do, sir? First thing is that I will take out probability of x minus 2y. So what I need to do is that probability of 3x minus 2y is greater than 3z plus 6. Right? This will be 3x minus 2y. This 3 goes here, 3z plus 6. That would be probability of 3x minus 2y plus 3z should be greater than 6. So I will assume another random variable w greater than 6. This is what I need to find. That will be equivalent to 6 minus mu w divided by sigma w. Right? So what is my w? W bubble. Bad joke. 3 minus 2y plus 3z. 3x minus 2y plus 3z, right? So 6 minus mu w divided by sigma w. So what we are getting? Mu of w will be equals to 3 mu of x. Directly I am writing down the answer. Mu of x. What is the value of mu of x? That is 1. Minus mu of y. That is 2. Plus 3 into mu of z. That is 3. So 3 minus 4 plus 9. What is the answer you are getting? Calculation is correct. 3 minus 4 plus 9. So 9 plus 3, 12, 8. And since they are independent, x, y, z all are independent. So what will be your sigma w square? So 9 sigma x square plus 4 sigma y square plus 9 sigma z square. Right? They are independent, so nothing covariance, nothing will come. only directly 9 sigma x square plus 4 sigma y square plus 9 sigma z square. So 9 sigma x square, 9 into 4 36 plus 9 into 4 36. Here 4, 9 into 4 36, here 9 into 4 36 and here 9 into 4 36. That is 108. So sigma w square is coming out to be 108. So sigma w will be under root 108. So q of 6 minus 8 divided by under root 108. So answer is q of minus 2 divided by under root 108. This will be the answer. So here even if 2 random variable is there, 3 random variable is there, 5 random variable is there, you don't need to worry because Gaussian will result in Gaussian. This is the beauty of Gaussian. So 1, 2, 3, 4, anything is there, you don't need to worry. But in uniform, if 3 random variables will be there, then you will have to worry, right? We will surely solve a lot of question based on 3 random variables as well when uniform PDF is given. For Gaussian, it will be very easy. For Gaussian, even if 3 are given, you don't need to worry because you know that resultant of Gaussian will be Gaussian. So mu w and sigma w I need to find, my job will be done. And that I can find very easily with the previous property that I already studied. And from here I will get this answer. Is that okay for you? Very simple thing, right? Okay. This page is empty. Now x and y are two independent random variables, neither uniform nor it is Gaussian. It is exponential. Another random variable z is defined as z equals to x plus y. You need to find the probability such that z is greater than 1 and you need to find the PDF of z as well. Okay. So how will you solve it? Independent random variables are given. So if I need to solve it with the concept that I already know, with the concept of lecture 3. So if I would have solved it with respect to the concept of lecture 3, what I would have done? fxy x comma y would have been equals to fx of x dot fy of y. So what is your fx of x dot fy of y? That would be 6 into e to the power minus 2x e to the power minus 3y ux uy. Right? That means x is going from 0 to infinity and y is also going from 0 to infinity. So x and y both are going from 0 to infinity. Both are going from 0 to infinity. So I will make only this much axis. What they are asking? Probability of z greater than 1. That means probability of x plus y greater than 1. X plus y greater than 1. So this will be my x plus y. Probability of z greater than 1 would be equals to probability of x plus y greater than 1. So this will be your x plus y. X plus y greater than 1. That means this is the region of operation. Here I need to do the surface integration. But what I will do? I will calculate this surface integration and I will subtract it from 1. Right? What I will do? I will calculate this surface integration and I will subtract it from 1 because this is very easy. I can easily choose the strip here. This point is surely x equals to 1, y equals to 0, x equals to 0, y equals to 1. So what we are doing? Probability of x plus y should be greater than 1, right? So that would be equivalent to 1 minus this is your y equals to 0 and this is your y equals to 1 minus x, and x is going from 0 to 1, x is going from 0 to 1 and y is going from 0 to 1 minus x. What is fxy? That is e to the power 6 into e to the power minus 2x e to the power minus 3y dx dy. There you go. This integration will not be that easy, but it is easy only, not that difficult as well. First you need to integrate with respect to y. So what you will do? Keep x as it is. So integrate with respect to y, keep x as it is. E to the power minus 3y divided by 3. Negative sign will also be there. So what I will do? In the negative sign, I will interchange the limit. E to the power minus 3y divided by minus 3 should come. But what I did? I put 3 here and then I interchange the limit. All good? Understandable? It was going from 0 to 1 minus x, but I did 1 minus x to 0. So what we are getting? 1 minus 2, x is going from 0 to 1, x is going from 0 to 1, e to the power minus 2x, e to the power minus 2x into 1 minus e to the power 0 is 1, 1 minus e to the power minus 3 into 1 minus x. So what I will do, e to the power 3 into x minus 1, e to the power 3 into x minus 1. So this is something that I will be getting, dot dx, right? E to the power 0 is 1 minus e to the power minus 3 into 1 minus x. So e to the power minus 3 plus e to the power, okay, sorry, this will be 1 minus x. So e to the power minus 3 e to the power plus 3x, e to the power plus 3x, and this will be e to the power minus 3. This will be e to the power minus 3. So what you are getting? 1 minus 2, x goes from 0 to 1, e to the power minus 2x dot dx minus 2, x goes from 0 to 1, e to the power minus 3, e to the power 3x dot dx. E to the power 3x multiply with e to the power minus 2x, so this will become e to the power x dot dx. Dot ds, e to the power minus 3, 2 sign is already there, 2 e to the power minus 2x, yeah. So 1 minus 2 e to the power minus 2x, like this is very bad way of solving the integration, to be very honest. I could have solved it in a better manner. 1 to 0 divided by 2 minus 2 e to the power minus 3 e to the power x 0 to 1, right? Like this calculation doesn't sound like very good. 1 minus e to the power minus 1 minus 2 e to the power minus 3 e to the power 1 minus 1, right? So e to the power minus 1 minus 2 e to the power minus 2 plus 2 e to the power minus 3. Let me check if I put everything correct or not. So I will solve this and let you know the answer. Yeah, so actually a lot of mistakes were there. First thing is that here positive sign would come, okay? This positive sign would come. And secondly, one more mistake was there. Here I wrote e to the power minus 1. It would be e to the power minus 2, okay? So these two mistakes were there. This will be a positive sign and here e to the power minus 2 would come. So when you solve this one, now you are getting answer 0.3, okay? So you can solve it very easily. It's just that I am a bit tired. Since I am tired, I am not able to do the calculation in a good manner. But now answer is 0.3. So this is how I could have solved it without using the concept of convolution. But I can use the concept of convolution as well, right? Because z is equals to x plus y, x and y are independent, so I can convolve them as well. Are you able to understand this point? So what I would do, method 2, z is equals to x plus y. Yeah, now from this method I cannot get the PDF of z. Z is equals to x plus y, so I cannot get the PDF of z from this particular method. I can surely calculate the probability. Probability is coming out to be 0.3, but I cannot get the PDF of z. If I need the PDF of z, I will have to use the convolution method. Z equals to x plus y. So fz of z would be equals to fx of z convolve with fy of z. What is your fx of z? That would be equals to, in place of small x you need to put small z. So e to the power minus 2z uz, e to the power minus 2z uz. And what would be your fy of z? So 3 into e to the power minus 3z uz. Okay, 3 into e to the power minus 3z uz. 3 into e to the power minus 3z uz. So what I need to calculate? Fz of z. So that will be 3 into 2 6 into e to the power minus 2z uz convolve with e to the power minus 3z uz. So can you do the convolution? Surely you can do the convolution. 6 into, I will apply the Laplace transform. So 1 upon s plus 2 into 1 upon s plus 3. So what I will be getting, since 6 into 1 upon s plus 2 minus 1 upon s plus 3. So that will be 6 into e to the power minus 2z uz minus e to the power minus 3z uz. So this is the answer you will be getting. So what is your fz of z? fz of z is coming out to be 6 into e to the power minus 2z e to the power minus 3z uz. This is your fz of z. So this will be mentioned in one of the options. So all you need to do is the convolution. Next, what they are asking, probability of z greater than 1. Probability of z greater than 1. So z goes from 1 to infinity, 6 fz of z dot dz, because uz goes from 0 to infinity, now you are taking from 1 to infinity, right? 6 into e to the power minus 2z divided by minus 2 e to the power minus 3z divided by minus 3. But in place of putting minus sign, what I am doing, I am interchanging the limit. 1 to infinity, infinity to 1, minus sign I have eaten out just for interchanging the limit. So 6 into e to the power minus 2 divided by 2 minus e to the power minus 3 divided by 3. So that will come out to be 3 e to the power minus 2 minus 2 e to the power minus 3. So 3 e to the power minus 2 minus 2 e to the power minus 3, same thing is coming, the answer will be 0.3. So any method you can follow. If these kind of PDFs are given, exponential, I would go with this method, okay, because here very easily I can do the convolution, no? Here I would see that, okay, convolution is not that difficult, it is very easy. E to the power minus 2x, e to the power minus 3y. If I remember the formula, that formula was e to the power minus ax minus e to the power minus bx divided by a minus b. Even if you don't remember the formula, very easily with the help of Laplace transform, you can do the convolution. Once I am done with the convolution, I am having the PDF, I need to integrate from 1 to infinity, very easily I get the answer. So again, for any random PDF, this method would work. But the condition is they should be independent. If joint PDF was given, if let's just say if this particular thing was given in the question, then I would directly go with this method only, x plus y greater than 1. Why I would go with this method? Because I don't know whether x and y are independent or not. If I get the marginal PDF of x, if I get the marginal PDF of y, then I can think they are independent or not. In the question, if it is not mentioned that they are not independent, then I will go with the lecture 3 only. But if it is mentioned that they are independent, then I would go with the lecture 7. Okay. So I will write down all the summary here. So 2-dimensional random variable. If x and y are not independent, then get the joint PDF, go with lecture 3. If x and y are independent, then you can go with lecture 3 as well, and you can go with lecture 7 as well. Okay, depends on whatever you want to follow. What will happen is that if they are independent, then mostly what will be given, fx of x will be given and fy of y will be given. If x and y are independent, then these two will be given. If these two are given, then you know one thing. What is that? You can apply the convolution theorem here, or whatever you can do, just you can apply the convolution one. And here what you will do, here you can find out fxy x comma y, which will be given as fx of x dot fy of y. Then for getting some probability, for getting any random probability, what you can do, you can take the surface integration dx dy. Here you can apply the convolution, you will get the z. What you will get here, what you will get fz of, if z is equals to x plus y. Basically here you will get the PDF of z, and that PDF, from that PDF you can calculate z greater than anything. So here from the convolution also you know how we can do, from the lecture 3 also you know how to do. Okay, so whatever that is comfortable, we have solved a lot of questions as well, that whatever that is comfortable. In this particular question, I will be comfortable with the convolution one. Also, this is also very easy only, just that integration is a bit typical, nothing else. Otherwise, it is very easy. In these kind of problems, here if Gaussian is given, my job is done. Gaussian is very, very easy. In Gaussian, I will not even have to think anything else, because Gaussian will result in Gaussian only. And if these square were given, if uniform PDF were given, so if there are two uniform PDF, then I will be happy, because convolving two square wave is easy for me, and then I can get the answer. Otherwise, I can get with this option as well. I have this particular method as well. In this method, where my x goes, where my y goes, and based on that, I can get my answer. I will just make a line, I will have to make the region of operation, and then I will have to calculate surface integration, right? So another summary is there. This is one summary. Along with that, there is another summary as well. What is that summary? two-dimensional random variable. What about that x and y? Where is that gone? Yeah, this summary is also there, but that we will see later on. Okay. Before that, we need to study about central limit theorem. So this summary is clear to you. Let's study about central limit theorem. So what it is saying, if you take a large number of independent and identical random variables, independent and identically distributed random variable IIDRV, if you take, their average or sum will approximately be normally distributed no matter whatever the original distribution was. What does that mean? That means that u, v, w, x, y, z are 5 identical and independent random variables. They are uniformly distributed between 0 to 1. Now you are defining another random variable z, which is u plus 2v minus w plus x minus 2y. So since you are adding up so much of random variable, resultant will be Gaussian only. Are you able to understand this point? What I mean to say is that fz of z will be Gaussian. Or you can say that z will be normally distributed with the having mean z and variance sigma z square. So if I get more than 2 random variables, in the question if more than 2 random variables are given, then I would say that my resultant will be Gaussian only. What if in the examination they would have given this particular problem and then they would have asked you what is the probability of u plus 2v minus w plus x minus 2y greater than 1. If they are asking this question, what I would have done? I would say that, sir, my z is given as u plus 2v, u plus 2v minus w plus x minus 2y. Now, no matter whatever the PDF was there, no matter they were uniformly distributed, they were exponential or they were normal, I don't care about that. If there is anything more than 2, if you are operating with more than 2 random variables, what I would say that z would be Gaussian only. And if it is Gaussian, so probability of z greater than 1, how I can write it down? Q of 1 minus mu z divided by sigma z. So what will be my mu z? Mu z will be mu of u. What is the mu of u? From here you can tell that what will be the mean, that would be 1 by 2. And what will be the variance? What will be the variance? B minus a whole square divided by 12. So variance would be 1 by 12. You remember this formula, no? A plus b divided by 2, 0 plus 1 divided by 2, b minus a whole square, length of whole square divided by 12. So mu of z would be 1 by 2 plus 2 into 1 by 2 minus 1 by 2 plus 1 by 2 minus 2 into 1 by 2. So what is the answer you are getting? 1 by 2, right? What is the answer we are getting? 1 by 2. And what about sigma z square? They are independent, right? They are independent. Since they are independent, so what will be my answer? Sigma u square plus 4 sigma v square plus sigma w square plus sigma x square plus 4 sigma y square. So 1 by 12, 1 by 12, 1 by 12. So 1 by 12 plus 4 by 12 plus 1 by 12 plus 1 by 12 plus 4 by 12. 11 by 12. What you are getting? 11 by 12. So what is the answer you are getting? This is your sigma z square. So what will be the value of sigma z? That will be under root 11 by 12, right? So let's do it on the next page. Probability of z greater than 1, that would be equivalent to q of 1 minus mu z, 1 minus mu z, mu z is 1 by 2 divided by sigma z, that is under root 11 by 12. So what you are getting here? 11 by 12 under root and then reciprocal into 0.5. So 0.52. Now sir, I don't even know the value of q of 0.52. How will I click on the option? You know the graph of q function, no? You know the graph of q function. Q of x, the graph would go somewhat like this. This is your q of 0. Sorry, x equals to 0. This value will be 1 by 2 and this value is 1. So q of minus infinity is 1. Q of 0 is 1 by 2. So what do you think, what will be your q of 0.52? So q of 0.52 will be surely less than 1 by 2 only, no? Q of 0.52 will be less than 1 by 2. So your answer would be less than 0.5. Answer would be less than 0.5. Answer would be 0.3. So this is actually 0.3. But even if it is not given in the question, what you can do? You can think about it, no? Q function. Right? Because q of 0 I know 1 by 2. So ahead of that it will be lesser than that. So lesser option. So what did you understand? If more than 2 random variables are given, previously x plus y was given, I was putting it at z and then I was doing the convolution and everything. But if more than 2 is given, if 3, 4, 5 are given, what I would do? I would say that the resultant would be Gaussian only. If resultant is Gaussian, then only two things I need to care about, that is the mean and standard deviation, or you can say mean and variance. So I can get the mean and variance very easily. And this will work only when independent and identically distributed. IID-RV should be there. Independent and identically distributed. Okay. Now someone will have a doubt that, sir, you said that u, v, w, x, y, they are identical. I agree to this point. They are identical. But u and 2v will not be identical, no? What I mean to say is that someone will say that, sir, if u is the random variable which is uniformly distributed between 0 to 1, but 2v is the random variable which will be uniformly distributed between 0 to 2. So they are not identical. This doubt someone can have, no? That, sir, u and 2v are not identical. U and w are identical, but u and minus w are not identical. Because u and minus w, they are not identical because w is uniformly distributed between 0 to 1. So minus w will be uniformly distributed between minus 1 to 0. So they are also not identical. Yes, your doubt is true, and what you are saying, that is also true. They are not identical. And ideally this central limit theorem should not work, because statement of central limit theorem says that they should be independent and identically distributed. But even if they are not identically distributed, still this theorem works. Approximately you get the same answer only. So in worst case in the examination, if they give you more than 3 random variable, blindly apply this theorem. Okay, blindly apply this theorem. Don't even think that whether this resultant will be identical or not. Ideally, as per the statement, IID-RV is written. In every textbook you will see that independent and identically distributed, that is written. But here, needlessly, or you can say deliberately, I took the example u plus 2v. I could have taken the example in a manner u plus v plus w plus x plus y. This is how I could have taken. But I deliberately took the example of u plus 2v minus w plus x minus 2y. Because people will have the doubt that, sir, 2v u minus w minus 2y and x, they are not identical to each other. They are different. Their distribution will be different. Yeah, they are different. I know they are different, but still the central limit theorem will work. But as per the statement, they should be identical. But actually, if a lot of random variables are given, the theorem works. Okay, the theorem works. All good? All fine? Okay. So now what is the summary? Linear transformation of random variable was given. This we studied in the last lecture. Y equals to ax plus b. Nature will not change for any kind of PDF. Whether it is Gaussian, non-Gaussian, uniform, any kind of PDF is given, the nature will not change. Only thing you need to change is that from where to where it will take the value. And mean will also change. Along with that, variance will also change. Basically, if y is equals to ax plus b is given, so what will be the mean? Mean of new random variable will be a into mu x plus b, and what will be the variance? Variance will be a into sigma x square. So mean and variance will change, but the nature will remain the same. nature will remain exactly the same. Now if you are adding up or subtracting independent random variables, that means y equals to x plus z. So if it is Gaussian or non-Gaussian, in non-Gaussian nature will change, but in the Gaussian nature will not change. So y, if x is Gaussian, z is Gaussian, so y will also be Gaussian. But here you cannot comment anything about the nature. Only thing you need to comment is fx of x convolution with fz of z. But here we will not put z because resultant is y. So here you will put fx of y and fz of y. So if you do the convolution of this PDF with this PDF, you will get the resultant PDF. You cannot comment on the nature of random variable. You cannot comment on the nature of the distribution. It could be uniform, it could be triangular, it could be any other shape as well. We don't know. But if you are adding up a lot of random variables, then the resultant PDF will be Gaussian only, irrespective of the nature of x, w and z. Whatever the nature of x, w, z is given, but if a lot of random variables are being added, the resultant will be Gaussian only. Is that okay for you or not? So this is the summary of everything that we have studied. So no confusion should be there. Linear transformation is a different thing. People usually think that, sir, this is also addition of two random variable. This is not the addition of two random variable. This is a linear transformation. Only one random variable is being converted into the other one. And this is the addition of two random variables. So they are different. That's why I wrote down two things together. So they are different. Here if you are adding up two random variables, in case of Gaussian PDF, it will be Gaussian only. But in case of uniform or in case of anything else, it may change. Okay. Here I will prefer doing the convolution, because with respect to convolution, I will get very easily I can get answer very easily. What I can do for square wave, it will be very easy. Doing the convolution will be very easy, and I can get my answer. Right. Otherwise, I have another method. What is that method? Lecture 3. Right. I will get the joint PDF, and from there I will solve it. Okay. And if a lot of random variables are being added, then simply Gaussian I will apply. Okay. And these things which we already know, y equals to ax plus b. So what will be mu y? So a into mu x plus b. And what will be your sigma y square? That would be a square into sigma x square. And what about mu y here? That would be simply mu x plus mu z. But what about sigma y square? That would be sigma x square plus sigma z square. That's it. No. 2ab. 2 into value of a is 1. Value of b is 1. 2 into covariance. So covariance will also come. Covariance of x and z. So that is important. Don't forget that. But if x, z, w, u, all these are independent random variables. If they are independent, then there is no change in the mean. But here covariance term will not come. The covariance term will not come. With respect to the mean, you just need to add them up. But here in the covariance also, you will just add them up. Nothing else will come. Okay. So these things we already know. Right. Now I told you one topic was left. Continuous random variable to continuous random variable transformation only, but this time it is non-linear. So what is the relation between y and x this time? Y equals to ln x plus 1. So this is non-linear transformation, right? So what kind of graph you will get between y and x? What I am doing, I am making the graph between random variable y and x. Look, if it was y equals to ax plus b, then the PDF of y would have been also exponential only. This would also be exponential, because linear transformation does not change the nature of random variable. So this would have been also exponential only. Here this would also be exponential. But now linear transformation is not there. Right? In place of linear transformation, ln x plus 1 is there. If ln x plus 1 is there, I can draw the graph. At x equals to minus 1, it will throw minus infinity. X equals to minus 1, it will throw minus infinity. X equals to 0, it will throw ln 1, which is equals to 0, and then it will go to infinity. So this kind of graph you will get. So surely it is not linear. It will go like this. At x equals to 0, sorry, at x equals to 0, it has to be 0 only. Yeah, fine. So this kind of graph you will get. Y equals to ln x plus 1. So surely it is not linear. So how will you find the PDF of y? So one problem I will tell you how to find the PDF of y. So here what you will do, you will always start with the CDF, with the basic concept, very basic concept. You will always start with the CDF. Along with that you will make this function as well. What is this? Fx of x. Fx of x is going from 0 to infinity. Value of x is going from 0 to infinity. So x equals to 0, the value is 2, and x equals to infinity, the value will be 0. So it is going from this is the graph of fx of x going from 0 to infinity, right? Now you can see that x is taking values from 0 to infinity, and y is equals to ln x plus 1, right? So from where to where y will take the value? If you put x equals to 0 here, what will be your y minimum? What I mean to say is that what will be your y minimum? So ln, if you put x equals to 0 here, what you are getting? Ln 1, that is 0. And what will be your y maximum? Ln infinity, that would be equals to infinity only. So y will take the value from 0 to infinity as well. And you can see here, if x is taking value from 0 to infinity, then y is also taking value from 0 to infinity only. So this thing we have understood. Now let's start the solution. So PDF of y I need to find. So what I will start with? I will start with the CDF of y. CDF of a random variable y. Cumulative distribution function of a random variable y. So that would be fy of y, probability of random variable y taking value lesser than small y, right? So probability of, what is your random variable y? Random variable y is ln x plus 1. So random variable y is ln x plus 1 taking values lesser than equals to small y. So from here what you can see, x is coming out to be e to the power y minus 1. Say yes or no? Ln goes here, it becomes e to the power y minus 1. So x should be e to the power y minus 1. So probability of random variable x taking value lesser than e to the power y minus 1. So e to the power y could be here as well, e to the power y minus 1 could be here as well, it could be here as well. But think where it would be there. What I mean to say is that x should be lesser than e to the power y minus 1. That means you would say that, sir, from e to the power y minus 1, sorry, x should be lesser than e to the power y minus 1. That means what you can do, from minus infinity to e to the power y minus 1 fx of x dot dx. This is what you can do, and you will get fy of y. Basically, if I had asked you what is the probability such that x is less than 2, what you would have done? Minus infinity to 2 fx of x dot dx. So probability of x less than e to the power y minus 1. So what you would do? What you would do? From minus infinity to e to the power y minus 1 fx of x dot dx. This is what I do, right? Do you agree to this point? Now fx of x I am already having. But just think, someone can say that, sir, what if e to the power y minus 1 is here? So sir, my integration will be 0. But e to the power y minus 1, where it will be e to the power y minus 1? You think from here, no, e to the power y minus 1. It will be surely greater than 1. Sorry, it will be surely greater than 0. E to the power y minus 1. From where to where y is going? Y is going from 0 to infinity. What is the minimum value of y? That is 0. So if you put e to the power 0, 1 minus 1, 0. And if you put e to the power infinity, what that would be? Infinity. So e to the power y minus 1 will be there from 0 to infinity, considering the fact that y is going from 0 to infinity. So that means e to the power y minus 1 will be somewhere here only. So that means you need to integrate from 0 to e to the power y minus 1. Are you able to understand this point? So you will integrate from 0 to e to the power y minus 1, because before 0 everything is 0 only. Fx of x is 0 before 0. So 0 to e to the power y minus 1. What is your fx of x? Fx of x is 2 e to the power minus 2x, 2 e to the power minus 2x ux dx. So what you are getting 2 here, e to the power minus 2x divided by 2. Limit is going from e to the power y minus 1 to 0. So what you are getting 1 minus e to the power minus 2 e to the power y. This is what you are getting. So what is your fy of y is coming out to be? Fy of y is coming out to be 1 minus e to the power minus 2 e to the power y minus 1 with the condition. What is the condition? That y goes from 0 to infinity. Y goes from 0 to infinity. So this is your capital Fy of y is coming. But this is what they don't want you to find. What they want you to find? They want you to find PDF of y. So what that would be? Differentiation of CDF. So can you differentiate this? Do the differentiation on your own. I am pretty sure a lot of people will do it wrong. The differentiation of 1 will be 0 minus e to the power minus 2 e to the power y minus 1. So what is the differentiation of e to the power minus f of y? That would be e to the power minus f of y, then differentiation of f of y. So similar thing I am going to do here. I did the differentiation of e to the power minus 2 e to the power minus e to the power y minus 1. Now I will differentiate minus 2 e to the power y minus 1. Right? So this 2 comes here. So 2 e to the power minus 2 e to the power y minus 1 was already there. This 2 is coming out, minus 2 minus sign, it became plus, and then differentiation of this one will be equals to e to the power y only. So what I can write down this as 2 e to the power y. So this is the answer, 2 e to the power y, e to the power minus 2 e to the power y minus 1. So this can be written in a better manner, 2 e to the power minus 2y plus 2 plus y. So the answer is 2 e to the power minus y plus 2 with the condition that it is going from 0 to infinity. That means I will put uy here. This will be the option mentioned. This will be your fy of y. 2 e to the power minus y plus 2 uy. This is the answer you will be getting. Is that okay for you or not? So very simple process, very simple, very straightforward. I will start with the CDF because it is the non-linear transformation. I will start with the CDF. Probability of capital Y getting the value, probability of capital Y getting smaller or equal value than small y. Then I can replace capital Y with ln x plus y. From here value of x is coming out to be e to the power y minus 1. That means the integration will go from minus infinity to e to the power y minus 1. Now you know that between minus infinity to 0 everything is 0, but where e to the power y minus 1 will lie. So if y is going from 0 to infinity, so e to the power y minus 1 will lie here only. So integration will go from 0 to e to the power y minus 1 to e to the power minus 2x dot dx, 2 divided by 2 e to the power minus 2x. It is going from e to the power y minus 1 to 0. So 1 minus e to the power minus 2 e to the power y minus 1. So when I did this, what I got the answer of fy of y, which is coming out to be 1 minus e to the power minus 2 e to the power y minus 1. And then you differentiate it. If you differentiate it, what you are getting? 2 minus 2 ahead, e to the power minus 2 e to the power y minus 1 e to the power y, multiply with e to the power y. So if this goes upper side, no, blunder, big blunder from my side. What I am doing here, 2 into e to the power y was there, no, right? 2 into e to the power y. This is e to the power minus 2 e to the power minus y. So this should be the answer. That's it, nothing else. Okay, this is the answer. This is your fy of y. That's it. No more changes, right? E to the power y, e to the power minus 2 e to the power y. So no more changes. This is the answer. Okay. So in the similar manner, you try this question. I will take a break and then I will come back. You try this question on your own in the similar manner. Okay. I will take a break and I will come. Yeah. So did you try this question? Welcome back. So what we need to find? We need to find the PDF of y. First thing I will say is that x is going from 0 to 2. X is taking values between 0 to 2. So from where to where y will go? If x is equals to 0, y is equals to infinity. If x is equals to 2, y is equals to 1 by 2. So y is actually going from putting x equals to 2, y is equals to 1 by 2. And putting x equals to 0, y is equals to infinity. So y is going from 1 by 2 to infinity. Okay, very simple thing. Then I will make the PDF of x. This is how I can make the PDF of x. This is the PDF of x. Very simply I can make it. What I need to find? I need to find the PDF of y. So what I will start with? I will start with the CDF of y. CDF of y says probability of random variable y taking value lesser than equals to y. So probability of what is the random variable y? 1 by x is lesser than equals to y. What I can do? If I invert them, what will happen? X is greater than equals to 1 by y. Another thing I need to notice is that x is positive, then only I can invert them. No, if x was negative, then with respect to inversion the sign would change, and with respect to negative sign as well the sign would change. Basically x is greater than 0 and y is also greater than 0. So when I inverted it, the sign got change. This sign got change, right? Now probability of x greater than 1 by y, this is what you need to find. So what will be the answer? From 1 by y to infinity fx of x dot dx. But you know that fx of x is 0, fx of x is 0 after x greater than 2. That means here you will put from 1 by y to 2. Now where 1 by y will be there? So 1 by y will be somewhere here. Why is that so? Because what is the minimum value of y? That is 1 by 2. So that means if I put 1 by 2 here, so I will reach here. And if I put y equals to infinity here, then I will reach here. So basically 1 by y will be lying somewhere in between. What I am saying is that if y goes from 1 by 2 to infinity, then 1 by y will be going from 0 to 2. Because y is actually coming from 1 by x. So this is nothing but x only. So whenever you are solving these kind of problems, you don't need to worry that where my 1 by y will be there. 1 by y will be here or there. It will be always somewhere in between where your PDF is non-zero. Here, where was the PDF non-zero? PDF was non-zero in this particular region. So e to the power y minus 1 will be somewhere in between. So blindly you can integrate from 0 to e to the power y minus 1. So here also 1 by y will be somewhere in between. So blindly you can integrate from 1 by y to 2. So what answer you will be getting? What is the value of fx of x? That is 1 by 2. So 1 by 2 comes outside, then 2 minus 1 by y. So what is the answer we got? So fy of y we are getting as 1 minus 1 by 2y with the condition that y goes from 1 by 2 to infinity. This is your fy of y. And if I need to find the PDF, what I will do? I will differentiate the CDF. So if I am differentiating the CDF, so what is the answer you will get? 1 by 2y square, right? So 1 by 2y square from 1 by y to 0. This is the answer I will be getting. Okay, 1 minus 1 by 2y, here 1 by 2y square from 1 by 2 to infinity. All good, all fine. Very simple question, very straightforward. Just it was given. I wrote down the condition. I will always start from CDF. Along with that, I will write down from where to where the value will go. So value of y will go from 1 by 2 to infinity. 1 by 2 to infinity. Then I saw that this is how I can solve it. Then I know that probability of x greater than 1 by y, what that would be? From 1 by y to 2. From 1 by y to 2. So fx of x dot dx. From here I can get this particular thing because amplitude is 1 by 2. So 2 minus 1 by y. This is what I will be getting. And then I differentiated. I got my CD. I got my PDF. Very easily I can do it. Y equals to x square. PDF of x also you need to make. PDF of x is going from minus 1 to 1. So x is going from minus 1 to 1. So from where to where y will go? This is simple mathematics. Y will go from 0 to 1, right? If x is going from minus 1 to 1. If x goes from minus 1 to 1. X goes from minus 1 to 1. So y will go from 0 to 1. So I'm not sure about the nature. Here what was the nature? Uniform. But here what is the nature? 1 by 2y square, which is completely different, right? Here the nature was uniform. Here nature is not uniform. So here nature is uniform, but I am not sure about the nature of y. But I can tell that from where to where y will go. If x equals to -1, y will be equals to 1. If x equals to 1, y will also be equals to 1. Then what do you think? What will happen here? If x equals to 0, then y will be equals to 0. If x equals to 1 by 2, the y will be equals to 1 by 4. If x equals to -1 by 2, y will be equals to plus 1 by 4 only. So value of y will always be positive. It will be going from 0 to 1. So y goes from 0 to 1. Is that okay for you? Right? What I need to find? I need to find the PDF of y. So I will start with the CDF. CDF says probability of random variable y taking value lesser than equals to small y. What is capital Y? Capital Y is equals to x square. So x square should be lesser than equals to small y. So from here, what will be the value of x? X will be minus under root y2 plus under root y. Say yes or no. Let's just say x square should be less than equals to 1 by 2. So what will be the value of x? It will be between minus 1 by under root 2 to 1 by minus 1 by under root 2 to plus 1 by under root 2. From minus 1 by under root 2 to plus 1 by under root 2. So here as well, minus under root y2 plus under root y, right? And now you don't need to think where minus under root y will lie, where plus under root y will lie. It will surely lie in this range. That's for sure. You don't even need to think. Here will be your minus under root y, here will be your plus under root y. Just think about it. Y goes from 0 to 1. Let's just say y equals to 1 by 2. If y is equals to 1 by 2, that means minus under root y will be minus under root 1 by 2 and plus under root y will be plus under root 1 by 2. So minus under root 1 by 2 will be here, plus under root 1 by 2 will be here. So surely your minus under root y and under root y will lie in this range only. Are you able to understand this point? So that would be minus under root y2 plus under root y fx of x dot dx. That would be 1 by 2 is the amplitude that will come outside, right? 2 under root y. So answer is under root y. Okay. So your fy of y is coming out to be under root y, where y goes from 0 to 1. And if I need to calculate the PDF, what I will do? I will just differentiate it, and what is the answer I will be getting? 1 by 2 under root y with the condition that y goes from 0 to 1. This is the answer. There you go. Very simple. Like there is one particular formula as well. For this kind of question, there is a formula. People usually remember that formula. But in longer run, you will not be able to remember and you will mess it up. So forget about the formula. Go with the concept. Very simple concept. Very easily I have told you this concept. Right? And you are not going to find out this kind of concept anywhere. Okay? So better than focusing on formula, go with the concept. Right? Very easily you can get the answer. Just calculate the PDF and then you have got the CDF. From CDF to PDF, if you need to go, you need to differentiate. What will be the differentiation of under root y? That would be 1 by 2 under root y from 0 to 1. Very easily you can get the answer. Whether they are asking PDF or CDF, whatever they want to ask, you can tell the answer. Right? Let's go to the next one. Y equals to cos x and PDF of x also I need to make. So here you can see that PDF was uniform. But since this was a non-linear transformation, this was not uniform. This was something else. Right? So yeah. Let's try this one. PDF of x is between 0 to pi. Fx of x is between 0 to pi. With the amplitude of 1 by pi. Right? Y equals to cos x is given. Y equals to cos x is given. So from where to where y will go? If x equals to 0, what will be the value? Y equals to cos x. You try making the graph. Y equals to cos x. Y versus x, if I make y equals to cos x. So this is how I will get the graph. When x is equals to 0, the value is 1. When x equals to pi, the value is minus 1. So it goes from minus 1 to 1. So random variable y takes the value from minus 1 to 1. Okay. Now, what I need to find? I need to find the PDF of y. I will start with the CDF. So fy of y. So probability of y taking value lesser than equals to small y. What is y? Y is cos x lesser than equals to small y. So whenever sinusoid or cosinusoid is coming, always make the graph. Make the graph between y and x. Previously, like here in the first question, we made the graph between y and x. So whenever sinusoid or cosinusoid is coming, so always make the graph. So always prefer making the graph between y and x. So what is the relation? Y equals to cos x is the relation, right? Y equals to cos x. And x goes from 0 to pi only, so I will make the graph between 0 to pi only. That's it. I will make the graph between 0 to pi. So it will go from 1 to minus 1. 1 to minus 1. So I will make the graph between 0 to pi. From 1 to minus 1. Only this much graph I will make. So cos x should be less than equals to y. So let's just say y is equals to 1 by 2. Cos x, this is the graph of y equals to cos x. This is the graph of y equals to cos x, right? So I am taking small y equals to 1 by 2. So x should be less than equals to 1 by 2. Right? Where will be 1 by 2? This will be 1 by 2. Cos x should be less than 1 by 2, right? This is what they are saying. This is your 1 by 2. This is your 1 by 2. So if I write down x, x should be greater than equals to cos inverse 1 by 2. Say yes or no. Because if you want the lesser value, that means angle should be increased. At 0 angle, you are getting value 1. But at pi angle, you are getting value minus 1. So if you are going ahead, your value is being decreased, no? Are you able to understand this point? Look, cos x equals to 1 by 2 if I need to solve. So what will be the value of x? Cos inverse 1 by 2. Now if I ask you, cos x should be less than 1 by 2. So what will be the value of x? You know that angle will be cos inverse 1 by 2. But greater sign will come or lesser sign will come? The graph is decreasing, no? The graph is decreasing. So greater sign would come. Because you need the value lesser than 1 by 2. That means you are okay with value 1. You are okay with value minus 1 by 2. You are okay with value minus 1 as well. That means value of x should be greater than cos inverse 1 by 2. Cos inverse 1 by 2. What is this? What is this thing? This value is cos inverse 1 by 2. Cos inverse 1 by 2. So value should be greater than cos inverse 1 by 2. X should be greater than cos inverse 1 by 2. So if your x is greater than cos inverse 1 by 2, then your job will be done. So in case of decreasing graph, this sign will change. Are you able to understand this point? The same thing happened with y equals to 1 by x as well. Let's write it down in a better manner. This was cos inverse 1 by 2. Cos inverse 1 by 2. Right? So similar thing happened with 1 by x as well. So here if you make the graph of y equals to 1 by x. This is your y, this is your x. Y equals to 1 by x. So at x equals to 0, you will throw infinity value. At x equals to 2, you will throw 1 by 2 value. So this is how the graph will go. At x equals to 2, the value will be 1 by 2. So graph is decreasing. If the graph is decreasing, then what will happen here? 1 by x should be less than equals to y. So x should be greater than equals to 1 by y. So sign will always interchange. Right? Similar thing will happen here as well. So just make the graph and then you will be able to think, okay, here cosinusoid is decreasing. If cosinusoid is decreasing, that means for smaller values, I will require larger angle. So cos inverse y will show the angle only. What cos inverse y will show? Cos inverse y will show the angle. So I am sure about the angle, but now here greater sign come or lesser sign should come. So how will I think? I think, okay, cos x should be less than equals to y. That means these values I require. If these values I require, what does that mean? That angle should be larger. So x should be greater than equals to cos inverse y. And I am pretty sure that cos inverse y will lie somewhere here. So cos inverse y will lie somewhere here. So what I need to do? I need to integrate from cos inverse y to pi, right? Fx of x dot dx. Amplitude is 1 by pi, pi minus cos inverse y. So answer will be 1 minus 1 by pi cos inverse y. This is the answer with the condition that value of y goes from minus 1 to 1. Value of y goes from, or you can write down y is from minus 1 to 1. And if I need to differentiate it, so basically my fy of y is coming out to be 1 minus 1 by pi cos inverse y with the condition that y is going from minus 1 to 1. And if I need to differentiate, what I will get? If I differentiate it, so what is the differentiation of cos inverse y? That is minus 1 upon under root y square minus 1. So what answer I will be getting? 1 by pi 1 minus y square. Not under root y square minus 1, it is under root 1 minus y square. So 1 by pi under root 1 minus y square with the condition that y is going from minus 1 to 1. Well and good. So this is the answer. 1 by pi under root 1 minus y square, y going from minus 1 to 1. This will be the PDF of y. Okay. Usually they are not asking these kind of questions in the gate examination. Okay. Till this point they never asked. But if they ask, then it is a good problem. I would say it is a good question. But usually they know that people remember the formula with the help of formula they will be getting the answer. The question paper setter knows that there is some particular formula, and with the help of formula they will get the answer. Right? That formula I am not going to teach you, because that will not help you learn anything, and that will just kill the concept. So I am not going to teach that formula. I will solve the problem with this kind of formula. But a lot of problems can be wrong if you solve by the formula. This problem will be wrong if you solve by the formula. Okay. The formula has some limitation, but method will not have any limitation. So that's why I am not teaching that formula. There should be an equilibrium between formula and the concept. Where formula is required, I will teach the formula. Where concept is required, I will teach the concept only. Okay. And since this is mathematics, this is the simple aptitude. Random variable is nothing but aptitude. So not a single formula we have studied here. Although I asked you to remember that expectation of x is a plus b divided by 2, b minus a whole square divided by 12 is the variance. All these things I will ask you to remember, but minimum things are there, right? That's why I never believe in short notes or these kind of things. Now, what will you write down in the short notes of random variable? What will you write? What will you write down? Nothing you will write down, right? Everywhere problems, some concept, then problems, concept, problem. So what will you write down in the short notes of a random variable, right? Nothing you will write down. Yeah, so similar thing is there. So this is the answer. Let's try this one. This is interesting. Okay, this is more interesting. Just what I did, I changed the PDF. Now x is going from minus pi to pi. X is going from minus pi to pi. So PDF of x goes from minus pi to pi. With the amplitude of 1 by 2 pi, right? And y equals to cos x. This is what is given. Y equals to cos x. So y versus x. In case of sinusoid, I will always try making the graph. Okay. Sinusoid or cosinusoid, I will always try making the graph. X is going from minus pi to pi. So value of x is 0, then cos 1 minus pi to pi, right? Now something interesting will come. Let's try solving the problem. So CDF of y, I will start with the CDF of y. So Fy of y will be probability of a random variable y taking value lesser than equals to small y. What is random variable y? That is cos x. So cos x less than equals to y. Now what will come here? What do you think? Let's just say I again take the value of y equals to 1 by 2. Again what I am doing? I am taking y equals to 1 by 2. This is your y equals to 1 by 2. So cos x should be less than equals to 1 by 2. Cos x should be less than equals to 1 by 2. That means this will come into action. Along with that, this will also come into action. So what is this point? This point is, if I am saying that this is 1 by 2, y equals to 1 by 2 I am taking, y equals to 1 by 2 I am taking. That means cos x equals to 1 by 2. So if I am saying that this angle is cos inverse 1 by 2, then what will be this angle? Sorry, what will be this particular angle? What will be this angle? This angle will be minus cos inverse 1 by 2. Basically from here to here this length, and from here to here this length is same, no? If this is alpha, then this will be minus alpha. If this is beta, then this will be minus beta. So if this is alpha, then this will be minus alpha. Are you able to understand this point? Right? So what all things are there in your desired region? The desired region will say that you can go in this range and you can go in this range. So but our y is not 1 by 2, our y is y only. Our y is y only. So what you can see here? What you can see here? What you can see is that x can take value greater than equals to cos inverse y. This we have already seen. X can take value greater than equals to cos inverse y. Or x can take the value lesser than equals to minus cos inverse y. Did you understand this point or not? X can take value greater than equals to cos inverse y and lesser than equals to minus cos inverse y. That means let's just say this angle is minus pi by 3. So every angle lesser than minus pi by 3 will come. That means minus, let's just say this angle is minus pi by 6. Okay, this angle is minus pi by 6. That means minus pi by 3 can also come, minus pi can also come. So every angle lesser than these will come. Are you able to understand this point? So where will be your cos inverse y? Cos inverse y will be somewhere here. So this was your y actually. So cos inverse y will be somewhere here and minus cos inverse y will be somewhere here. So this will be your minus cos inverse y and this will be your cos inverse y. So probability of x greater than cos inverse y, what that would be? Pi minus cos inverse y divided by 2 pi plus probability of x less than equals to minus cos inverse y. That would be, what is this length? This length is, this particular length will be pi minus cos inverse y only. This length I am asking. What this would be, this length? Minus cos inverse y minus pi. Basically, if I ask you this length, what do? B minus a, no? This length will be b minus a. So similarly, minus cos inverse y minus of minus pi. So that will become plus. So pi minus cos inverse y, pi minus cos inverse y. There you go. Pi minus cos inverse y. Pi minus cos inverse y into 2 pi. Into 2 pi. So what you are getting? 1 minus 2 cos inverse. Basically it is same only, nothing different. 2 pi 1 minus cos inverse y by pi. Same thing we are getting, nothing different. So this is your fy of y. And from where to where y will be going? Y is actually going from 1 to minus 1 only. What is the limit of y? Y maximum value can take y. Maximum value can be taken as 1 and minimum value can be taken as minus 1. So y is actually going from minus 1 to 1 only. Right? So what you are getting? Y going from minus 1 to 1, and if you differentiate it, what you will get? 1 by pi under root y square minus 1. This is the answer you will be getting. Okay, so this is the answer we are getting. One minus cos inverse y divided by pi, 1 by pi under root y square minus 1. Oh, sorry. 1 minus y square. Really sorry guys. Differentiation will be 1 minus y square. Okay, so did you understand this concept? Although no question have been asked till this date, but even if they ask, very easily we will be able to solve. Okay, very easily we can solve these kind of problems. I don't think any other problem is there. Yeah, so that's it. So what is the concept? Concept says simply start with the CDF and you will get the answer. If linear transformation was there, we have already seen. DRV to DRV transformation, already seen. CRV to DRV, already seen. The point was CRV to CRV but non-linear. So that we have seen now. Always start with the CDF and go to the PDF. CDF, differentiate, you will get the PDF. How will you calculate the CDF? Basic formula. Basic formula. Very basic formula. Okay. Very basic question as well. Now this is a gate PYQ only, very good question. So try doing it on your own. Try doing it on your own. So U and V are two identical, two IID RV with zero mean. CDF of U and 2V are Fx and Gx respectively. Correct statement. Did you understand this point? Did you understand what question is saying? U and V are two independent and identical random variables having zero mean. So can I say my U is uniformly distributed between -1 to 1? Yes. And similarly my V will be there because they are identical and independent, zero mean. So zero mean, this will also be zero mean. So in these kind of questions, always take the example. Okay. So what they are saying, CDF of U and 2V, CDF of U and 2V are Fx and Gx respectively. U and 2V, CDF, and what they are talking about? They are talking about CDF. Can I make the PDF of U? Yes, I can surely make the PDF of U. PDF of U. So that will be between -1 to 1. -1 to 1, right? And here this amplitude will be 1 by 2. So Fu of U versus U, right? And can I make the PDF of 2V? What I am saying, another random variable I am defining as W, which is 2V. So I am making the PDF of 2V, or you can say you are making the PDF of W. So what will be the PDF of your W? That will be between -2 to 2, because if V is going from -1 to 1, then W will go from -2 to 2, because this is linear transformation. So it will go from -2 to 2. So this will be your 1 by 4. Okay. So this is the PDF of U, this is the PDF of W. But what they are talking about? They are talking about the CDF. So they are talking about Fx and Gx. So from PDF to CDF, if you need to go, what you need to do? You need to integrate the PDF. So can I make Fx? Surely I can make Fx. What I will do? I can surely make the Fx. The Fx will look something like this. What is your Fx? Fx is the CDF of U. CDF of U is Fx. So I will integrate this particular waveform. So it will start from -1, then you will get a slope of 1 by 2, and then it will become 1. This is your Fx, right? Can you make Gx as well? Surely you can make Gx as well. What is Gx? Gx is the CDF of 2V. That's why I made the PDF of 2V. If I made the PDF of 2V, now I can get the CDF. How will I get the CDF? By integrating it. So I will start from -2, it will go till +2. This is your Gx. Going from -2 to +2, and this answer is 1. Next, what we need to do? What the options are saying? Options are saying Fx minus Gx everywhere. That means you need to subtract both of them. This is for sure. Because options are saying Fx minus Gx everywhere. Everywhere they are saying Fx minus Gx. So surely you need to subtract them. So can you do the subtraction? What is the slope here? 1 by 4. What is the slope here? 1 by 2. So if you know the basics of signal system, or if you know the basics of mathematics, then you will be able to subtract it. So what will be the subtraction of Fx minus Gx? So everything will start from -2 and it will go till +2, right? So let's get started. till minus 2 everything is 0, 0 minus 0 will be 0 only. Then fx minus gx we need to do, no? Fx minus gx. Fx minus gx we need to do. So here between minus 2 to minus 1, between minus 2 to minus 1, here the slope is 0, but between minus 1 to minus 2 to minus 1, here the slope is, between minus 2 to minus 1, here the slope is 1 by 4. So 0 minus 1 by 4, the slope will be minus 1 by 4. The slope will be minus 1 by 4. The slope will be minus 1 by 4 between minus 2 to minus 1. So this slope will be minus 1 by 4. Okay, again wrong. This slope is actually positive. I need to make the negative slope. Sorry guys, I need to make the negative slope. Negative slope means this is how I will make it. Between minus 2 to minus 1. So between minus 2 to minus 1, there is a negative slope of 1 by 4. अरे क्या कर रहा हूँ यार मैं? Sorry guys, negative slope only, no? So this will be the graph. There was nothing wrong. This will be the graph, negative slope between minus 2 to minus 1. Actually, it's been like roughly around 9 a.m. in the morning and I did not sleep for the whole night. That's why it is all happening. Okay, so never try all these things. I have just built up the habit. These kind of habits I have built up, like I sleep at any random time and all these things I do, and that will hamper my health for sure. As an educator it is fine, but as a student it is not fine. Although as an educator also it is not fine, but it is what it is. I am trying to improve and surely I will improve one day. But yeah, so that's why these kind of errors are happening. 0 and here minus 1 by 4. So slope will be minus 1 by 4 here. So what will be this point? This point will be 1 by 4. So this value will be 1 by 4. And you can surely see here at minus 1 you are getting 0 and here you are getting value 1 by 4. This value will be 1 by 4 only. This value will be 1 by 4. And what do you think what this value will be? This value will be 3 by 4. This value will be 3 by 4, right? Now between minus 1 to plus 1, between minus 1 to plus 1, here the slope is half, here the slope is 1 by 4, right? Half and 1 by 4. So what will be the slope? Now the slope will become positive. Slope will become positive and the slope will be plus 1 by 4. Slope will be plus 1 by 4. So till this point you will reach, slope will be plus 1 by 4. So this point will also be plus 1 by 4. And after that between 1 to 2, here the slope is 0. What is the slope here? Slope is 0, right? And from 1 by 2 to, sorry, from 1 to 2, from 1 to 2, here the slope is 0, but here the slope is 1 by 4. So now the slope would become minus 1 by 4 again. And after that, this slope is also 0, this slope is also 0. So this is how you will get it. So this is your fx minus gx. Fx, this is the graph of fx minus gx. Right? This is the graph I have made for fx minus gx. Now if I multiply this graph with x, what is the graph of x? What is the graph of x? Y equals to x. What I am doing? I am making the graph of x versus x. Basically y equals to x, no? This axis is y. Y equals to x. This graph I am making. So what will be this graph? This graph will go like this. So if I multiply both of them, so what will happen? This is positive value, positive value. Positive value multiplied with positive value will be positive only. But this is negative value. And what is this? This is also negative value. So negative value multiplied with negative value, that will become positive. Are you able to understand this point? What is this graph? This graph is odd. And what is this graph? This graph is also odd. Odd multiplied with odd, it will become even. Odd multiplied with odd will become even. Are you able to understand this point? Or forget about odd or all these kind of things. Basically this part will be positive, positive, negative, negative. So what do you think? Fx minus gx, fx minus gx into x will be always greater than equals to 0. There you go. This is what we need to prove and we have proved it. This is the answer. So take the example and your job is done. Identical and independent random variables were given. I took the example, then they were talking about u and 2v. So I made the PDF, then I made the CDF because they are talking about CDF. So before that I know the PDF, then I made the CDF. Then I subtracted both of them and then I multiply with x, I got to know that they will always be positive. But here these options will be wrong, that fx minus gx is always greater than 0. No, sometimes it is positive, sometimes it is negative. Fx minus gx always less than 0. No, sometimes negative, sometimes positive. So this is also wrong. And fx minus gx multiply with x always less than 0. No, always greater than 0, because positive part multiply with positive part will be positive, negative part multiply with negative part will be positive. So option D is correct. Let's go to next question. So this is going to be our final question of random variable of the whole chapter of whole random variable. This is going to be our final problem, and this was asked in GATE 2014. GATE 2014. Only A, only the section A was asked. B, C, D, E I have framed on my own. Okay. So x1, x2, x3 are identically distributed random variable going from 0 to 1. And what we are asking, x1 plus x2 should be less than x3. 3-dimensional random variable is coming. 3 random variables are coming. I told you one thing, central limit theorem. If more than 2 comes, what you will think? Okay, if more than 2 are coming, then sir, I know that whatever the addition subtraction you are doing, the resultant will be Gaussian. So this is what I will be thinking, and I will be solving this problem with respect to x, y, z. So what I am saying, x equals to x1, y is equals to x2, and z is equals to x3. Okay, because we are comfortable with x, y, z. So 3 random variables are given. Let's try solving first question. So what I would have done, x plus y should be less than z. So then I will say probability of x plus y minus z should be less than 0. And now I can call it w. So probability of w less than 0, that would be equals to q of 0 minus yq, because I know that this w will be Gaussian, right? What is w? W is x plus y minus z. Since more than 2 are there, that means this will be Gaussian. Nearly Gaussian you can say, not purely Gaussian, nearly it will be Gaussian. So what will be your mu of w? Mu of w will be equals to mu of x plus mu of y minus mu of z. And from here you can see that mu is 1 by 2 and my variance is 1 by 12, right? So what you will be getting? 1 by 2 only. And what is the variance? Sigma w square. 1 by 12, 1 by 12, 1 by 12. Basically sigma x square plus sigma y square plus sigma z square. So 3 into 1 by 12, that is equals to 1 by 4. So sigma w is 1 by 2, right? So here what I need to write down, mu of w divided by sigma w, q of 0 minus mu of w. What is the value of mu of w? That is 1 by 2 divided by what is the value of sigma w? That is also 1 by 2. Answer is coming out to be q of minus 1. q of minus 1. ये क्या दिक्कत हो गई भाई? q of minus 1. Z is less than 0 or Z greater than 0? What did they ask? I guess it was greater than 0. Let me check the question again. I guess here it was greater, okay? As far as I remember, this sign should be greater. कहाँ गया भाई? Lesser only, but the answer is coming out to be q of minus 1. The answer is correct only, right? Here in this book it is given wrong. Okay, I am having the book of some particular publication. It is given wrong here. Q of minus 1 answer is coming, no? Yeah. Now the point is this question was integer type and you don't know the value of Q of minus 1. Although I ask two values to remember every time. Look, I have asked you to remember Q of 0, that is 1 by 2. I have asked you to remember Q of infinity, that is 0, and Q of minus infinity, that is 1. So can you remember two more values for me? Two more values. A lot of time Q of 1 will also come, okay? And a lot of time Q of minus 1 will also come. Just let me know which one will be larger. And if you know the value of 1, then you can tell the value of other one as well, right? What I mean to say, Q of 1 plus Q of minus 1 will be equals to 1. Q of 1 plus Q of minus x will be equals to 1. So just let me know which guy will be larger, Q of minus 1 or Q of 1. Q of minus 1 will be larger because the graph goes like this. So Q of minus 1 will be larger than Q of 1. So Q of minus 1 is, and surely it will be greater than 0.5. So it is 0.84 and this is 0.16. Okay. So if you want to remember, you can remember it. Q of minus 1 is 0.84. But as of now, I will consider that I don't remember the value of Q of minus 1. So now I am stuck. What I will do? And everywhere in all the questions, the value of Q function will be required. No matter whatever the problem you are solving, here the value of Q function will be required. That we don't remember, right? So now we need to solve the problem. How we will solve it? So for that we will use the concept of three-dimensional random variable. So the way we used to solve the problem in 2 dimension, in the similar manner we are going to solve in the 3 dimension. So can you define fx of x, can you define fy of y, and can you define fz of z? Surely I can define. All are identical and independent. So fx of x, what is fx of x? 1 by 2 between 0 to 1. 1 by 2 between 0 to 1, otherwise it is 0. What will be your fy of y? That will also be 1 by 2 between 0 to 1, 0 otherwise. And what will be your fz of z? That will also be 1 by 2 between 0 to 1, 0 otherwise. Okay. What we need to find? This we need to find. Joint PDF, right? Joint PDF we need to find. And what I know, x, y, z are independent. And if they are independent, that means fx of x, fy of y dot fz of z. Similar process we are following, ditto similar process. So what will be the answer? When they are non-zero, 1 by 2, 1 by 2, 1 by 2, amplitude will be multiplied. What is the answer you will be getting? 1 by 8. With the range x being between 0 to 1, y being between 0 to 1, and z being between 0 to 1. 0 otherwise. So this is my joint PDF. Okay. So what do you know? X is going from 0 to 1, y is going from 0 to 1, and z is going from 0 to 1. So previously what we used to do, I only used to make two axes, x and y, but now I need to introduce z as well. So here I am making x, here I am making y, and here I am making z. X goes from 0 to 1, x goes from 0 to 1, y goes from 0 to 1, and z goes from 0 to 1. So in this region they are going. Basically, if I forget about y, that means x is going from 0 to 1 and z is going from 0 to 1. So this will be the region. Say yes or no. Do you agree to this point or not? If I forget about y completely, that means I am only working on xz plane. So x goes from 0 to 1 and z goes from 0 to 1. And in this plane, everywhere x and z will be between 0 to 1 only. Are you able to understand this point? Or you forget about z. So x goes from 0 to 1 and y goes from 0 to 1. So this is how we used to make our region of working. Now forget about x. So z will go from 0 to 1 and y will go from 0 to 1. So this will be your region of working. So basically in 2 dimension, what you used to get? In 2 dimension, you used to get a surface. Now you will get a volume. In 3 dimension, you will get a volume. So you are getting a cube. Basically in this cube, x, y, z will be between 0 to 1 only. I am saying that this coordinate is x equals to 0, sorry, x equals to 1, y equals to 0 and z equals to 0. This coordinate is x equals to 0, y equals to 0, z equals to 1. This coordinate is x equals to 0, y equals to 1, z equals to 0. What will be this coordinate? Here z and y are non-zero, x is equals to 0. What will be this coordinate? So in this manner you can tell the coordinate. What will be this coordinate? This coordinate will be 0, 0. Now what will be this coordinate? Here your x and z are non-zero but y is 0. So 1, 0, 1. So in that manner you can tell all the coordinates. Is that clear to you or not? So I am just removing some coordinates. I am just telling that this is how we can tell the coordinates. Right? Now what they are asking? Probability of x plus y less than z. So there what used to happen? Probability of, let's just say, x plus y less than 2. So what we used to do? We used to make the line of x plus y equals to 2 like this. X plus y, let's just say it was 1. So we used to make the line of x plus y equals to 1. This was the line of x plus y equals to 1 and then we find the region of operation. So here what is the scenario? Probability of x plus y less than z. This is what we need to find. Probability of x plus y less than z. This is what we need to find. So here what I will make, x plus y equals to z. So now this will represent a plane. Okay, what this will represent? This will represent a plane. In the previous video I said that x equals to y equals to z, this will represent a plane, but that was wrong. This will represent a line actually. Okay, this is nothing but a line. Okay, but x plus y equals to z. What is the equation of a plane? Equation of a plane is ax plus by plus cz is equals to d. This is the equation of a plane. So this will represent a plane. X plus y equals to z. This will represent a plane. How will you draw this plane? So randomly you have to take coordinates. What I mean to say is that if I say my x is 1, y is 0 and z equals to 1, will this satisfy this plane? Yes. This point will satisfy this plane 1, 0, 1. 1, 0, 1. Where will be 1, 0, 1? X is 1, y is 0 and z is 1. This will be the point 1, 0, 1. This point will be there 1, 0, 1. So I have to take those points which will satisfy this equation of plane, nothing else. What I am saying, I am taking those points which will satisfy this equation of plane, considering the fact that x, y, z all are between 0 to 1 only. X, y, z are between 0 to 1 only. So I have to take the values in a manner that everything lies between 0 to 1 only. Are you able to understand this point? To make a line, how many points you require? If I give you 2 points and I ask you draw a line which is passing through these 2 points, then only you can draw only one line. Similarly, to make a plane, how many points you will require? 3 points. So what I am doing, I am thinking of 3 points. That is, first one is 1, 0, 1. What could be the second one? Second one could be x is 0, y is 1 and z is 1. Here x is 0, y is 1 and z is 1. 2 points. Both of the points will lie on this plane. Let's think about third plane. Let's think about third point. Third point. 1 point I have made, second point I have made, and third point I need to think. I cannot take 1, 1, 0. I cannot take 1, 1, 0. That would be wrong, right? 1, 1, 0 would be wrong. So what I will take? And it should be between 0 to 1. So what point I can take? I can take x equals to 0, y equals to 0 and z equals to 0. X equals to 0, y equals to 0, z equals to 0. So 0, 0, 0. So you have got 3 points. What you need to do? You need to join them. Join all of them. This is joined with this one, this is joined with this one, and this is joined with this one. So basically this is the plane. This is the plane of x plus y equals to z. This is the plane of x plus y equals to z. X plus y equals to z. This is the plane of x plus y equals to z. Are you able to understand this point? Surely you are able to understand this point. But now what is our concern? Our concern is I need to make x plus y less than z. So let's check this point. Will this point satisfy our condition or not? Because here what will happen, either this region will be into action, not region, either this volume will be in action or this volume will be in action, because this is a plane, no, lesser than this or greater than this. This is not a line, this is a plane, lesser than this, that means all these volume will come into action, and greater than this, that means all these volume will come into action. So now the volume will come into action. So x plus y less than z. So here the value of x is 0, value of y is 0, the value of z is 1. So 0 less than 1, yes. That means this region will come into action. Sorry, this volume will come into action. So now I need to calculate the volume integration here. Are you able to understand this point or not? This is the volume integration that we need to calculate. So this will be our answer. Our answer of x plus y less than z will be this volume integration. So what will be the answer? Similarly, in the similar manner, the way we used to solve 2-dimensional random variable, in the same manner we are solving this 3-dimensional random variable. Probability of x plus y less than z. Probability of x plus y less than z. There will be some particular volume v, fx y z, x comma y comma z, dx dy dz. What is the value of this? That is 1 by 8, constant value. And you need to calculate the volume integration of dx dy dz. Basically you need to take the volume. So what will be the volume of this particular scenario? What will be the volume of this much? What that volume will be? So that volume, what is this? This is a pyramid. Okay, so that volume will be 1 by 3 into area of base, 1 by 3 into area of base into height. So you will remember this. In aptitude also we studied. So 1 by 3 into area of base. What will be the area of base? Half into base into height. Into height. Height is 1. So what is the answer you are getting? 1 by 6. Is that okay for you? Just 1 second, guys. Yeah, so what is the area you are getting? That is 1 by 6. And really sorry guys, a big blunder, like a senseless mistake. Very senseless mistake, right? What will be the amplitude? Amplitude will be 1 only, no? So you should always slip. What is the conclusion? You should always maintain your slip cycle, right? If you don't maintain your slip cycle, then you will write down, if x is between 0 to 1, then your value of PDF, your amplitude of PDF will be half. A big blunder from my side, right? 1 into 1 into 1, that will be 1 only. So yeah, really sorry for this kind of mistake. Like this will just, like, those who have been following, like they would think what he is doing. I'm really sorry for that. Like some people might have wasted their 10 to 15 minutes thinking about what he is doing. But till this point you should be confident enough, right? Here 1 by 2 should not come, 1 should come. So he is doing some blunder which he will modify later on, right? And really sorry for this mistake. Okay, these things should not have happened. So this 1 by 8 will not come, this will be 1 only. Yeah, so now you tell. So this was our region of, I should not say region of operation, this was our volume of operation, right? In this particular volume, we need to tell the volume. That volume was 1 by 3 into area of base into height. Area of base is half into base into height. Area of base, what is the base? Base is triangle, no? Base is the triangle. Base is triangle. So what is the area of this base? That is half. And what is the height? This is the height. Height is 1. So what is the volume you are getting? 1 by 6. So what will be your answer? Answer is 1 by 6. Okay. So probability of x plus y less than z is coming out to be 1 by 6 only. So actually it is given correctly in the book. What we are doing wrong here? What mistake we are doing here? Okay. Sorry guys. W less than 0, right? Again there is a mistake. Too many mistake in this video. 1 minus. We remember the formula for W greater than 0, no? We remember the formula for W greater than 0. Too many mistakes are there. In this video, too many mistakes are there. Okay. So we remember the formula for W greater than 0, right? So 1 minus 1 by 2, 1 by 2. So this will be equivalent to Q of 1. I remember the value of Q of 1, that is 0.16. And if you solve 1 by 6, 1 by 6, this is exact answer, and this is approximated answer. Q of 1 is approximated answer and 1 by 6 is the exact answer. So what is the answer you are getting? 0.167. 1 by 6 is 0.167. Okay, so yeah, both answer would be correct, but you will not know the value of q of 1. If you know the value of q of 1, then your job is done. Now just for the practice purpose, you solve this question as well, this question as well, this question as well, this question as well. You know one thing, that our value of x, y, z will be going from 0 to 1, 0 to 1. So again and again you will be getting the same cube. This cube you will be getting everywhere, just this plane will change. This particular plane will change. So what is the next question? The next question says probability of x plus y plus z should be taking the value lesser than 1. X plus y plus z taking the value lesser than equals to 1. What does that mean? That means my target would be to get this plane and then the volume, right? And I know that I need to add pages. What I know? Okay, just wait a second guys, this is lagging. Okay, now not lagging. Yeah, so this plane will not come into action, so let's remove this plane. Let's remove these lines as well. Yeah, so x is going between 0 to 1, y is going between 0 to 1, and z is going between 0 to 1. X, Y, Z. All fine? Okay, all good. Yeah, now x plus y plus z should be less than equals to 1. This is our target. X plus y plus z should be less than equals to 1. This is our target, right? So what I will make, x plus y plus z equals to 1. This plane I will be making. So what all things I can put? X equals to 1, y equals to 0, z equals to 0. X equals to 0, y equals to 1, z equals to 0. And x equals to 0, y equals to 0, z equals to 1. So these 3 points I can put 1 0 0, 0 1 0 and 0 0 1, and I just need to join these points. This is joined from here and this is joined from here. So I have joined these points. What you are getting? This is the plane that you are getting. This is the plane that you are getting. Are you able to visualize this plane? In 3D, are you able to visualize? This is the plane of x plus y plus z equals to 1. X plus y plus z equals to 1. This is the plane of x plus y equals to x plus y plus z equals to 1. What they are asking, x plus y plus z should be less than 1. So from this plane, either the downward region or the upward region, not the region, volume. So from this plane, either the downward volume or the upward volume will come into action. So which volume will come into action? What do you think? The downward volume will come into action, right? Why is that so? Because from this plane at the downward there is 0, 0, 0 point, no? So if you put 0, 0, 0 here, what you will be getting? 0 plus 0 plus 0 less than 1. Yes, satisfied. That means whatever the region that you are getting downward, that will come into action. So which region will come into action? Can you mark it? This thing, and this. This is the region downward. This is the region that is coming into action. Are you able to see it? Right? So probability of x plus y plus z less than 1. What that would be equivalent to? F x comma y comma z, x comma y comma z, dx dy dz with volume 1. So this value I know already 1. So dx dy dz. Isn't it again the pyramid only, right? It is the same structure. Say yes or no. So what will be the answer? 1 by 3 into area of base. You see the base. What is the base? Triangular base is there. This is the length, this is the height. So what will be the area? Half. Into what is the height here? That is 1. So what is the answer? 1 by 6. Like, are you able to visualize the volume? The volume will be again pyramid only. And what is the volume of a pyramid? 1 by 3 into area of base into height. 1 by 3 into area of base into height. So what is the area of base? Into height. Area of base into height. What is the area of base? Half. 1 by 3 already there, height is 1. So this is what you are getting, answer is 1 by 6. Try doing the next one on your own. Here I should have copied this diagram, but again we will have to draw the diagram. So for the answer of next one is 1 by 6. For the answer of this one is 1 by 6. For the answer of this one was 1 by 6. What do you think? What will be the answer of this one? But let me know what will be the answer of these two. Probability of x1 plus x2 plus x3 should be lesser than 3. Look, you just let me know what will be the minimum value of x1 plus x2 plus x3. I don't know what kind of a nature will be there. It will be nearly Gaussian, I know that. But forget about the nature. You just let me know what will be the minimum value and what will be the maximum value. What will be the minimum value of x1 plus x2 plus x3 and what will be the maximum value. So minimum value will be 0 plus 0 plus 0, 0. And what will be the maximum value? 1 plus 1 plus 1. That would be 3. 0 plus 0 plus 0, 0. 1 plus 1 plus 1, 1, that would be 3. So between 0 to 3 it would be there. And they are saying that value of x1 plus x2 plus x3. That means x1 plus x2 plus x3 should take value lesser than equals to 3, which is pretty obvious. 100% they will take the value lesser than 3. And 0% they will take the value lesser than 0 because they cannot take the value lesser than 0. So here the probability will be 0, here the probability will be 1. So you don't need to make any diagram or anything like that. Are you able to understand this point or not? x1 plus x2 plus x3 should be less than 3, which is pretty obvious. They will take the value lesser than 3 and they will never take the value lesser than 0. Now only concern is x1 plus x2 plus x3 less than equals to 2. So do it now. x1 plus x3, sorry, x1 plus x2 plus x3, that means x plus y plus z, x plus y plus z less than equals to 2. So again, let's copy the diagram. हो जा भाई copy. Yeah. So diagram is copied. Let's keep these points as it is. So first I will only make this cube. Now what is my target? I need to make this plane x plus y plus z is equals to 2. This plane I need to make, right? So what points I can put? X equals to 0, sorry, x equals to 1, y equals to 0 and z equals to 1, 1 0 1. I can put x equals to 0, y and z 1 1, and next I can put x equals to 1, y equals to 1, but z equals to 0. That means this point I can put. Which point I can put? This point I can put. X equals to 1, y equals to 1 and z equals to 0, because 1 plus 0 will be equals to 2. So these points I can put, and then I need to join these points. So this point will be joined with this one and this point will be joined with this one. Now you need to take the region of operation. So what do you think? What will be your region, not region of operation, again I am saying the region. What will be your volume of operation? So what will be the volume you will be working in? So what they are asking? Just 1 second guys. Yeah, so what I was saying, yeah, now I need to see the volume. So this is the plane that I have made. What is this plane? This plane is x plus y plus z is equals to 2. Okay. Now I will put this point 0 comma 0 because this is the plane here. 0 comma 0 will be lying here and other points will be here. So I will put 0 comma 0 comma 0 and I will check whether this will come into action or not. So 0 plus 0 plus 0. So 0 less than 2. Yes, satisfied. That means my region of working will be downward. This will be my region of working, right? All this will be my region of working. This will also come into my region of working. That will be downward. This will be the region of working which is downward. Are you able to understand this point? Downward region is coming, right? But the downward region is not a pyramid. You don't know the volume of the downward region. I don't know. I don't know the volume of downward region. But in the upward volume, what I can see, I am getting a pyramid here. I am getting a pyramid here. So this volume I know. Upward region volume I know. Downward I don't know. But one thing I am pretty sure that if I need to calculate this particular thing, whatever the desired volume is there, that I need to calculate. So basically I just need to calculate the volume. My target is to calculate the volume. So what will be my volume? 1 minus the volume of this pyramid. Are you able to understand this point? The whole volume will be 1. The whole volume will be 1. But now what I will do is that from 1 I will subtract the volume of this pyramid and I will get my answer. What is the volume of this pyramid? That is 1 by 3 into area of base. What will be the area of base? Half into height. So 1 minus 1 by 6, answer will be 5 by 6. This is the answer. Did you understand this point or not? So answer will be 5 by 6. So only question that I wanted to solve on 3-dimensional random variable will be this one. If again they repeat 3-dimensional random variable, then believe me, they will ask this kind of problem only. So very simple. Whatever you used to do in the 2-dimension, same thing you need to do in 3-dimension. If the value of q are mentioned, then your answer will be very easy. If q function is mentioned, if the value of q function is mentioned, then don't even worry. Don't worry about anything. Just go with the theorem that we studied, that if you add up more than 2 random variables, if you add up or subtract more than 2 random variables, then resultant will be Gaussian only. And with respect to that, you can get the answer. If q value is not mentioned, then you will have to go to 3-dimensional random variable. Fx of x, fy of y, fz of z is given. You can get fxyz. From there, you can make these diagrams and solve the problem. X plus y less than z. I told you how to make the plane. What you will do? First, you will make the plane by taking up the points. Then you will join all the points. Then you will get the equation of plane. Then you need to see greater than or lesser than. Based on that, you will get your answer. Right? This was the question. This was the problem. And then this was the problem. Right? All good. All fine. Now there is something called binomial distribution and Poisson distribution. So if you solve the PYQs, the questions can be found on Poisson and binomial. But as of now, we did not study Poisson distribution and binomial distribution. That we will study when we study about information theory. Along with that, you can study it in the engineering mathematics as well. Okay. These are not important because we study it again and again. Like when information theory will come, I will again teach it. When engineering mathematics would come, there also I will again teach it. So yeah, we study Poisson and binomial again and again. So that's why we are avoiding studying Poisson and binomial as of now. Okay. So yeah, now you can solve the PYQs of random variable, or if you want to hold, you can hold as well. You can solve the PYQs after random process. Okay. So I would suggest that you hold as of now. You revise the notes, you revise the concept, and once you are done with random process, after that you can solve the PYQs of random variable as well and random process as well. Along with like together you can solve the PYQs. All good, all fine. Okay. So you can avoid the PYQs of Poisson's distribution and binomial distribution. Okay. So yeah, that's it. So everything we have seen about random variables. I hope you enjoyed the complete chapter of random variable. In the similar manner, you are going to enjoy random process as well. Okay. So if you enjoyed it, you will comment down and you will let me know how did you find it. Thank you very much.